Welcome to our course on Spring Integration. Within this course, we will focus on the purpose of the Spring Integration Framework, we'll learn key framework concepts, and we'll take a deep hands-on look at how to use the framework. For those of you unfamiliar with Spring Integration, it's another tool within the Spring ecosystem designed to support enterprise integration patterns. So we're talking about exchanging information between systems. Information exchanges between systems are a common requirement, and it's rapidly increasing within our field. The rise of APIs have really propelled forward this idea of exchanging information between systems. While APIs may be the standard, it's not a guarantee that it will be the approach required for integrating every system. Often systems use traditional web services, file transfers, and database sharing to exchange information. In many cases, you are not able to dictate how information is exchanged, and you're often prescribed an approach by the data owner. Spring Integration provides a solution to abstract the exchange of information between systems through the use of trusted enterprise integration patterns. The implementation of these patterns provided to you by Spring Integration will make your applications more robust, flexible, and consistent. Consistency is very important, because it prevents Frankenstein applications that leverage various integration techniques with a rigid implementation. Spring Integration abstracts the integration technique behind its messaging system, allowing for the exchange of information between systems to easily transition to a better format. There are three main parts to this course that we'll cover. The first part of the course will cover the basics of Spring Integration. You will learn the key concepts underlying the project and learn the basics of setting up a project. From there, we'll cover the messaging architecture. The messaging system within Spring Integration provides a lightweight approach to exchanging messages between application components. We'll see how Spring Integration applications can use the messaging system to exchange data in a flexible manner that is easily adjusted for changes in our applications. The final part of this course will cover integrating with external systems. So this is when our application reaches out to some other source. We'll learn how to use a set of components provided by Spring Integration that allows our application to exchange information via the file system, FTP, JDBC, and HTTP. These components will interface with the messaging system that we'll explore within the earlier lessons in the course. Together, the messaging architecture, as well as the integration components, will form our Spring Integration application, a very cohesive, predictable application capable of exchanging data with an external system. I'm sure you're excited to get started within the course, but there's a few things that you need to know in advance in order to ensure that you will be successful. There's only two items. The first thing, you should have a very good understanding of Java because Spring is a Java framework and Spring Integration uses Java. You should also understand the Spring Core. Spring Core will form the foundation that Spring Integration is built on top of. If you're familiar with these two technologies, this course is for you. And it's going to unlock how you work with exchanging information between systems and really improve that aspect of your applications. In this chapter, we'll introduce enterprise integration and Spring Integration. Our discussion will focus on why these technologies exist, what they attempt to achieve, and how they are implemented. So let's take a closer look at this chapter. It is important to understand the problem we are trying to solve with enterprise integration. We'll discuss the original problems that created the need for enterprise integration solutions. Most of our discussions will be rooted in the concepts expressed in Hope and Wolf's book, Enterprise Integration Patterns. This book serves as the motivation for the Spring Integration Framework, and many of the concepts we see within that book are supported by Spring Integration, so it's a very important reference for us. Once we have a better understanding of enterprise integration, we'll turn our attention to Spring Integration to see how it facilitates integration of applications. We'll explore the core concepts and the goals of the project. Then we'll start to take a look at how Spring Integration works. We'll take a deep look at some of the core components, so endpoints, channels, and messages, and how they are constructed to work together as part of a messaging architecture. Then we will install the STS IDE, which is the development environment we'll be using throughout the course to build Spring integration projects. Finally, we'll take a look at a very simple Spring integration project, and we'll see how the different components are used to build a project, and then how they enable the flexible architectures we need to have successful integration between applications and within our applications. So that wraps up our overview. Let's get started with the chapter. Before we dive deeper on Spring integration, I just want to cover some of the building blocks of enterprise integration. So to start out, when we look at most enterprises and inspect their IT infrastructure, we find that business processes span multiple systems that are constructed using a variety of technologies. You may see different languages, you may see different COTS products, and all of these technologies need to talk to each other in order to satisfy business requirements. You'll often see these systems interacting and sharing information. Sometimes what appears to be a simple transaction within one system may actually be an orchestrated set of operations that occur behind the scenes in many other systems. This is where we see enterprise integration in action. So let's talk through a simple example. Think of your favorite e-commerce system. And now let's think about all of the different systems that need to interact. You may visit the web interface of some company and order an item, but really there are a multitude of systems behind the scenes working in tandem in order to complete that business process. You may have the inventory system checking to see that your item's available, the billing system actually performing the financial transactions, and then you're also going to see interaction with a shipping partner, such as like FedEx or UPS, in order to see the status of your item as it is sent to you. And then also there is a notification system involved. You're often notified when you hit different milestones in the purchase, such as when your item's been shipped, when it may be arriving. You get all these different notifications. That's not just one system, it's a bunch of systems working together to provide you that service or that capability. And that's where the real complexity arises. Getting these systems that may not share a common architecture or platform to work together to exchange information in a reliable and efficient manner in order to fulfill the business process. In addition, the interoperability of these systems is often rigid, and that creates problems when we need to change our process in some way. It creates a lot of work and it requires a lot of effort. And these are the problems that enterprise integration looks to solve. So let's talk a little bit about how that is achieved. We know the goal of enterprise integration is to promote the exchange of data between our systems. And the way it is promoted is really by abstracting the problems that we encounter when we attempt to integrate our systems. We want to eliminate rigid data exchanges or rigid interoperability problems. And to do that, we need to use a more robust approach. And this is where the different enterprise integration patterns come into play. There's more robust ways that we can structure the communication between systems to do things like guarantee delivery. We can handle a significant load better. We can also increase the availability of the system. So that is all accomplished through abstractions and through patterns. And we get these common solutions to these problems that we normally face. One of the major hurdles when working with enterprise integration is that the integration need is not always within our enterprise. So we may need to reach out to a third party and connect to one of their systems. Or they may use a different technology than we do. So there's all these complexities, and one of the ways we can overcome that is by leveraging adapters. So we'll see that most enterprise integration solutions have a variety of adapters that allow us to communicate with different technologies that may be found within our organization or within a third party's organization. Now that we know a little bit more about how enterprise integration is achieved, let's talk about the goals of enterprise integration. So, enterprise integration eliminates the barriers that keep our systems from exchanging data or working together. And what this allows is new capabilities and synergies to be recognized by the system owners. Information and capabilities once contained in siloed systems can be unlocked to support new organizational processes. It encourages system interaction by solving problems faced by developers when integrating systems. Legacy approaches were often brittle. They required much oversight, and the effort to maintain the connectivity between the systems was very high. So we want to change our applications to support our business processes. And the way we do that is by leveraging this integration approach that really reduces coupling between our systems. Using flexible architectures that are constructed using enterprise integration patterns that were popularized in the book Enterprise Integration Patterns, we can build better systems that exchange information and create these new synergies between the different systems. I highly recommend that anyone serious about enterprise integration read this book. These patterns address the rigidity commonly found in point-to-point integration solutions, improving the agility of the overall enterprise. System changes are no longer costly endeavors. They allow business processes to change quickly at the need of the enterprise. In addition, enterprise integration brings stability to business processes by decoupling interconnected systems, often through the introduction of a queue or middle platform for guaranteeing delivery of messages. So, as you've probably realized, enterprise integration is more of a concept or a theory. But in order to put those practices to work, we need implementations. So now let's talk about two of the most common implementations. The first is the Enterprise Service Bus, and an Enterprise Service Bus is a more centralized way of performing enterprise integration. Enterprise Service Buses integrate applications by putting a communications bus between them and using the bus for communication between the systems. Each system has no knowledge of the other system and relies solely on the bus for communication. And that's how decoupling is achieved between the interconnected systems. For our course, we'll be focusing on the integration framework approach, which is more lightweight and allows for point-to-point connections of simple solutions. However, if needed, we can move towards a more full-scaled solution that does have that centralization of the communication between these systems. As we work through the course, we'll dive into the benefits of integration frameworks and how these capabilities are provided through Spring integration. In this lesson, we'll discuss how the Spring integration framework facilitates enterprise integration. Spring integration is a project that extends the Spring framework to support a set of enterprise integration patterns found in the Enterprise Integration Patterns book by Hope and Wolf. These patterns provide us with better approaches to exchanging data between systems. The project was first introduced by Mark Fisher in 2007. Since then, the project has grown and we are currently at version 4.3. The framework uses the features found within the Spring core to implement enterprise integration patterns. This allows developers familiar with Spring to leverage their existing knowledge to quickly build Spring integration applications. So while working with the framework, you're going to be doing things like dependency injection and auto wiring, all the things we love about Spring. In addition, developers will find that Spring integration opens the door to interfacing with systems that use a variety of technologies such as web services, JMS, underlying file system, and JDBC. Now let's discuss some of the key objectives or goals of the framework. Spring integration, like all Spring products, is designed to simplify the life of the developer. The framework aims to allow developers to easily establish flexible business processes that leverage a diverse group of applications within their enterprise and beyond. The framework allows for the loose coupling of interconnected components. The message-driven architecture used by Spring integration allows endpoints within a project to be swapped transparently, meaning changes are less costly once we see them arise within our business processes. The framework also does an excellent job of defining the boundaries between components. You'll see that each framework component performs a single responsibility, which allows us to clearly define our processes. This is also helpful for keeping our custom code separate from the integration code, which is responsible for transporting messages between endpoints. So now let's talk about how all of this is achieved. Spring integration uses an architecture that relies upon channels to route messages to endpoints. Channels, messages, and endpoints come in all shapes and sizes to fit a variety of integration needs. Commonly, you'll hear the comparison to pipes and filters when talking about Spring integration. This is similar to the Unix construct where the output of a filter is often routed to the next filter for manipulation. The routing is performed by the pipe, while the operations are performed by the filter. In our scenario, channels do the routing instead of the pipes, and endpoints perform the operations. We can link numerous filters together to build the processes we need to support our businesses. This is all done without using a heavyweight central enterprise service bus. For those of you familiar with Spring, this should not come as a surprise. Instead, the framework leverages the lightweight, method-driven architecture to perform point-to-point integrations between systems, or, when necessary, a message queue is often incorporated for more demanding integration solutions. This is achieved by using familiar Spring core components such as task schedulers and executors. A key feature of the framework is the set of provided adapters which ease integration with various third-party technologies, such as messaging systems, file systems, databases, and FTP servers. Let's take a look at a few of these adapters that Spring integration provides. So Spring integration provides adapters for data stores. So these are things like relational databases, NoSQL databases. We can use these already created components in order to connect to these types of systems. We can also connect to file stores, so things like the file system, FTP servers, or SFTP servers. We can also access resources over the HTTP protocol with adapters. There's adapters available for email or SMTP traffic. And then we also have adapters for messaging queues, so AMQP or JMS are available to us. And we also see an adapter for Twitter, probably not as heavily used. And then one of the more popular ones is the web services adapter, which allows us to connect to web services that operate on protocols such as SOAP, REST, or JSON. So we have all of these adapters available to us, and they perform a lot of work for us, and they allow us to integrate systems together. So the key takeaway from this lesson is that Spring integration provides us with a bunch of tools to integrate systems together to exchange data. And when we use these tools, we have lower development costs and lower maintenance costs because these tools follow strict enterprise integration patterns. And that's what we're going to learn about for the remainder of this course. Spring integration uses three types of components to construct its messaging architecture. which supports flexible integration of enterprise applications and system components. In this lesson, we'll take a closer look at these three components and discuss how they are used by Spring integration. Of course, the three components we will be studying are the message, the channel, and endpoints. Within Spring integration, these components are used to build the messaging architecture. The messaging architecture allows us to deliver a message from one endpoint to another over a channel. This exchange may occur internally within Spring applications or between a Spring application and an external system. As we learn more about these components, we'll see there are different types of these components which possess different behaviors or have different purposes. As we integrate systems, we'll choose the appropriate type of component to best support our integration needs. The first component we'll discuss is the message. The message is the piece of information passed between two components. Within Spring integration, messages are used to wrap any object used by Spring integration. The object wrapped by the message is referred to as the payload. It is the primary piece of information we would like to exchange. Accompanying the payload can be a set of headers that provide information about the message being sent. Headers may provide information such as IDs, timestamps, or custom values that may be consulted for activities such as routing messages. Messages are very generic, which allows them to deliver almost any type of payload such as string, objects, XML, JSON, or SOAP. Once we start working with messages, you'll notice that the object has no setter methods, making the message itself immutable. However, the nature of the underlying payload is determined by the developer. So if the object that we are delivering via the payload is mutable, it can change, and that can cause problems. Next, let's take a look at the channel, which is the component that delivers the messages between endpoints. The job of the channel is to determine how and where a message is delivered. Using a channel to transport messages between endpoints keeps the endpoints unaware of each other, reducing coupling between components. Channels are the key to flexibility within Spring Integration's messaging architecture. As we work more closely with channels, we'll see that there are various implementations. Some channels' behavior provides point-to-point communication, which delivers a single message between two endpoints. Other channels provide a publish-subscribe behavior that delivers a single message to multiple endpoints. This approach is established using a technique similar to an observer pattern. Other implementations will allow processing to occur synchronously or asynchronously. If that were not enough, you can define your own channel implementation. The most interesting of these components is the message endpoint. Endpoints are the components that actually perform some operation when a message is received. These components sit at the end of channels and connect the messaging framework with different services that react when receiving a message. When referring to endpoints, we'll often use the terms producer and consumer. These terms simply describe which side of the channel an endpoint resides. Producers place messages on a channel to be delivered to a consumer that receives it. There are many types of endpoints that will become more familiar as we work more closely with Spring integration. The framework provides endpoints such as channel adapters for one-way connections to external applications, gateways and service activators for messaging between internal components, as well as filters, splitters, aggregators, routers, and many more. The components we just reviewed are the key to successful enterprise integration within Spring. But there's one final concept I want to reinforce about the Spring integration architecture. We now know that messages, channels, and endpoints form the messaging architecture behind Spring integration. We also know that messages can be sent internally between components and also externally to enterprise applications. When we send messages internally, we do so via the messaging architecture. However, when we send them externally, Endpoints within the messaging architecture mask the interaction with the external component, making it appear as part of the messaging system. When communicating with external systems, we'll use special endpoints known as adapters or gateways. Picture these endpoints as sitting on the edge of our Spring integration application's footprint. These endpoints receive messages from the internal messaging architecture, then perform the communication with the external system via its particular protocol. However, our enterprise application is unaware of these details. It doesn't know the protocol being used, it just knows it sent a message to an endpoint. This is the power of enterprise integration. The ability to abstract these concepts builds flexible applications based on established patterns. In this scenario, our external application could change. However, our system would only need to adjust the endpoint facilitating the communication between systems. The same is true for the communication occurring between the internal components via the messaging system. Now that we've taken a closer look at how Spring integration works with its components, we'll move on to learn more in depth about these components. In this lesson, we'll download the Spring Tool Suite IDE, otherwise known as STS. STS will be the IDE we use throughout the course to explore the Spring integration framework. STS is an Eclipse environment that has been outfitted with tools to help Spring developers. Since it was designed specifically for Spring by the Spring team, it is naturally one of the best tools for building Spring applications. To start working with STS, we'll need to obtain a copy of the installer, which is a convenient zip file. To do that, we're going to navigate to the STS website. The best way to get there is simply to type in STS download into Google, and then if they would change the URL, you can easily find it. So here you can see the Spring Tool Suite site, and we'll just navigate to that site. It'll have a little bit of information about the IDE, and what we're interested in is this See All Versions link. So once we navigate to this page, you're going to see there are various downloads for each respective platform. So you need to find the platform you're using and then choose to download the file. I'm using Windows and I'm on a 64-bit machine, so I'll download the zip file, and it prompts you for the download and simply save it to your desktop. Now, I have already done this ahead of time, so I can move ahead and not wait for that download, so I'll spare you that. So I have the file on my desktop, and what I need to do now is simply extract the file. So I'll use my favorite extraction tool 7-zip, and I'm going to extract the files to a folder named Spring Tool Suite 3.8.0.release, and 3.8 being the most recent version of STS. So that will begin to extract the tool, and now we should have a new folder that contains the IDE within the STS bundle directory, as well as a pivotal Tomcat server that will host any applications that we launch from the IDE. The IDE itself is located within the STS 3.8 directory, and if we navigate down to the bottom of this directory, you see sts.exe, and that's the IDE. So we're going to go ahead and launch it. Once all of the libraries load, we will then be prompted to select our workspace. So what we're going to do is we're going to place a new folder on our desktop. So I'm going to click the Browse button, and then I'm going to go to my desktop, make a new folder, and I'm going to name this folder STS Workspace. And then we will click on that folder, hit OK, and then be sure to check this Use this as the default. That way we're not prompted every time to specify our workspace. We only have to do it once. Now once we hit OK, STS is going to begin to open up. And there we see all the different Eclipse libraries being loaded. Sometimes this takes a little. And then we can arrange our STS application so that it fits on the screen as we'd like. You'll want to give it as much screen space as possible so you have more area to work with. You'll see all the outfitting for Spring on this Eclipse install. It looks very much like Eclipse. You're going to find the shortcuts are the same, a lot of the windows are the same. There's just this little extra tooling in there for Spring, and we will be exposed to some of that as we work through the course. But at this point, we have our IDE set up and we're ready to start working on Spring integration projects. This is my favorite lesson because it's the point in our course where we crack open the IDE and start looking at code. We'll inspect a very basic Spring integration project and run a demonstration of the application in order to get some hands-on experience with the concepts we've discussed in this chapter. So to start out, we need to import a project from your working directory. So stage the files from the working directory inside of your STS workspace. Then go to File, then Import, and then type Existing Maven Projects, and then hit Next. You'll then be able to browse. You'll then navigate to your workspace where you have placed the files for this lesson. There I see the Spring integration demo, so I simply click on that folder, hit OK, and then hit Finish. And at that point, Eclipse will begin to import the Maven project. And this is the project that contains the demonstration we'll be taking a look at for this lesson. If you look at the Package Explorer, you'll notice the Spring Integration Demo Application class, and this is where we're going to start. So looking at this class, the first thing that you'll see is that the application is architected using the Spring Boot project. We can tell that by looking at the Spring Boot application annotation on our project. Spring Boot is a separate Spring project that allows developers to quickly get up and running with Spring. Instead of performing tedious configurations, developers can simply tell Spring the technologies they would like to use, and Spring will build the project using some sensible and customizable defaults. So to build this project, we told Spring Boot to build a Spring integration project, and it provided the necessary configuration and libraries. Next, you'll notice that our application class references the integration context.xml file. This file instructs the Spring IOC container to construct the various beans we'll need for our application. Those beans can then be injected into our project. So let's navigate to that configuration file, and it's found within the source main resources directory. Now, the first thing you'll notice is we're on the Integration Graph tab, and this provides a visual overview of the beans that we have configured within our integration context.xml file. This tooling is specific to STS. It won't be found in a plain version of Eclipse. Using this tooling, we can build out different integrations that we would like to see in our project. What I'd like to do for our demonstration, though, is take a look at the source. Now, an important point to remember is that the messaging architecture uses endpoints, channels, and messages. And within our integration context.xml file, we see two endpoints established, and they are connected via a channel. So we have a very rudimentary messaging architecture set up here. And the first component we have is this endpoint, and it's a gateway. Basically, this allows us to send a message to this gateway, and then you see it's configured to use the input channel. So the gateway will put the message on the input channel, and then the input channel delivers it to our service activator. And once the service activator receives this message, it is going to print out the message it received. Now, you'll notice that we have this print service bean and this reverse service bean, and those are going to be wrapped by the service activator. So really, the service activator is allowing these two beans to be accessed via the messaging architecture provided by Spring integration. Don't get too caught up with the terms service activator and gateway at this point. Just know that they are capable of receiving messages, and the service activator does something once a message is received. In fact, we can go take a look at the print service, and you see that it simply receives a string and then outputs that string to the console. So there's nothing too complex happening there. So now that we've taken a look at the integration context.xml file, let's navigate back to the Spring Integration Demo application.java file and talk through this a little bit more. The gateway is a bean, so we can inject that into our application, and then we can use that gateway. So we invoke the print method on the gateway, and we pass it this string hello world. Now, the gateway is smart enough to wrap that in a message. So hello world becomes the payload, and then that message containing the hello world payload gets sent to our channel. That channel passes the message to the service activator, and that service activator is wrapping our print service and incorporating that into the messaging architecture. It takes the payload out and passes it to the print method on the print service, and then we write our output to the console. So it's pretty simple. Let's head back to our application and we'll run through this demonstration. So to run the application, all we need to go to is our Package Explorer and right click, and we can go Run As, and you can just run it as a Java app. And then what we'll see is some console output, and there we see that we printed out hello world, exactly what we expected. So now let's head back to our integration context, and what we'll do is we are going to actually change the bean that our service activator is exposing. Instead, we are going to use the reverse service, and all this does is it reverses our string. So there I just changed the bean that this endpoint, the service activator, is working with, and we're going to see how flexible it is to make a change within our integration application because of how we abstract out all of our logic with the messaging architecture. So all we need to change is the bean that our service activator references, and that's the reverse service. And then if we do take a look at that bean, you'll notice it has a reverse method, and that's the method we want to invoke. So we're going to head back to our service activator declaration, and we change up the method that we will invoke once we receive a message. Okay, so we have that change in place. Now let's navigate back to the Package Explorer, and we're going to run our application one more time. And we keep an eye on the console, and now we get our message payload, which was that simple string, backwards. So you may be thinking, wow, I could do that by simply invoking a method. And the point here wasn't to just show you how we can change console output. Think about this in more complex terms. What if it wasn't simply a call to system.out.println? What if this was a more major integration where you're reaching out to a third-party system? Look how easy it would have been to swap that out. And that's the whole point of abstracting out the message architecture, making it more generic. It makes a lot of these problems look the same, and that makes things more flexible. So this was our first real look at Spring integration within the IDE. And I hope you really enjoyed seeing how flexible the project and the framework is. We'll continue to dive deeper into some of these components we're using throughout the course. The Integration Basics chapter contains a series of hands-on lessons designed to make you more comfortable working with Spring integration components. The lessons within this chapter will spotlight the key components in Spring Integration's messaging architecture. This will give you the foundation to advance to more complex integrations within the framework. So let's talk a little more about the contents of this chapter. By the end of this chapter, you will have constructed a simple Spring integration project that leverages each component within the messaging architecture. We'll start out by creating a new project from scratch using Spring Boot. From that point, we'll walk through the core messaging components one by one, You will gain hands-on experience with each component, teaching you to work with messages, channels, and endpoints. Finally, we'll use Spring Integration's messaging template to remove some of the messaging system specific code from our application. You will see how the messaging template is a great way to make our code more concise when working with Spring Integration. The concepts within this chapter demonstrate how the major Spring integration components, the message, the channel, and endpoints, work as part of the messaging system. Once we have mastered these components, we can integrate external systems into our Spring integration application by leveraging our knowledge of the framework's messaging system. In this lesson, we'll set up a basic Spring integration project within STS. The technique we'll walk through will rely upon Spring Boot to quickly establish our project and provide the appropriate configurations. With Spring Boot, it is no longer necessary for us to manage our project's dependencies or their versions within the Maven pom.xml file. This will allow us to rapidly get started with Spring integration. The project we are about to configure will serve as the base for many of the lessons within the course. If you have never used Spring Boot, it is extremely simple when using STS because there's built-in tooling. So all you need to do is go to File, New, and then Spring Starter Project. This is going to open a project dialog where we specify the name of our project. So we're just going to name our project Spring-Integration. Then we specify a group ID, an artifact ID, which will just be Spring-Integration. And then we specify a package, which I'm going to change to com.o'reilly.integration. You'll notice that we are using Maven when building out our Spring Boot project. This means we will have a pom.xml file, and it needs to have some dependencies provided for us. And to set those dependencies, we hit Next, and then we can specify which starter poms we would like included. Now you can search for the integration dependency, and that will cause the integration libraries to be included with our project and to already be auto-configured for us. So just go ahead and hit Finish, and STS will start building out our project using Spring Boot. Once all of the content for the project is imported, you can expand the Spring integration project within the Package Explorer and then take a look at the pom.xml file. And if we look at that file, you're going to see that our Spring Boot Starter integration dependency has been included. And if we take a look at that dependency hierarchy, we see all of these different libraries and the appropriate versions have been provided for us. This is amazing. If you've ever had to manage this on your own in a Spring project, this is revolutionary. It saves us so much time. Further taking a look at the project, you'll notice that we have the Spring Integration Application.java class. And this class contains the main method, which will start our Spring Boot application. We need to do a little bit of work within this file in order to set up our project. So what we're going to do is we're going to go to the class declaration, and we're going to have our class implement the application runner interface. So go ahead and import that type, and then we need to implement one of the methods on the interface. So if you hover over the underline on our type, you'll be presented with the option to add unimplemented methods. So we want to go ahead and do that. And this is going to add the run method to our class, and we need to provide an implementation for this method. So I'm very simply just going to print out a message to the console, and we'll just say hello world. And at this point we have the interface implemented, and all this does is it causes the run method to be called when we start our Spring Boot application. The next thing we're going to do in this class is we are going to add the configuration annotation. And this just specifies to Spring that we are going to possibly declare some beans to be instantiated within our IOC container inside of this class. I'll go ahead and save our Java file. And now we're going to build out a Spring Bean configuration file. To create this file, we'll navigate to the source main resources directory within our package explorer. And then we can open the new dialog by pressing Ctrl-N, and we'll type Spring Bean configuration file. And all we need to do now is specify a name for our file, and I'm going to name the file integration-context.xml. And then I'll just simply click on Finish, and our new XML configuration file will be created. Within this file, we can go ahead and add the integration namespace. So just click on the namespace tab, and there you see the int namespace, and this is going to provide us with some shortcuts when we create different integration beans. And they're all found within the Spring integration libraries that have been imported by our pom.xml file and Spring Boot. Now, we're not going to provide any specific integration beans for our project setup right now. We'll add those as we walk through the different lessons. But one thing I do want to point out is we are using XML configuration here in combination with Spring Boot. Now, we will also, in some cases, use annotations in order to specify some of our configuration. So we're going to have a little bit of a mixture. But the reason we choose the XML configuration primarily is because much of the Spring integration documentation is written using the XML format. So I do believe this is the best choice when using Spring integration, but you'll notice we are coupling it with Spring Boot. It's a very quick way to get up and running and then use what seems to be the preferred configuration for the library. So the next question you should ask yourself is, we've declared this integration-context.xml file, and this configuration is going to instruct our IOC container, but how does the Spring Boot application know about this file? Well, we need to add an annotation to our Spring Boot application annotated class. So we head over to the Spring Integration Application class, and we add the import resource annotation. And this simply tells Spring Boot to include some additional configuration when it starts up the IOC container. And then what we can do is we provide the name of our configuration file, so integration-context.xml. Now, by default, this is going to look on the class path for that resource, and we do indeed place the integration-context.xml file on our class path. So that is our base project, and we'll just go ahead and launch the application in order to make sure all of the configuration is appropriately set up. So you can just right-click on the Java file within the Package Explorer, and then we go to Run As, and here you can run as a Java application or a Spring Boot application. I'll just launch as a Java app, and then we'll take a look at our console and make sure we get our output. So there we see Hello World, and that signals to me that we have appropriately configured our Spring integration-based project. In this lesson, we'll take a deeper look at the message component within the Spring integration framework. This key component abstracts the object that we use to exchange information between our endpoints. Let's first get started by declaring a message within our run method. So we'll go ahead and declare a variable of type message, and we'll name that variable message. And then I'm just going to go ahead and import the org.springframework.messaging.message type. And if we navigate to that type by hitting F3 while hovered over it, you'll see that the message is an interface that contains two methods, one being getPayload and the other being getHeaders. And this corresponds with the two pieces of a message that we discussed. The message acts as a wrapper for the payload, and it also contains headers that provide information about the message. You'll notice that the message interface has generic type parameters allowing us to specify the type of the payload that we are going to deliver with the message. So let's go ahead and close our message interface, and then we will proceed to declare a new message. And the way we do that is by using the generic message constructor. And this is an implementation of the message interface. So we'll go ahead and import that type, and then what we need to do is we need to provide a payload as an argument to our constructor. So I'm just going to pass a string, and that will serve as our payload. Now we can also specify our generic type arguments in order to more strongly type our message. Now that we have created our message, let's create a new class that can process our message. So I'm just going to navigate to the Package Explorer, open the New dialog, and I will create a class called Print Service. And this is going to be a very simple class. It's going to contain a public method, and that method is going to have a return type of void, and the method name will be print, and then we're going to pass in a message, and then we'll take that message and we will print out the message payload to the console. So we'll import the message type, and then we can invoke the getPayload method on our message. And we want to make sure that we import the correct type. So we'll run our imports again, and we'll pick the Spring message, and there we have our print method defined on our print service. Now let's return to our application class, and we are going to create a new print service, and we'll just name it service, and then we'll use the default constructor to instantiate an instance of the service, and then we'll invoke the print method passing in our message. So it's pretty simple. We're just sending our newly created message to the print service, which will grab the payload using the getPayload method, which is defined on the message interface, and then it's going to print that payload to the console. So let's just run this demonstration real quickly. And to do that, we can navigate to the Package Explorer, right-click on our Spring Integration Application class, and then click on Java Application. And then we will see the console display our output, and there we get Hello World. Okay, so let's return to our application class, and now we're going to take a look at headers. So we know that messages can have headers which contain different metadata about the message being sent. So we're going to see how to add those headers into a message. So when we work with headers, we first create a map, and the map is going to have the string and object generic arguments. And then we can name our map, and I'll just name it map. And then we are going to use a hash map implementation. And we'll make it, once again, use the string and object generic type arguments. And then what we'll do is we will add a object into our map, and the object or the entry will use a string as the key. So let's just put key as our key, and then it takes an object as the value. And we're just going to use a string here, and we'll use the string value. And then what we can do is we can declare a variable of type message headers, and I'll name this variable headers, and then we use the message headers constructor in order to instantiate our message headers object. And the message headers constructor accepts an argument of type map that has a generic type argument set specified of string and object. And then what we need to do is we need to pass our headers into the constructor of the generic message. And at this point, we have constructed a message that has one header that we have specified. Now, there will be default headers that are included in this message placed there by the Spring Integration Framework, but we only have one custom header, and it's going to have a key of key and a value of value. So now we'll save those changes, navigate to our print service, and what we're going to do is we're going to extract the message headers from the message. So on the message, we'll invoke the getHeaders method, and then we'll import the message headers type, and then we're going to navigate through the headers using a for each loop. Now, know that the message headers really implements a map. So what we can do is we can use the entry type, and then we can pull the entry set from the map. So we use the entry set, and then we import those types. And then what we can do is we can output the key for the entry, and then we can also output the value for the entry. And that allows us to inspect the headers. So let's go ahead and we'll run our application once again. And now we see that we get several headers printed out. We see our custom header, which is the key and value output we see to the console, but then we see some of the defaults. We see the ID and the timestamp, which are placed there by the Spring Integration Framework. Okay, so let's return back to our application class. And now we're going to work with a little bit better way of creating these messages. Spring Integration's Message Builder provides us with a builder pattern implementation that allows us to more easily construct a message. So we're going to remove our previous code to create our message, and now we're going to use the builder pattern, which will be much easier. So we're just going to use the message builder type, and you'll see several static methods that we can invoke. So one is with payload, and all we need to do is pass in our payload, and we'll say hello world from the builder pattern. And then we can also specify different headers that we would like to add to our message. So there we see the set header method, and what we can do here is we can specify the header name. So I'm going to say new header, and then I can specify a value for the header, and I'm going to say new header value. And then at this point, we just invoke the build method in order to actually create the message itself. So it's traditional builder pattern that we're working with here, and there's several variations of using the message builder that you can use. If you just explore the API for this object, it's very simple to pick up how to use it. So there we see we've created our new message, and let's run through our demonstration, and we can see that it works the same way as when we manually built our message, but it's much more convenient to use the message builder. So that concludes our lesson where we took a deeper look at the message, which is a generic way to exchange information between our endpoints within Spring Integration. In this lesson, we'll take a closer look at channels within Spring Integration. We'll learn how to establish a channel, and we'll learn how to send a message over the channel. Message channels are a key component within Spring Integration because they decouple the endpoints that exchange messages. In order to get started, we'll need to navigate to the integrationcontext.xml file. Within this file, we will leverage the integration namespace, so it begins with the prefix int, and within that namespace, we're going to see a variety of tags that we can use, and these tags will cause specific Spring Integration components to be registered in our IOC container as a bean. Now, the tag that we are interested in is the channel tag. So all we need to do is go ahead and place that tag within our XML file, and we'll give the ID attribute a value of message channel, and that will end up being the name of our bean. So the channel will be created as a bean within the Spring IOC container, and that means we can dependency inject the channel into other Spring beans. Now, once we have our channel declared and it will be built in our Spring IOC container, we can navigate over to our application class, and here we're going to auto wire the channel. So it will be dependency injected by the Spring IOC container. And what we're going to do is we're going to use a type of direct channel. So we declare a field and we put the auto wired annotation on it, and the field's type is direct channel. So we'll import those types, and let's talk a little bit more about direct channel. It follows a point-to-point approach to integration. So it's going to connect two endpoints and that's it. And they are directly connected. So once we put a message on this channel, it's going to go from one endpoint to another. It's a very simple type of channel that we can use within Spring integration. Now, if we take a closer look at the direct channel type, we can go ahead and attach the source. And once our source is pulled down, we see that the direct channel extends the abstract subscribable channel. And if we take a closer look at that type, we see that it implements the subscribable channel interface. And looking at that interface, we see that you can have a message handler subscribe to this channel. It's very much like an observer pattern where you would register the observer with a notifier, and then the notifier notifies the observer once something occurs. So we can create an implementation of the message handler, and we'll do that in a little bit, and we can subscribe to this channel. Now, you'll also see that we extend the message channel, and message channel is also an interface, and this type declares two important methods, and they're both named send. You just see the overloaded form there, and they accept an argument of type message, and then you can also specify a timeout in the other form. So this is really the core interface for a channel within Spring integration. Every channel will implement this interface, and it basically allows you to send a message over the channel. We'll see various channel types as we work further into the course. So I'm going to go ahead and close all these types, and we'll get back to our application class. So now what we're going to do is we are going to work with the channel inside of our run method. So the first thing we'll do is invoke the subscribe method on the channel, and then we're going to define a message handler. And this is the base interface for components that receive messages. So once we have declared our message handler, we need to import the type and be sure to choose Spring's message handler. And then we need to provide an implementation of this type. So we need to implement the handle message method. And what will happen is this message handler will be subscribed to the channel, and when the channel sends a message, it will provide that message to the message handler and invoke the handle message method. So what we'll do is we will declare an instance of the print service, and then we'll invoke the print method and we'll pass in our message. Now, we're going to do some casting here. It won't really be appropriate for production code, but we're just going to, for demonstration purposes, do a really hard cast to a message with a generic type of string. That way it satisfies the signature of the print service method. So with that in place, we can actually remove the print service from the body of the run method, and now we can use our channel and we can invoke the send method and pass in our message. When we do that, it's going to cause the channel to send that message to all of its registered message handlers. And that in turn will invoke the handle message method, and that's going to cause our print service to print out our message. So with this code in place, we'll go ahead and run our demonstration. So we'll navigate to the Package Explorer, and then we're going to expand the com.o'reilly.integration package, right-click on the Spring Integration Application class, and then go to Run As and Java Application, And then we can watch our console to see our message be sent over the channel. There we do see our message, and it was sent to the print service, and that caused all the headers to be printed. And that was all made possible by our channel and subscribing a message handler to that channel. So in this lesson, we got some good hands-on experience working with channels. And as we progress in the course, we'll continue to work with channels and different types of channels, and we'll see how they can alter the behavior of how our messages are sent. In this lesson, we'll create a simple endpoint and attach it to the message channel so that it can participate in Spring Integration's messaging architecture. There are many types of endpoints available within Spring Integration that each perform some operation on or with a given message. The operation can be some simple passing between components or as advanced as the completion of a multi-step business process. Within this lesson, we'll be using the Service Activator endpoint to demonstrate how endpoints are leveraged by Spring Integration. A Service Activator is just one type of many endpoints within Spring Integration. It is used to connect a Spring bean to an input channel. So in order to work with the Service Activator, we're going to need to declare a bean within our integration context.xml file. So we will use our print service within our Spring integration context to declare a bean. So we create a bean of type print service, and then we're going to give that bean an ID of print service. So now we have this bean, and what we can do is we can take this bean and make it work with the Service Activator. So we'll go ahead and use the integration namespace, and we'll use the Service Activator tag. And the first attribute that we need to provide a value for is the ref attribute. And all this does is it says point to the bean that this Service Activator is going to connect to a channel. So in our case, we want to connect the print service bean to a channel. Then we specify a method on the bean that we would like to have invoked when a message is received. So let's take a look at the print service. And there you see we have one method, print. So our options are limited here. And you can even see that IntelliSense will help us out. So it'll look at the print service type and it will provide the messages available to us. The next thing that we'll need to do is specify an input channel. This is the channel that will deliver messages to the print service. So I'm going to go ahead and specify a channel name of input channel just to keep things clear. And then I'm going to go up and change our message channel's name to input channel. And at this point, we have a simple Service Activator endpoint that is connected to our channel. The Service Activator connects our print service bean to the channel, and the print service bean is capable of receiving messages. So now let's navigate to our application, and we're going to make some changes here in order to work with our new endpoint. So we're going to remove our message handler, and I'm just going to comment it out for the time being. And then we can save our application, and now we can run our application. So if we go to the Package Explorer, and then we right-click on the project, we can go to Run As, and from there we can pick a Java application. You may get prompted to pick a particular class file that contains a main method. So we just need to find our Spring Integration application class and click OK. From here, our new application will be launched, and there we can see that we invoked the print service, and the print service printed out all the headers as well as the payload for our message. So let's return back to our editor. Now let's take a look at how we can return a message from our Service Activator. So first, let's head to the print service, and let's imagine instead of just printing this message out to the console, we want to return a message of our own. So we're going to use the message builder, and we're going to create a message with a payload, and we're just going to make the payload new message. And then we're going to invoke the build method on the builder. And at this point, we have a method that can return a message. So let's change its type from void to message. And now we can import our message builder, and our print method is modified. The problem is we need to specify that within the configuration of the service activator. We need to let the service activator know what to do with the message. So let's navigate over to our integration context.xml file, and we're going to create a new channel. And I'm going to call this channel the output channel. And then if we look at the attributes on the service activator tag, you'll see we have an output channel attribute, and there we can specify the channel we would like to see anything returned from the service activator be sent to. Now, we'll need to modify our application. The first thing we should do is we should auto-wire the new channel, and I'm actually going to switch the channel names so that we can discern between them. So here's our input channel, and here's our output channel. And now we need to add a qualifier. That way Spring knows how to auto-wire these beans of the same type. So we'll go ahead and add the qualifier annotation. And then we just specify the ID of the bean that we would like to have auto-wired to this field. So we'll import that annotation, and then we'll add it to the input channel field. And we have our two channels that will be appropriately auto-wired. So now we need to send the message to the input channel, and we need a place where that message will be received. So we're going to uncomment this block of code, and we're going to switch it up to use the output channel, and we'll subscribe a message handler to our output channel. Instead of invoking the print service within the handle message method, we're simply going to print out the payload of the message. So we can invoke the getPayload method, and then we'll need to re-import our types. And at this point, we have our application set up. So let's talk through what just happened there. We modified the print service to return a message. Since we're returning something from our print service, which is used by a service activator, we need to say where that message goes. So we created this output channel to send the message to, and then we specified the output channel attribute on the service activator, which will cause that message to be sent to the particular output channel. Within our application, we added a message handler on that output channel that will then print out the payload of the message. So let's go ahead and we can run through our application, and we'll take a look at our output. So what we see is that we hit the print service, we print out all of our headers, and then we send that message over to our output channel, which is wired up to our message handler, and that's an endpoint we're using to print out our payload of the returned message. So in this lesson, we learned more about endpoints and the part that they play within Spring Integration's messaging architecture. We worked with a service activator endpoint, which is just one of the many types of endpoints, and we saw how it can receive and send messages as part of the messaging architecture. In this lesson, we'll take a look at the Spring Integration messaging template. The messaging template provides us with a way to send and receive messages directly within our application code. Normally, we would not work directly with channels inside of our Spring Integration applications. We'll see that there are better ways of using the messaging architecture that makes Spring Integration transparent within our code. However, if you must work directly with the messaging system, the messaging template is the best approach because it provides support for both requests and replies over a channel. Normally, when working with a channel, we only have the ability to send. The messaging template allows us to do the two-way communication necessary to communicate with some endpoints. To get started, we're going to navigate to our Spring Integration application class, and within this class, we are going to go ahead and add a messaging template. So in order to create an instance of a messaging template, all we need to do is declare a variable of type messaging template, and then we'll give it a name of template, and then we use the no argument constructor for the messaging template. It's that simple. We now have the messaging template available to us to use within our code. Let's just quickly take a look at some of the methods provided to us on the messaging template. So here you'll see there are a variety of convert and send methods, and those allow us to send messages and perform some modification to them. There's also a send and receive form. What we're really interested in is the send methods, and this is what we're going to use within our application. Specifically, we're going to use send and receive. So there you see there's also there's a receive and convert, but the one that we will be using is send and receive. So before we do that, we're going to have to modify our integration context.xml file. So what we're going to do is we're going to remove the output channel within our configuration. So we'll just go ahead and remove the channel itself as well as the output channel attribute on the service activator. And then we'll save our integration context. Now we'll navigate back to the Spring Integration Application class, and the first thing that we'll do is remove the output channel from the class. So we remove the field and its annotations, and then we will need to remove the subscription of the message handler to that output channel, and now we can start to work with our template. So as we said, we're going to invoke the send and receive method, and the first argument that we're going to provide to this method is the channel that we would like to send this message to. So we're going to send it to our input channel, and the second argument we'll provide is the message itself that we would like to send. Make sure you're using the regular form. You'll notice it accidentally selected the convert and send and receive, and that's not what we'd like to do. And now, because we're using our template, we no longer need to directly invoke the input channel. So look at all the code reduction that we achieved using the messaging template. We didn't have to work with the channel that was going to return our message, so the output channel is completely gone. We didn't need to directly invoke the send method on the input channel, and now we're able to get our message back. So what we'll actually see is that the template can return a message. So let's call this our return message. And we can take that return message and we can print out its payload to the console. So it's very much like just invoking any old method that is going to return some object to us. However, we are actually using Spring Integration's messaging architecture in order to perform the request and the response. So now that we have our changes in place, let's go ahead and we can run our demonstration. So we'll navigate to our console, and there we see our output. So we get all of the different headers, and you actually see that the messaging template added some of its own headers, and it actually added a temporary reply channel, and that brought back our message. And there we invoke the get payload method on the message, and we print it out to the console. This is actually all the output from the print service, and then once the print service sends its message back to the template, we then retrieve that message object, and then within our application code, you'll remember that we printed out the payload to the console. So you'll notice how much more concise this is. If you need to work with the messaging system directly in your code for some reason, always be sure to use the messaging template. It's going to make your code a lot more readable and a lot more concise. Within Spring Integration, we use channels to pass messages between endpoints. This chapter will focus on the different channel implementations and components that support working with channels. Let's take a closer look at what will be covered in this chapter. We'll start out by discussing what channels Spring Integration makes available and what types of behaviors they provide. Particularly, we'll be taking a look at channels that implement the pollable and subscribable interfaces within the framework. These two interfaces serve as base interfaces for the two major categories of channels within Spring integration. After we see the theory behind the channels, we'll work to configure each of these channel types within simple Spring integration projects. We'll cover how to build channels such as the QueueChannel, PriorityChannel, Publish-Subscribe channel, and DirectChannel. Next, we'll explore how to use a messaging bridge to connect two channels. This can be useful when we want to combine two types of channels, for example, combining a queue with a Publish-Subscribe channel. This gives us new options when building the messaging architecture within our applications. Finally, we'll use channel interceptors to interject within the messaging architecture. The interceptors will allow us to modify messages or perform logic at particular points when a message is being sent or received. So after completing this chapter, you will have a good handle of the channels within Spring integration, knowing the different types of channels and when to use them in particular situations to suit your application needs. In this lesson, we'll talk more in depth about the types of channels made available to us by Spring integration. We know that channels are used to send messages between two endpoints in a decoupled manner. Channels are what ultimately make the messaging architecture within Spring integration extremely flexible. Depending upon an application's needs, messages may be required to be passed using varying behaviors over a channel. For example, some messages may need to be sent to multiple endpoints, while others only need to be sent to a single endpoint. Having different channel implementations allows us to control how messages are received by our endpoints. Within Spring integration, there are two primary types of channels: pullable channels and subscribable channels. Before we discuss their differences, let's take another look at the base channel interface, messaging channel. The message channel interface is implemented by all channels within Spring integration. The interface has two variations of a send method that allow us to pass a message to a channel, and this is necessary in order to complete the process of sending a message. From this interface, the pullable channel is derived. The pullable channel allows our endpoints to request messages from a buffer by invoking its receive method. And there we see the receive method on the pullable channel interface. The channel stores messages in a buffer that it receives from a producer until they are pulled by a consumer that is pulling the channel. So when we use a pullable channel, we can expect to have endpoints or consumers that are constantly invoking the receive method frequently. And that's how they pull messages out of the buffer. Now let's talk about a buffer because it's a very generic term that's used quite frequently. But let's make sure we cover our bases and talk about what exactly we mean by a buffer. The term buffer is very abstract and it's used across many domains. Very generically, a buffer is a place to store something temporarily in order to mitigate differences between input speed and output speed. In order to better understand a buffer, let's walk through a simple example. Let's imagine that you and I are mailing letters, and we both have two different jobs. My job is to put the letter in the envelope, and yours is to stamp, address, and seal the letter. My job is very simple, and I can pass the letters to you very quickly. In fact, I can pass them to you more quickly than you can stamp, address, and seal the letters. Your job requires more time, where mine can be completed very, very quickly. So as we start working, you become overran with these letters that I'm passing to you because you can't keep up with my pace because you have more work to do. So in order to mitigate the difference in our speeds, we put a basket between us. And when I complete my work, I place it in the basket, and then as you are ready to begin your next piece of work, you pull it from the basket. Well, in this instance, the basket is acting as a buffer. It's allowing us to operate at different speeds, but still get the job done without me overrunning you because I'm operating faster. So as our diagram at the bottom of the slide depicts, there's a producer and they're sending messages. And those messages get queued up within a buffer, and then a consumer can consume those messages at their desired rate. So remember that a pullable channel is an interface, while a queue channel is going to implement that pullable channel interface. And here we see a diagram depicting a queue channel. And the channel has a queue that holds multiple messages. And then the messages are being retrieved by our two consumers who would be invoking the receive method on that channel. The queue we see, it functions as a first in, first out, or FIFO queue. So as the messages are received, they are then processed as they're received. Another implementation of the pullable channel is the priority queue channel. This channel functions very similarly to a queue channel, except that our messages are given a priority based upon some criteria. Those messages with the highest priority move to the front of the queue and are processed first when our consumers invoke the receive method. So those are the main channel types that fall into the pullable channel category. Now let's discuss the second set of channels that we can use. And we're talking about the subscribable channel type. Subscribable channels allow endpoints or consumers to request to be notified when a message is received. The behavior of this channel type is very similar to the observer pattern, where observers register with a notifier who then alerts all observers when a particular event occurs. The direct channel is the most basic channel type within Spring integration. It also implements the subscribable channel interface. It allows for direct communication between one producer endpoint and one consumer endpoint. This is the default channel type used by Spring integration, allowing for basic point-to-point message exchanges. Next, we have the Publish Subscribe channel, which also implements the subscribable channel interface. The Publish Subscribe channel is slightly more complex in that it allows for multiple consumers of a message. Once a message is placed on the channel, it is sent to all subscribed consumers in a one-to-many fashion. This channel implementation is useful for sending event type notifications out through the messaging system. So in this lesson, we covered some of the major types of channel implementations found within Spring integration. We'll get to learn more about these channels by working with them through hands-on demonstrations. In this lesson, we'll be working with Spring integration's queue channel. The queue channel places each message within a blocking queue that can be pulled by endpoints that invoke the channel's receive method. This approach allows messages to be handled asynchronously, meaning the execution of our application does not stop while waiting for a response from a consumer. To get started, we'll create a gateway that will allow us to send and receive messages. In order to create a gateway, we build a new interface within our com.o'reilly.integration package. So just open the new dialog by pressing Ctrl-N and then type interface. And we're going to name our interface Printer Gateway. So this interface will eventually become a gateway endpoint within Spring integration. And what we need to do is we need to specify the method on this interface that's going to accept a message, and it's also going to return a message. So we declare a public method that returns a type of future. So this is a way of dealing with concurrency in Java. And a future has a generic type, so we're going to specify a generic type of message. And message has a generic type, and we're going to specify that generic type as string. Eventually, we wind up with our method name, and then we specify the arguments for our method. So we're going to specify that we will accept a message for this method. and we import all of our types, and be sure to choose all of them from the Spring framework. And now we have our interface. So what will happen is a message will be passed to this interface or this gateway, and the gateway is going to send a message to a channel. And how we configure that is we navigate to our integration context.xml file. And if we look within the integration namespace, you guessed it, we're going to find a gateway tag. That gateway is used to configure our interface so that it can accept messages. And the way we do that is by specifying the service interface attribute, and we point it at our gateway interface. So we point it to the printer gateway type, and there we can see that our gateway is configured within the integration context.xml file. Now, the one thing we do need to specify for this is a default request channel. And what this means is all requests that are received on the gateway will be sent to this channel. And we want to send them to our input channel. And that input channel delivers messages to our service activator. So here we see our service activator, which is exposing our print service. And if we take a look at our print service, we see that it is just going to print out some information about our message. It's going to print its payload, and then it's going to grab the message number, which is a header on our message, and it's going to print out when it sends a reply for that message. So it's actually placing that in the payload of this newly created message that we are returning from our print service. There you can see that it's specifying the message number that it's sending a reply for. Okay, so let's return back to our integration context.xml file, and now we're going to set up our actual QueueChannel. To do that, we need to add a tag within the body of our channel tag. And it's very simply the queue tag, and each queue allows you to specify a capacity. So this is how many messages can be held in the queue. And it's very important to set this so you don't have any overflow errors. And we're just going to say that our queue can hold 10 messages. So we'll go ahead and save our configuration file at this point. And now let's talk about a change we need to make to our endpoint. So the service activator is going to be the endpoint receiving messages off of our queue. It's actually going to be pulling them at a frequency. So it will invoke the receive method on our input channel. And it will do that quite frequently to continue to check whether or not messages are available on that channel. In order to do that, we need to configure a puller, and we need to put that puller within the body of the service activator. Pullers are used to connect an endpoint to a pullable channel, and we will find that there is support for pullers within the integration namespace. And then when we're working with a puller, we need to specify how frequently we would like it to pull or invoke the receive method on the queue channel. So we're going to go ahead and specify a fixed rate attribute of 5, and that says pull the channel every 5 seconds. It's important to know that the value for the fixed rate is set in milliseconds. So we can remedy that by changing our time unit to seconds. So now we'll invoke that receive method every 5 seconds, and we can also specify a value for the max messages per pull. So this means every 5 seconds pull this many messages, and we're just going to say grab 2 messages off the queue every 5 seconds. So now we need to make some changes to our Spring integration application. And the first thing that we'll need to do is we'll need to auto wire our gateway. So I'm going to remove this direct channel, and we're going to add our printer gateway as a field. So we'll declare its type, and then I'm just going to name it gateway. We'll import the gateway type, And then we will proceed to our run method to build out the implementation of our application. So the first thing we're going to do is we're going to declare a list of futures, and those futures are going to return a message of type string. So we'll go ahead, import those types, and then we're going to name this variable futures, and then we build the implementation. So it's an array list of futures that returns a message that contains a string. Okay, so we'll import all of those types. And at this point, we have our list of futures. Now, what we'll do is we're going to iterate through a loop 10 times. And for each iteration, we're going to build a message using the message builder. And we're going to specify that the payload of this message is printing message payload and then 4, and then we'll end our string, and then we will add our sentinel value there. So we're just going to have message 0, 1, 2, 3, and that way we can just uniquely identify these messages. So we're going to then invoke the build method, and that's going to provide us with our message. And now we're just going to add some debugging that says, hey, we're printing out the message. So we're going to say sending message, and then we're going to print out the number of the message that we're sending. And then we're going to add the returned future from our gateway to this list. And this is just a way of dealing with futures in Java. So here we're invoking the print method on the gateway, and we are passing it the message. So that's going to pass the message to our QueueChannel. And what you'll see is that the execution will not stop here. We'll continue passing these messages until they are all passed to the queue. Now we're going to iterate through our futures using a for each loop, and we're going to get each individual future from our list of futures, and then we are going to invoke the get method on the future. So that's going to get the value that's returned from invoking the print method on our gateway, and that will be of type message, and then we're going to get the payload and print it. Now, we'll need to handle the possible exceptions that can be thrown when working with the future. So there we just can add the throws declaration, and that will add the appropriate message handling onto our method. So before we run our demonstration, we'll do one last thing, and we'll add a header to our message. So we'll invoke the setHeader method, and we need to provide the name of our header, and it's going to be message number, and then we can pass in the value that we're iterating through. So there we went and added a message number. That way the print service knows which message we've sent. Okay, so with that in place, we can go ahead and run our application, and we'll take a look at the console output. And there we see that all of our messages were sent, and as we were iterating through the loop, we sent them in order. But now what you're seeing is that they are being pulled off of the queue in a different order. So this is just evidence that they are being processed asynchronously. So instead of sending message 1, waiting for the service activator to process message 1 and send it back, we actually did it out of sequence with how we processed all of these messages. And that's just to demonstrate the asynchronous behavior of a QueueChannel. So in this lesson, we learned how to set up a QueueChannel, which allows us to queue up messages, and those messages can then be pulled by a consumer in order to work the messages off of a queue using a buffering type of fashion. In this lesson, we'll learn how to use the priority channel. The priority channel is very similar to the QueueChannel except for one major difference. Both channels store messages in a queue for a consumer to pull. However, instead of using FIFO or first in, first out ordering like the queue channel, the priority channel allows us to specify the order in which the messages should be processed by pulling consumers. We'll see two different ways to specify the priority of a message on the priority channel within this lesson. Using these approaches, we can control which messages will be pulled from our queue. To get started, let's take a look at our Spring Integration application class. Within this class, we are building out a message. And if we take a look at one of the methods on the builder pattern for the message builder, we'll see that there is a set priority method. And setting this priority allows us to dictate when a message should be pulled from a priority channel. And remember, the priority channel contains a queue. So what we're going to do is we're going to simply set the priority to the X variable's value. So as our sentinel value is increased in our loop, it's going to continuously raise the priority of our messages, and the highest priority will be pulled from the queue first. So now that we have set the priority header on our message, we need to change our channel implementation over to a priority channel. And the way we do that is by changing the type of our queue within the channel tag. So we're going to reference the integration namespace, and we will use the priority queue tag to specify that we would like to use a priority channel. Now you'll see that this tag contains a capacity attribute, and we always want to set that attribute when working with a queue. Now that we have established a priority channel, let's run our application. And what we'll see is that the messages that have a higher priority will be processed first by our service. And our service is going to simply print out the message. So let's go ahead and we can run this demonstration, and we'll watch our console to see its output. So there we see the messages got sent to our priority channel in order, and now you can see that they're being processed in reverse order, and that's because we have assigned higher priorities to the later messages. So there our priority channel functioned as we expect, and that's the first way that we can establish a priority for a message, and we simply set the priority header on the message. Now we're going to take a look at another way to set the priority on a given message. So we're going to go ahead and remove the invocation of the set priority method. And now we're going to take a look at our custom message comparator. So this comparator simply compares messages, and in our case, it's going to pull the last character of a message, and that's going to contain the number of the message. So take a look at how we build the payload, and here we see that we attach the sentinel value at the end of our payload. So our comparator is just pulling that number, and then it's determining whether or not that number is odd or even. Any even numbers are placed at the front of the queue, and the odd numbers go to the back. So in a sense, we're prioritizing the evens over the odds. Now, in order to use that comparator, we need to make some changes within our integration context.xml file. And what you'll see is that we have a comparator attribute that can be specified on our priority channel. So we pass in this comparator, it compares our messages, and that's how it determines their priority on the queue. So in order to supply a value for that comparator attribute, we need to declare a new bean. And we're going to name this bean our custom comparator. And when we specify the type of our bean, it's going to be a custom message comparator. So now we have our bean declared. It's within our Spring IOC container. and we can reference that bean using its ID so that it is referred to when looking for the comparator for our priority channel. So with our comparator in place, I'm now going to go ahead and decrease the rate at which we pull. That way we don't interrupt our demonstration by pulling the messages off the queue too quickly. Now we can go ahead and we'll stop our application, and then we'll navigate to the application and relaunch it, and then navigate over to our console where we can watch our output. So there you can see that the even messages are being processed first. And when we run our next iteration, we'll see that the messages are indeed even. The comparator provides us with another way to specify the priority that messages will be taken off of our priority channel. That concludes our lesson, and I hope you enjoyed taking a look at this alternative channel implementation provided by Spring Integration. In this lesson, we'll be taking a closer look at the direct channel. The direct channel implements the subscribable channel interface and is unique in the fact that it will only deliver a message to a single subscribed message handler. Within the internals of the channel is a round-robin load balancer that will alternate between message handlers when sending messages. We'll be taking a closer look at the load balancer to learn more about direct channels. So before we get started, we're going to take a closer look at our project. So within the Spring Integration Application class, you'll see that inside of its run method, we have a loop that creates 10 messages, and the payload of these messages contains the message number, and then we send that message to a gateway. And if we look at the Spring Beam configuration file named integrationcontext.xml, here we see the declaration of our gateway bean, and we see that it passes messages to the input channel. The input channel is connected to a service activator that passes the message to a print service bean. And we can take a closer look at that print service bean and see that it has one method named print that accepts a message, and it simply prints out the payload of a message. And it's receiving that message from the service activator, which is connected to the messaging architecture by that direct channel. So in order to demonstrate the load balancing capabilities of the direct channel, we need to create another endpoint. So we're going to copy our print service, and then we're going to paste it within our package, and we'll need to change the name of our print service class. So I'm just going to call it uppercase print service, and I bet you can guess what we're going to have this class do. So let's open up the class, and here we're going to keep a print method on this class, but we're going to send the payload, which is going to be the string, to uppercase. And now what we'll need to do is connect that print service to the messaging architecture. So first it needs to be a bean, and I'm going to name that bean uppercase print service. And then we need to change the type of our bean to point to the appropriate type. So now we have a bean, and we need to connect that bean to the message channel, and we'll do that using another service activator. So what we're trying to do is we're trying to expose that bean and connect it to the messaging architecture so we can invoke it. All we need to do is point our service activator to the uppercase print service bean via the reference attribute, and we still want to invoke the print method, and we want to receive messages from the input channel. And that's enough to set up two endpoints that are going to receive messages from the input channel. Now remember, only one message will be sent to one endpoint at a time, and our round-robin load balancer will alternate the messages. So let's head to our application, and we'll run the application and take a look at our console output. So there we see that our messages came in, and you see that the first message gets uppercase, so it went to the uppercase print service. The second one's lowercase, and then we go upper. So there you see the round robin load balancer in action because we're alternating the endpoints that we send our messages to. Now let's navigate back to our integration context file and run through another demonstration using the load balancer. So you probably noticed that the first endpoint we sent a message to was the uppercase print service. Well, we can determine which order our messages are sent by using the order attribute on the endpoint. So I'm going to specify that the uppercase print service is second in our order, and the regular print service is first in our order. So this means we're going to send the first message to the print service, the second message to the uppercase print service, and the load balancer will then just repeat that pattern. So let's run through this demonstration and we'll watch our console. And this time we see that we sent our first message to the regular print service, the second went to the uppercase print service, and that was all controlled using that order attribute. Now for our next demonstration, we're actually going to return an error from one of our print services. So we'll go to the vanilla print service, and we're just going to throw a new runtime exception. And this exception can say anything. So this is an error, and we'll throw it from our method. What we're trying to replicate here is the print service is failing. So the print service fails, it throws some exception up to the messaging architecture. And what will happen in this case is that the messaging architecture will then send the message to the other endpoint on the load balancer. So we're having a failover occur here when one endpoint fails to process a message. The messaging architecture is smart enough to fail over and use our other endpoint, which in our case is the service activator attached to our uppercase print service bean. So now we're only going to see uppercase output when we run this demonstration. Okay, so there we see all of the output is uppercase as we expected, and now we have one more demonstration to run through. So what we haven't done is really shown where the load balancer would be explicitly specified, and that is within our channel. So because we haven't specified any special channel type, we default to a direct channel. And then within that direct channel, we can add a dispatcher, and that dispatcher represents our load balancer. And if we take a look at that tag, we see a couple of attributes. So there we see the failover attribute, and we can actually turn off failover. And in this case, our application will fail to run. And we'll run that demonstration in a minute after looking at our other attributes. We can also specify the maximum amount of subscribers to this channel, so that's a way we can limit how many endpoints connect to the input channel or our direct channel. We can also specify the load balancing strategy, and there's very few choices here. You can specify round robin, which is the default, and that's just alternating between endpoints, or you can specify that you would like no load balancing strategy. And then finally, you'll see that there is the load balancer ref attribute. And that attribute can be used to specify your own implementation of a load balancing strategy. So if you had something special that you'd like to see occur with how these messages are dispersed, you could provide that implementation. So what we're going to do, we're just going to specify that the failover is false. So now what we'll see is that all of the messages that are sent to the print service, which is going to return an exception, will not fail over and hit the uppercase print service. And we'll actually get an exception within our application. So let's go ahead, run our demonstration, and there we got our exception. There we see the runtime exception printed to the console. It's one of the rare instances where we are happy to see an exception because it really validates our proof of concept. So in this lesson, we took a much closer look at the direct channel to see how we can customize the behavior of the load balancer within that channel. And remember that the direct channel implements the subscribable channel interface, and that allows multiple endpoints to subscribe to the channel, but a message delivered on that channel only reaches one of those endpoints, and there is also that failover capability. In this lesson, we'll learn about Spring Integration's Publish-Subscribe channel. This channel implementation is used to send a message to all subscribed handlers. The Publish-Subscribe channel is primarily meant for sending messages to 0, 1, or many endpoints. The messages sent normally serve as notifications to all subscribed message handlers of a particular event. To begin working with the Publish-Subscribe channel, we need to navigate to our integration context.xml file. And if we look at the channel currently being used, we will notice it is our default channel, DirectChannel. So instead of using our default channel, we want to go ahead and use the Publish-Subscribe channel. So we can put that tag in place. And now we're going to remove our existing direct channel. You'll also notice that our channel is failing over. We had some tests in there that we need to now remove. So we're going to take the runtime exception out of the print method of the print service, and that will allow the service to perform properly. Now, with the publish subscribe channel in place, we can take our direct channel out of the configuration, and we're going to begin building out the publish subscribe channel. The first thing we do is we provide an ID for that channel, and we're just going to name it input channel, and that will replace the direct channel. And at this point, we can go ahead and run our demonstration. That's how easy it is to change out a channel implementation with Spring Integration. But let's talk about what's going to happen here. Once we send the message to the printer gateway, it will then put the message onto the input channel. Now we have multiple endpoints subscribed to this channel, two service activators. Now, unlike the direct channel, which would only send the message to one of our service activators, the publish subscribe channel will notify both of these endpoints because they have subscribed to the input channel. So let's navigate over to the Spring Integration Application class, and here we see within our run method, we're simply going to send 10 messages to that channel. So let's go ahead and we can run our application, and now we'll see that we print out our messages to the console. And you'll notice we now print out 20 messages. If this were a direct channel, we would only print 10. And we see that both our regular print service and the uppercase print service are receiving the message and printing it out. You'll also notice that the messages are being handled sequentially. So that is because we are not using any threading here to achieve these messages being printed or sent to our endpoints concurrently. So now we'll take a look at a task executor to see how we can send and process our messages in parallel. So what we'll need to do is navigate to the namespaces tab, and we'll add in our task namespace. With that namespace in place, we go back to the source tab and we'll build out our task executor. So we use the task namespace, and then we choose the executor tag, and I'll just name our task executor executor. And then if we look at the attributes on this tag, you'll see that we can specify the pool size, and that's how many threads are going to be within this task executor. And now what we can do is on the publish subscribe channel tag, there is a task executor attribute, and that allows us to point to a task executor bean within the Spring IOC container. So we point to that reference. And now if we navigate back to our application class and we run through the demonstration, what you'll see is that our messages are processed in a non-sequential order. It's not a very good demonstration here, but you do see that we process message 1, then we get message 0 and 0, so that's out of order. We process 8 out of order. Let's run this again and see what our results look like. Maybe we can get a better example here. Okay, and this is a little bit better. There we see the third message executing way towards the end of our output here. So that's a better illustration of how these messages were executed non-sequentially, and that's because we used a task executor in combination with our publish-subscribe channel. So that concludes our lesson on the publish subscribe channel within Spring integration. It is a subscribable channel that is capable of sending the same message to multiple endpoints, and that's really its function. It normally serves to notify different message handlers of events that have occurred so they can perform some sort of processing. In this lesson, we'll learn how to use a messaging bridge to connect two channel implementations. Often we'll use a messaging bridge to connect a polling channel to a subscribable channel. This allows us to hide polling configuration from multiple endpoints. To get started, we're going to modify our integration context.xml file in order to interject a pollable channel between our gateway and the subscribable channel. We'll use the integration namespace, and if we look on the namespace, we'll find the bridge tag, and this is going to allow us to connect our two channels. Now you'll notice that we don't have a second channel, so we're going to build that channel as well. And that channel is simply going to be defined using the channel tag, and then within that channel, we're going to create a queue. And we're going to set the capacity on that queue to 10, and then we need to provide an ID for our channel, and we'll call this the pollable channel. And now we're going to modify our gateway to send all of its messages that it receives to the pollable channel. So we have this new pollable channel, and it's going to have a queue that's going to collect these messages, and then we're going to connect that pollable channel to our bridge. And the way we do that is we use the input channel attribute on the bridge tag, and then we set up the output channel. And the output channel is going to be actually our input channel, so what was our old input channel. And that input channel is connected to our service activators, which are encapsulating the print services and tying them to our messaging architecture. Now, since our bridge is connecting to a pollable channel, we need to define a poller. So the poller is going to be set up with a fixed delay, and we're going to set that fixed delay to 5 seconds. We set the fixed delay attribute to 5, and then we're going to set the units for the time of the poller to seconds. And we'll also specify that we only want to pull 2 messages for each iteration our puller goes through. It's only going to retrieve 2 messages off of the queue. Now we have interjected our bridge between a pullable channel and our publish subscribe channel. What we'll see occur is that all of the messages will build up on the queue, and then the puller is going to pull 2 messages every 5 seconds and send them to the publish subscribe channel, which will then send the messages to both of our print services. So this is helpful because we're able to queue up messages on our pullable channel. And what that does, it allows us to throttle how we would send our messages to the endpoints that are subscribed to our publish subscribe channel. And that's all made possible by the bridge. Let's see it in action. So we'll head over to the Spring Integration Application class, and then we're going to run our Java application, and we can watch our console output. So there we see the messages being pulled off of the queue every 5 seconds, 2 of them, and then they are sent to both of our print services, the uppercase print service and the lowercase print service. And eventually here we'll see the execution wind up once all the messages are sent, and that completes our demonstration. Before we wind up this lesson, let's navigate back to the integration context.xml file, and now we're going to look at the integration graph, and this better explains what's going on. We see that we have our gateway, and then the messages go from that gateway to the pullable channel, to the bridge, to our publish subscribe channel, and eventually to our two service activators, which serve as endpoints. So this is another great way to see exactly what is going on the messaging architecture within Spring integration. Spring integration provides us with a channel interceptor bean that can be used to respond when messages are sent and received from a channel. When we attach an interceptor to a channel, we have a hook into the messaging architecture, which can be advantageous for performing operations such as logging or message modification at a global level. In this lesson, we'll walk through an example of how to put a channel interceptor in place. To get started, we'll navigate to the Package Explorer to create a new class. So within the com.o'reilly.integration package, open up the New dialog and type class, and we're going to name our class Custom Channel Interceptor, and we want this class to extend the Channel Interceptor interface provided by Spring Integration. So we'll go ahead and hit OK to include that interface, and then we'll hit Finish and our new class will be built. So on the class, you're going to notice that we're asked to provide implementations for the methods on the Channel Interceptor interface. And you see there's a pre-send method, so that's going to be invoked before a message is sent over a channel, a post-send message, which is invoked after it's sent, and then after we've completed the send. So there's all these different methods that are able to be invoked when sending or receiving a message over a channel. Here we see a pre-receive, a post-receive, so that's if we're pulling a channel. So what we would need to do if we were just going to implement the channel interface is we would need to provide no-op instances of these methods that really don't do anything. The folks at Spring are pretty smart, and what they do is they will provide normally an abstract class that we can extend, and it provides those no-op instances of these methods. So we're going to go ahead and switch our class up to extend the Channel Interceptor Adapter class, and this will provide us with implementations of those methods that really don't do anything. And then what we can do is we can go in and pick the method we'd like to override. So just right click in the source file and then go to source and then override implement methods. And there we see all the methods on the interface, and we can just pick one. So let's go ahead and pick pre-send. Before we send the message, let's do something with it. And what we can do is we'll declare a new message, and we'll just leave its type as unbounded, and we'll name this MSG. And then we're going to use a message builder, and then we're going to create a method with a payload. And what we can do is we can get the original message, and we can say get payload, and since we're passing a string, we'll cast it to a string, and then we'll concatenate and say message intercepted, just to show that we're able to grab this message and then perform some modification to it and return it back from our channel interceptor. And then what we'll need to do here is we'll need to pass our newly created message. So here we're doing some active modification of the message. And we could do all sorts of things within this method. We could maybe notify some other system what's happening for auditing. Anything we can pretty much imagine can be done within this interceptor. Now, we've built our interceptor. The next thing we need to do is wire that interceptor into our Spring IOC container so that Spring integration can use it as part of the messaging architecture. And we do that within the integration context.xml file. So from this point, it is pretty simple. anytime that we want to use a bean, we need to register it with the IOC container. So I'm just going to declare a new bean and I'll name it Interceptor. And then I'm going to specify the type of that bean as our custom channel interceptor. And now it's available within the IOC container. And then what we can do is we can register that interceptor with a channel. So I'm going to register it with our pullable channel. And the way we do that is if we look at the integration namespace, which you should realize is becoming very helpful by now, we have this interceptors tag, and then we can specify a reference to a channel interceptor. And I just reference the bean by its name. And now we have our channel interceptor wired into our messaging architecture. And every time we send a message, we're going to make that modification where we actually copy the payload, create a new message, and then ship that off on our pullable channel. And eventually it's going to wind up hitting our bridge, which is then going to send it to the publish subscribe channel. And then it's going to hit our two service activators, which are specified as endpoints. So with that in place, let's navigate to the Spring integration application. And we'll fire off the app and then head to the console to see if everything behaves. So there we can see we're modifying the payload that we originally sent. We're adding that intercepted string. We concatenated on there. We're performing active interception of this message, and we're doing some logic, and that's occurring all thanks to the channel interceptor provided by Spring integration. This chapter begins our discussion of Spring Integration's endpoints. Within Spring Integration, there are a large number of endpoints due to the various operations we need to perform on messages. Some endpoints do the heavy lifting within our applications, enabling us to integrate with external systems or tying important business processing components to the messaging architecture. Other endpoints are more supportive of the messaging architecture, performing tasks related to how messages flow within Spring Integration's messaging system. Given the large amount of endpoints available, we'll be dividing our coverage of endpoints into different subsets associated with chapters. This chapter focuses on how the router, filter, splitter, and aggregator endpoints support Spring Integration's messaging architecture. Let's take a closer look at what our chapter will be covering. As we mentioned, we're going to learn about a subset of endpoints within Spring Integration. There's a large set of endpoints within the framework, and we're going to focus on some that really support how we send messages through the architecture. And that's going to give us better control over how we work with Spring Integration and how our messages flow through the system. Particularly, we'll be looking at how we can direct a message to a specific endpoint using routing. We'll also see how we can limit messages from being passed through a channel downstream to another endpoint by using filtering. Then we'll see how we can distribute messages by splitting them and sending parts of those messages downstream through our message flow. Finally, we'll see how we can take multiple messages and combine them back together to make a single message with an aggregator. It's very helpful to see these different flows depicted visually, so I'd like to just go over a couple diagrams very quickly to show you what we're going to be talking about throughout the chapter. First up is the router. I'm sure you all have a router probably sitting somewhere within your house that is allowing you to connect to the internet right now to view this. And the simple job of the router is to take messages off the channel, and based upon some logic, it sends those messages to various endpoints. So your home router, you probably have multiple machines connected to that router, and it is responsible for routing your traffic to the appropriate machine or PC that requested it. The messaging router within Spring Integration simply has some sort of logic embedded within it that says, hey, take this message and route it to this particular channel, and then that message is going to wind up on an endpoint connected to that channel we route to. So in this diagram, we see all of the purple messages, and maybe that's our criteria, being routed to the purple endpoint, and all the burgundy messages being routed to the burgundy endpoint. And the logic to perform that is embedded within the router. Next up is the filter. And here we see that we're getting some messages coming in from the channel, and they hit the filter endpoint, and then only selective messages are passed on to the channel to be delivered to the next endpoint. So in this case, our filter is rejecting all of the burgundy messages and passing on the purple messages to the endpoint through the channel. That logic is coded into the filter, and there's something about that message that we're going to inspect, and depending upon the state of that message, if it satisfies our criteria or not, we will then allow it to pass downstream in our messaging flow. Next is the splitter. So the splitter receives a message from a channel, and then it divides that message into two subsequent messages. So here we see our blue message coming into the splitter, and then we divide it into two smaller messages. Now they're still messages, but they are a subset of the first message we received, and those get passed on to our endpoint. The opposite of the splitter is the aggregator. So the aggregator takes in two messages, combines them into a larger message. So here we see two messages, a burgundy message and a purple message, coming into the aggregator, and the aggregator bundles them together within a single message that is then delivered to the endpoint. Often you'll find an aggregator downstream from a splitter. So you may want to split a message to allow for parallel processing, and then eventually you aggregate that message back together. So we'll be working with these various types of endpoints throughout the chapter. We'll see different implementations of each endpoint, and we'll even learn how to create our own custom implementation of many of these types of endpoints we just saw. And then we'll see how we take those and tie them into the messaging architecture so we can control the behavior of how our messages flow through Spring Integration's messaging system. This lesson will teach us about Spring Integration's payload type router. The payload type router is available out of the box and allows us to route messages based upon the type of a message's payload. The router will inspect the payload of a message and then conditionally route the message to the appropriate channel as defined by mappings that link Java types to target channels. Like any router, the payload type router allows us to dynamically decide which channel should receive a message. Let's work through a demonstration that shows how easy it is to use this router. To get started, let's take a quick look at our project. If we inspect the integration context.xml file, you'll see that our context sets up a gateway that's going to accept a message and pass it to the input channel. The input channel has two endpoints that are subscribed to the channel, and those endpoints are our two service activators. So here we see a numeric print service as well as a regular print service. The numeric print service is a newly created print service, and all that print service does is it accepts a message of any type, and then it applies this printing the numeric string literal before printing out the payload. So we have these two types of print services which are encapsulated within our service activators and attached to the messaging service. So in order to set up a router, we need to use the integration namespace. And what we'll do is we'll create the new tag, and we will see the payload type router tag. And within this tag, we define our mappings. So if we take a look at the available contents we can place within the body, we see that mapping tag. Now, before we specify our mappings, we'll set the input channel attribute on our router. This is the channel that our payload type router will receive messages from. In our case, we're going to receive them from our input channel that will be fed by the printer gateway. Now we need to define our mappings. So the first thing we specify is a type, and this is a Java type. So we're going to route all integers, and we specify java.lang.integer, and then we specify the channel we would like to send them to. So I'm going to make a channel called int channel, and that channel will receive our messages that have a payload type of integer. So we need to navigate down to our service activator that is associated with the numeric print service, and we're going to change that channel to receive messages from the int channel. Now we'll head back to our payload type router, and within the body we're going to define another mapping. And this time we're going to have the type java.lang.string routed to a channel named, you guessed it, string channel. So now we have a string channel that we are going to connect to our regular print service. And we do that by changing the value of the input channel attribute. So we say we'd like the string type, when it's found in the payload of a message, to be routed to the string channel. And that's going to pass our messages to our regular print service. With the payload type router in place, I'm going to navigate to the Spring Integration Application class. And from here, we can right-click on the class and run it as a Java application. And if we inspect our console, what we'll see is that all of our messages were sent to the regular print service. So we don't see that string literal being prefixed to our console output. And that makes perfect sense because if we look at the Spring integration application and at this for loop, you can see that our payload is definitely a string. Now, what happens if we change up our payload so it's now an integer? And we'll need to change our message now, and we'll just have the message be a wildcard type. And the payload is now an integer, so we expect it to route to the numeric print service. And if we take a look at that service, we see we're going to get a prefix. So let's now run our application one more time, and we will get our expected console output. So there we can see that the messages were routed to the numeric print service because of those mappings that we defined within our payload type router. Now let's just take a moment before we conclude our lesson and look at some of the attributes available on the payload type router. So an important attribute is the default output channel, and this is the channel that will be sent our message if there is no match for the payload. We're also able to specify that we would like to ignore failures when the router fails to route a particular message. This can occur when more than one channel meets our mapping requirements. We're also able to specify a timeout, and this will determine how long we wait before sending the messages onto a particular message channel as specified in our mapping. So there's plenty of attributes there you can explore to change the behavior of the payload type router. Another way that Spring integration allows us to route messages is by using a header value. When we would like to conditionally send a message to a channel based upon a header value, we can use the header value router. When using the header value router, we specify a name of a header, and then we can associate different channels with the values that may be provided for that header. In this lesson, we'll walk through establishing a header value router bean and including it within the messaging architecture to route messages. Getting started with the header value router is fairly simple. All we need to do is navigate to our integration context.xml file And within this file, we are once again going to leverage the integration namespace. And within that namespace, we find the header value router. And this has an attribute that we need to supply, and that's the input channel. And in our case, the input channel will be the input channel. And that channel will receive messages from our gateway and pass them to our router. Now, the next attribute is important. It is the name of the header that it will inspect on a message. And we're just going to name that header route header. At this point, I can go ahead and I'll remove the payload type router from our messaging architecture, and I'll save our integration context.xml file. Now we can navigate to the Spring Integration Application class, and we can add our header to the message that we build. So we invoke the setHeader method, and this method accepts two arguments. The first is the name of the header you would like to add to the message. So in our case, that's the route header. And then we can specify a channel name. So I'm just going to directly specify the int channel, and that will cause our message to be passed from the router to the int channel. And if we take a look, we see that the int channel is associated with our numeric print service. So now if we run our application, what we'll find is that all of our messages are passed to the numeric print service thanks to our header value router. Now, if we return to the integration context.xml file, we can work the configuration of this router a little bit differently. So what we can do is we can provide explicit mappings. So here we can say that we would like to pass all messages that have a route header with a value of int to our int channel. And we'll do the same for strings. So we're going to say all messages that have a header named route header that has a value of string will be passed to our string channel. Now, one modification we will need to make for our demonstration is we're going to make our print service a little bit more generic, and we're just going to specify a wildcard as the type parameter for the message. Now, if we return back to the Spring Integration Application class, what we can do is we can specify a value of string for the route header header. And now when we run our application, all of the messages will be passed to the regular print service that just handles strings and doesn't do any prefixing onto our message. So in a nutshell, that is the basic function of the header value router. You can also specify a default output channel, which would receive all of the messages in the case of a failure. So there's additional configurations that you can apply to affect the behavior of our header value router. Spring Integration provides another type of router known as a recipient list router. The recipient list router allows us to statically define a list of message channels that should receive a message passed to the router. In this lesson, we'll walk through a demonstration of the router and some of its more advanced configurations. Thanks to the Spring Integration namespace, it's fairly simple to get started with the recipient list router. Within our integration context.xml file, we're going to open up that namespace and then select the recipient list router tag. And while we're building out our new router, we're going to remove our old router. So the first thing that we'll need to specify on the router is the input channel. So this is the message that our recipient list router will receive messages from. And that's going to be our input channel, which will be fed by our printer gateway. Now, within the body of the recipient list router, we're going to specify a recipient. And in this case, we're going to pass the message to the int channel, and then we can go ahead and specify another recipient. And in this case, we're going to pass the message also to the string channel. And that's going to cause our two service activators to receive the message. So let's navigate to our application, and we'll kick it off and take a look at our console. And if we inspect the console output, we do indeed see that both of our endpoints have received the message. So that's pretty simple. Let's move into a little bit more of an advanced configuration. If we inspect the recipient tag, we see the selector expression attribute, and this allows us to specify a spell or Spring expression language expression that will determine whether or not a message is routed to our matching channel. So in this case, we're going to define an expression, and if that expression is satisfied, then the int channel will receive the message. If not, we will not pass the message to that channel. And we can reference our payload, and we're going to say that our payload equals 5. And if we inspect our application, we see that we are running through a loop, and with each iteration we pass in the counter value, so it will indeed be 5 at one point, and that's going to cause that message to go to our service activator that is subscribed to our numeric print service. So let's go ahead and run our demonstration again. And if we inspect the output, here we see that we did indeed pass the message with a payload of 5 to the numeric print service, but the other messages were not passed. And that's because we were able to use that selector expression to conditionally route to this channel. So let's say that we have specified the same selector expression on our string channel recipient tag. And we're going to set both of them to, let's say 51, so it's not going to match any of our messages. One of the things we can do is we can specify a default output channel. And this is a channel that will receive the message if none of our recipients resolve the message. So let's go ahead and build out a new channel, and I'll just name this channel default channel. And then I'm going to add that channel to our configuration, and we'll specify that channel's ID. And now what we're going to do is within our com.o'reilly.integration package, I'm going to copy the print service, so just Control C and then Control V, and I'm going to create a new service named default service. So now we have our default service. Just hit OK, and it will build the class for us. And now we can open that class. Within the print method of the default service, we're just going to output a message to the console that allows us to know we are printing this message from the default service. So let's just say printing from the default service. And that will let us know that we have indeed passed our message to this service. Now, in order to have this service be wired into the messaging architecture, we need to build a bean, and we'll call it the default service. And we're going to have the bean be of type default service. And once we have that bean, we can go ahead and create a service activator, which will refer to that service and connect it to the messaging architecture. And we're going to connect it to the default channel. So what will happen is that we're going to send a message to our gateway, and the gateway is going to place that message on the input channel. The input channel is going to drop that message off at our recipient list router. It's going to consult our two recipients and their selector expression and see that there's no match. When there's no resolution of a channel for that message, it's then going to pass the message to the default output channel, and that is named default channel. The default channel is connected to our service activator, which is referencing our default service. And that's going to cause our message within the default service to be printed. So let's navigate over to the application and we can fire it off and take a look at the console output. So now if we inspect our console output, we see that each of our messages was sent to the default service, and that's as we expected. And just know that the default output channel can be found on many endpoints, and it's a way to just have a default channel that can handle all of the messages. So in this lesson, we learned about the recipient list router and how we can use it to statically route messages to various channels, as well as control the routing via a selector expression and a default output channel. In this lesson, we'll learn how to construct a custom message router and connect it to the messaging infrastructure within Spring integration. This approach allows us to define our own logic for how messages should be routed, then add the custom endpoint into our integration flows. Let's get started by first creating a new class for our message router. So I'm going to navigate to the com.o'reilly.integration package, and I'll open the new dialog and type class. I'm going to name our new class Custom Router, and then we want to inherit from the Abstract Message Router class. And once we have placed our superclass in place, we can go ahead and hit Finish. And now we're going to be able to define our new router. The way we implement our new router is by providing an implementation of the determineTargetChannels method. And we see that this method returns a collection of message channels. So let's go ahead and first create our collection, and it's going to have a generic type of message channel, and we'll just call this target channels. And then we need to create the implementation, so we're going to just use a simple array list that is typed for message channels, and we'll import those types. And now what we'll need to do is add the channels that we would like our message to be routed to this collection. Well, we don't have any channels on hand, so what we can do is we can auto-wire in our available channels. And the way we're going to do that is by using the auto-wired annotation and the qualifier annotation to grab our int channel. So we can import these types. Then for the qualifier annotation, we need to provide the ID of our message channel bean. And in this case, it's going to be the int channel. So we've now auto-wired the int channel into our abstract message router. We're going to add an additional channel, the string channel. So we just need to change our names and our qualifier, and we now have hooks to both of those channels. Now let's just do some simple routing based upon the payload. So I'm going to use our message, and I'm going to grab the payload, and then I'm going to get the class, so now I know its type, and I'll just check if its type is equal to an integer. And if it is, what we'll do is go ahead and add our int channel to our collection. So there we add the int channel to our collection, and now we can add another conditional, and once again we're going to work with the payload, get its class, and then we're going to check to see if it's a string. And in this case, if it's a string, I bet you can guess that we're going to add our string channel to the collection. And then finally, we can return our collection, so our target channels are returned from our determineTargetChannels method. And at this point, we have established our custom router. Now we need to integrate it into the Spring IOC container. So this needs to become a bean so that it can have the auto wiring achieved, and also so that it can be used as a bean within our messaging architecture. So let's navigate to the integration context.xml file, and within this file we are going to establish our bean for the custom router. So we add the bean annotation, We're going to give it an ID of custom router, and then we need to specify its type, and its type will be of type custom router. So now we have this bean, and we can actually remove our recipient list router because it's going to get replaced, and we'll replace it using the router tag within the integration namespace. And within the router tag, we will find the ref attribute, and this ref attribute just says point me to a bean of type router, and we can then point to our custom router, which extends the abstract message router class, which is ultimately what Spring Integration is asking for. And then we specify the input channel. So this is the channel that is going to deliver messages to our router. And in that case, it's going to be our input channel. And at this point, we have integrated our custom router into Spring Integration's messaging architecture. Now we can navigate over to our Spring Integration application class and run our demonstration. So what we should find when we run this demonstration is that all of our messages will be routed to our numeric print service. And if we quickly take a look at that print service, we see that it just adds a little string literal before to say which service it's coming from. So let's go ahead and we can run our application. And as expected, our console output does come from the numeric print service because our custom router sent the message to that endpoint. So let's just test now, and we'll change the payload of our message, and we'll make it, this is a string, just so there's no questions there. And now what we should see is that our custom router is going to route the messages to the regular print service, which just prints the payload. Okay, so we're running the application again. And when we look at the console output, we see that we went to the appropriate endpoint because our router and its logic was able to direct the message to the correct channel. So in this lesson, we took a look at establishing our own abstract message router, which can then be built into Spring Integration's messaging architecture. And this is really a great way, if we have very complex routing logic that we need to perform, of encapsulating it within a component inside Spring Integration, and then introducing that component into the flow of our message. In this lesson, we'll take a look at another endpoint, the filter. As its name implies, filters are used to decide whether messages should be passed or dropped on a message channel. The logic used by a filter to make this decision can be configured in several ways. In this lesson, we'll set up a basic filter and perform some message filtering within our application. Before we get started, let's do some work to clean up our application. We're going to remove our custom router, and then we're also going to remove the numeric print service. We won't be using those beans for this lesson. And then we're going to navigate to our integration context.xml file, and we'll need to remove the custom router as well as the router tag. We can take out the default channel, our numeric print service, our default service, as well as the service activators associated with them, and then finally our service activator associated with the numeric print service. So now we have a very basic messaging architecture set up. We just have the printer gateway, which is going to accept messages, pass them to the input channel, and then they're going to be passed to the service activator, which relies upon the print service bean. So now we're going to interject a filter within this flow. The first thing we can do is we can rely upon the integration namespace, and on that namespace is a filter tag. So we'll add that filter tag, and if we take a look at the attributes on the filter tag, you'll notice the input channel attribute. And we've seen this in the past. It's just the channel that will supply this endpoint with messages. Now what we'll also see is an output channel, and this is the channel this endpoint will supply with messages. So the input channel brings the messages into the endpoint, and then the output channel is where our endpoint places them for delivery to the next endpoint. In our case, we're going to use an output channel named output channel. Now, it's important that we define that channel so that we have a channel within the IOC container that can be referenced here. So we want to create a new channel and we name it output channel. So now we have a messaging channel available on the Spring IOC container and available to the messaging architecture for our use. The final thing we'll do with our filter is we're going to specify another attribute, and that attribute is an expression. So the expression can use the Spring expression language, and this expression will be consulted when making the decision whether or not we want to pass along a message or whether we want to just drop that message and not pass it to the output channel. So the message comes in on the input channel, we evaluate the expression. If the expression returns true, we pass it to the output channel. If not, we drop the message here at the filter. So using the expression, we're going to reference the payload, and we're simply going to say, does the payload equal 4? And we can save that, and we now have our filtering expression. So if you take a look at spell, you'll see there's all sorts of different tools you can use within that package to create your expression. We'll see some more advanced ways of filtering as we move on. Now, if we navigate to the Spring integration application, we're going to change our application to build a message that simply uses the counter variable in the loop, and let's even take this header off of there. Okay, so what we should see now is that only messages that have a payload equal to 4 will be sent to our print service. All of the other messages will be dropped, and that's thanks to our filter. We see it takes the messages in from the input channel, sends them to our output channel, and then our final configuration, we'll need to make sure that the activator receives messages from the output channel. So with that in place, we can go ahead, run our application, and now we will see that the only message that gets sent to our print service is our message that has a payload of 4. And that was determined by the expression that we set up on our filter. Spring integration allows us to create custom filters to handle our advanced filtering requirements within our applications. The custom filters are created by providing an implementation of the message selector type. The message selector allows you to build custom logic that can be integrated into and consulted by the messaging service when filtering messages. In this lesson, we'll set up a message selector and build it into the messaging architecture within Spring integration. So to get started, we need to build out a new message selector, and to do that, we create a new class within our com.o'reilly.integration package. So we'll select a class, and let's just call this class Custom Filter, and then we need to implement the message selector interface. So we can click on the Add button next to Interfaces, and then select the message selector. With that interface chosen, hit the Finish button, and the IDE will build out your class. Now, within this class, we can provide some logic to determine whether or not we'd like to filter the message or allow it to be passed through our filter. And the accept method is the mechanism we use to do that. You see that it returns a Boolean, and it provides us with an argument of type message. So we're able to take the message, inspect whatever we'd like about it, maybe the payload or the headers, and based upon some sort of logic, we pass back either true or false. True if we would like the message to be passed through, and false if we would like to filter the message and not allow it to continue along the messaging architecture. So we're going to just set up a very simple filter here. So we'll just grab the message, we'll get the payload, and say, is it equal to 7? And at this point, we have our implementation of the message selector. Now, Spring integration is capable of recognizing this interface and working with it to filter our messages. And where we integrate it into the messaging architecture is within our configuration. So as you probably guessed, the first thing that needs to happen is that this custom filter needs to be declared as a bean. So we specify a bean of type custom filter, and then we're going to give it an ID of custom filter. So now this bean sits on the Spring IOC container. And then what we can do is we can remove the expression from our filter tag, and we can simply have our filter refer to that bean. So we have this filter that is tied into Spring Integration's messaging architecture, and when it receives a message from the input channel, it's going to consult our custom implementation of the message selector named custom filter, and that's going to return it a Boolean value of whether or not we would like to allow the message to continue to be processed. And that's really all we need to do to put a custom filter in place. If we navigate to our application file, we can kick it off and run the application, and we should only see the message number 7 being passed to our print service, and there we see that happening. So this is a lot like setting up a router. You'll find that there is some sort of interface that you must implement, or some abstract class that must be extended, and then we turn our implementation into a bean, and we use the integration namespace to then pull those components in the messaging architecture, and that helps us specify the behavior of how our messages are routed. Spring integration provides an endpoint known as the splitter, which we can use to separate a message into multiple parts. The resulting parts are then sent independently through the messaging architecture. Within this lesson, we'll learn how to configure a splitter and see it in action. In order to work with a splitter, we'll need to create a new class within the com.o'reilly.integration package, and we're going to name this class Custom Splitter. We need our class to extend the abstract message splitter, so we're going to click on Browse next to Superclass and simply type abstract message splitter. And we'll select that type, and then we can hit Finish and our new class will be built. Now on our custom splitter, you see that we need to override the split message method. And this method accepts a message as an argument, and it has a return type of object. Spring integration is able to recognize this type and use it to split messages. Now when we split a message, we need to return one of 3 types. We can return a collection or an array of messages, we can return a collection or array of non-messages, or we can return a message or a non-message object. So we're going to walk through returning a collection, specifically a list. So we're going to return a new array list, and it's going to be of type string for its generic type. And then what we'll do is we'll use arrays.asList in order to get our message and then get its payload, convert the payload to a string, and then we are going to invoke the split function, and we're going to split by white space. So there we see the implementation for our custom splitter. What we're doing is we're just taking the message, we're getting its payload, splitting it into a string array, then turning that array into a list, and then returning that a list to Spring integration. And it's capable of splitting our single message into multiple messages. What will be returned from this method is a list that has multiple strings, and each one of those items within the list will become its own message and will be sent further down the messaging architecture on our output channel. So with our custom splitter set up, now we need to navigate to the integration context.xml file, and here we're going to create a bean that is going to be named custom splitter. And you can probably guess the type of this bean is going to be the custom splitter type. And then we'll remove our filter. And if we inspect the integration namespace, we find our splitter. And we can then specify some attributes on the splitter. So the first attribute we're going to specify is a reference to our splitter bean, so custom splitter. And then we need to define an input channel, and that input channel will supply the splitter with messages, and our input channel will be named input channel. And now we need to tell the splitter where to send the messages, and to do that we use the output channel. So there you can see what will happen is we pass a message to the gateway, it hops on the input channel delivers the message to our splitter, which refers to our custom splitter, and that's going to separate the payload by its white space, and that return collection will get sent to our service activator, which encapsulates our print service. So now let's navigate over to the Spring integration application, and we'll need to change our message payload for this demonstration. I'm simply going to use my name, so Kevin Bowersocks. We see there's white space within it, and if we run our demonstration, we can take a look at the console, and you'll notice that my name was split 10 times. So we ended up with 20 messages. Each line is going to represent a message, and we did this within a loop. So my name was sent, Kevin Bowersocks, that string literal, was sent to the gateway, eventually winding up at the splitter, and each time the message was split on the white space and multiple messages were produced. So that is one way to configure a splitter. Now, we don't even need to extend our abstract message splitter. I much prefer this route because then we just have this strongly typed object. We know what to expect as far as the method we need to override, but we can use a little bit more of a loose approach. So we can not extend that object, and let's change up our method name to split. And then I'm going to clean up our imports. And remember, we need to return a type, which is a collection or an array. So I'm going to return a list of strings from our method on the custom splitter. And we're going to perform the same logic, but what will change is the configuration within the integration context. And actually, before we navigate there, another thing we'll need to do is make our method public. Now let's head over to our configuration file, and on the configuration file, we can add a method attribute to our splitter tag, and then we can pick the split method that is specified on the custom splitter bean. So here we didn't have to adhere basically to that contract that Spring integration expects. We can use our own method name, and we got to use a simple POJO. There was no inheritance involved. And if we run our demonstration, you'll see that it functions the exact same way as when we were using the abstract message splitter class. And there we see our message payload being split multiple times. So there's no change in our output. What really changed was the approach. We're not using the abstract type provided by Spring integration. There's no inheritance. And then we just need to specify the method we would like to invoke for our splitter. So in this lesson, we learned more about Spring integration splitter, and we saw how the splitter can take a message, separate it into multiple parts, and then send those new messages down the messaging architecture. The counterpart to Spring Integration's splitter is the aggregator. While the splitter breaks apart a message into multiple messages, the aggregator does the opposite. It consolidates several messages into a message group and then creates a single message from that group. This allows us to piece together multiple messages. To get started with our lesson, let's begin by adding an aggregator into our messaging flow. So within the integration context.xml file, we will add our aggregator, and I'm just going to add it below our splitter because that's naturally where it would sit within the flow of our message. Normally you'll split and then you'll use an aggregator to piece the messages back together. So we can take a look at the integration namespace, and there is the aggregator tag. And the aggregator tag allows us to define an input channel, and this is the channel that will deliver messages to the aggregator endpoint. And in our case, we are going to use a channel named AggChannel, short for aggregator channel. And then we're going to output to the output channel. Now what we'll need to do is change our splitter so that it is going to send the messages it splits to the ag channel. So really we're sending directly from the splitter to the aggregator. Normally you would have some other endpoints between these two, but for our purposes we're just going to send them directly between these two endpoints. And to do that, we need to have a channel that has an ID of AggChannel. So we can go ahead and define that channel. And at this point, we have our aggregator set up. So let's navigate over to our Spring integration application. We'll modify this application in order to better demonstrate the work that an aggregator performs. So to do that, I'm going to create a string array, and I'm going to name this array payloads, and then I'm going to add some strings into that array. The first being Kevin Bowersocks, and that's just my name. Then we'll add a John Doe, and then we'll add a Jane Doe, and we'll add a little accent mark there. So now what we'll do is we'll change our loop to iterate through our payloads array. So we're just going to navigate through for each item in that array, and then we're going to pass that as the payload of our message. So that's going to be sent to the splitter, and the splitter is going to split based upon the white space. And then the aggregator is going to create a message group that will place the split messages back together, and then a single message will be sent based upon that group. Internally, what will happen is that each of these messages, when split, will get a unique ID. It's known as the correlation ID, and that's used to piece them back together. When using the default aggregator, what will happen to these messages when they are sent as that single message ultimately from the aggregator is that they will be sent as a list, and it's a list of the payloads that were received for a group. The Kevin space Bowersock string is going to get split based upon the space by the splitter. We're going to have two messages now, Kevin and Bowersocks. They'll both have the same correlation ID. The aggregator will get them, put them into a message group, and then that message group will be combined into a single message. And that single message is going to have a list where there's a message with Kevin and then a message with Bowersocks. So let's go ahead and run our demonstration. And if we take a look, we will see that the aggregator is able to successfully pair up our messages. So there we see Kevin matching Bowersocks, John matching Doe, and Jane matching Doe. We saw how the aggregator can be used to piece back together messages that were split, or to group messages and then aggregate them as a single message. To do that, we put in place a simple aggregator tag within our integration context.xml file, and that added the aggregator bean into the messaging flow. When using a generic aggregator, Spring integration relies upon the default aggregating message group processor to consolidate the payloads within a message group. This type, by default, will create a message with a list of the payloads for the group. This behavior may not always be desirable for creating the final payload of the message created by the aggregator. Our applications may require more advanced logic for aggregating messages. In this lesson, we'll learn how to customize the logic used by the aggregator for generating our final message. So before we get to work, let's just take a closer look at the problem we're trying to solve. We know what our aggregator does, and if we run our application, we can see that the output from the default aggregator may not be that ideal because now we need to have some component that expects a list of these strings, and maybe we need it in some other form. Maybe we need it to be a single string, just Kevin space Bowersocks, all one string literal. Well, this lesson is all about figuring out how we can get the output of the aggregator in the format we'd like to see. We'll see how to do that by creating a new class in the com.o'reilly.integration package. So just create a class, and I'm going to call this class custom aggregator. And this class needs to extend a class provided by Spring Integration, and that's the abstract aggregating message group processor. So that is a fancy way of saying this is the component that is going to receive a group of messages and convert them into a single message. So with that base class specified, go ahead and hit finish. And now we have our class, and it's up to us to provide the implementation of this aggregate payloads method. So what's going to happen is the aggregator is going to collect all of our messages and then put them into a message group. So there's that message group we've been talking about. And then it's up to us to return a single object. In this case, we're going to return a string that's been concatenated from this method. And then Spring Integration takes that, puts it as the payload of the new aggregated message, and now we have it in the format we'd like. So this is a way we get a little bit more control over the aggregator and what it's doing internally. So since we will be combining our strings that are returned from the message group, I'm going to use a string builder, and I'll just name it builder, and we can declare that variable. And now we're going to iterate through our message group, and the message group just contains a bunch of messages. So I'm going to use a for each construct here, and on the group argument we can invoke the getMessages method, and that's going to return a collection of messages, and since it's a collection we can use it with the for each construct. And we import our types. Make sure you pick the org.springframework.messaging.message type, or else you're going to have a very confusing error. Now we're iterating through our messages that were contained in that message group, and we're simply going to invoke the append method on the builder, and then we're going to grab the payload of our message and append that to our string builder, and then we're going to invoke the toString method on the string builder. Now, one thing we're going to do just for fun here is we're going to grab a header off of the message. So we're going to look at the integration message header accessor, and it has this correlation ID. So that will be a header placed on all of the messages within the message group, and it's how we build the message group by correlating all of these messages together using this ID. And I just want you to see that as we work through this example. So now we're going to navigate over to the integration context.xml file, and within this file we are going to declare a bean. And that bean is going to have an ID of custom aggregator, and that bean's type is of custom aggregator. Okay, so we have that bean defined, and then you can probably guess we can refer to that custom aggregator bean within the int aggregator tag that is part of the integration namespace. Now we have wired in that custom logic we've specified for aggregation into the messaging architecture. And if we were to navigate to our Spring integration application, we can go ahead and run the application, And now we see that our messages that are part of that message group and the final message from the aggregator are actually our string concatenated. And here we see that correlation ID that is actually used to group these messages together. So we know the aggregator received a message with the payload of Kevin, a message with the payload of Bowersocks, and both of those messages had this header, and that's how it grouped them together. And that's why we don't see something like Kevin Doe, because the John Doe messages had their own correlation ID, and that's how the aggregator grouped them together. In this lesson, we saw how to specify some custom aggregation logic that we can use when working with an aggregator. This chapter will focus on the set of Spring integration endpoints that are used to transform a message. When we transform a message, we modify either the headers on the message or the message's payload. Throughout this chapter, we'll see a variety of approaches to performing these transactions. We'll take a look at the subset of endpoints that allow us to modify the headers or do some transformations on the message's payload. We'll get started by looking at how to establish simple transformers and take a look at the variety of transformer types available to us, including some out-of-the-box implementations that change our message payload type. We'll explore transformers capable of outputting our payloads in string, map, or JSON format. In addition, we'll see how to perform custom transformations by defining our own transformer logic. From there, we'll learn how to remove headers from a message using a header filter. This approach can be useful for preventing specific headers from traveling downstream in the message flow. Next, we'll take a look at how the header enricher can add headers to our message, performing the exact opposite operation of the filter. We'll conclude the chapter by establishing a payload enricher, which modifies the payload of our message. We'll see how the enricher leverages a request channel to supply updates for our payload. By the end of this chapter, we'll have a whole new set of endpoints to add to our toolbox within Spring integration. The transformer is another endpoint that Spring integration makes available out of the box. Transformers are used to manipulate a message. Using a transformer, we may modify the payload of a message or decide to adjust message headers. Transformers allow for loose coupling between endpoints because we can adjust message types to satisfy a consuming endpoint. For example, if we had an endpoint that only processed JSON data, however a producer sends the endpoint messages with objects in the payload, a transformer can be used to perform the conversion between the objects and JSON data. Transformers are very useful for standardizing the types or formats of our payloads before passing them downstream in the messaging architecture. Let's take a look at a transformer in action. If we inspect our integration context.xml file, you'll find that we have a simple messaging flow in place. We accept messages on a gateway, we send them to an input channel, and that input channel delivers them to a service activator, and then we have our print service print the message. So what we're going to do is we're going to interject and add a transformer into this messaging chain. So here we see the transformer element within the integration namespace, and we're going to configure this element using its attributes to introduce this transformer into our application. So the first thing that we need to specify on the transformer is the input channel. And just like in past examples, the input channel will deliver messages to the transformer for transformation. Once the message has been transformed, we then send them to our output channel, and that continues the message's journey on our messaging chain. Now that we have our channels set up, the next thing that we specify is an expression. And the expression can be a spell expression, and it's used to modify the message that is received before it's passed along. So in our case, we're going to do something very simple. We're just going to get the payload of the message, and we know it's a string, so we're going to invoke the toUpperCase method on the string. And that's going to serve as our transformation. So that's pretty simple. And if we navigate to our Spring Integration Application class, you see that we're just passing in a series of names, and we would expect them to be sent to the console in uppercase after running through our transformer. And there we do indeed see that our console output is in all caps, and that means our transformer was successful. So let's now build out our own custom transformer, and we can include that within Spring Integration's messaging architecture. So I'm just going to build out a new class within the com.o'reilly.integration package. So I just hit Control N and type class. And now I'm going to call this class custom transformer, and we'll go ahead and hit finish. And within this class, I'm going to add a public method that returns a string, and I'll name that method transform. Now I'm going to have this method accept an argument of type message that has a generic type of string, and I'll name that argument message. Be sure to include the Spring Framework message. And then within the body of this method, I'm going to split our payload. So get the payload, and then invoke the split method and split by white space. And then what I'll do is I'll return our payload with the last name first, and then we'll add a comma in there, and then we'll print out the first name, almost like a roster order that you would see. So we're just going to change the format of that string. So that's how we set up our Pojo to do the transformation, and these can be named anything you'd like. The method can be anything you'd like, because as you'll see, we'll build that into our integration context.xml file. And the way we do that is by creating a bean. So I'm just going to name this bean custom transformer, and then we specify the class for the bean, and we point to our custom transformer type. And now instead of specifying an expression, we can use the ref attribute, and we simply point to our custom transformer. And what this will cause to happen is for our custom transformer to be consulted when the transformer receives a message from its input channel. Now what we'll also have to specify here is the method that we would like to invoke, and that's going to be our transform method. And you'll actually see, if we do everything correctly, you can take advantage of IntelliSense here. So there we have our custom logic setup for our transformer, and if we navigate to the Spring Integration application, we can go ahead and run the application, and there we see that our output now comes out in that roster format as specified within our transformer. So in this lesson, we learned how to add a transformer into a messaging flow in order to manipulate or change a message as it is sent through the messaging system. Spring Integration provides us with several useful transformer implementations out of the box. In this lesson, we'll explore the available transformers and walk through a demonstration of their use. To this point, we have been mostly working with simple payloads. However, payloads can contain more complex types. For example, our application may work with a person class instead of transporting simple strings containing their name. In order to work with the transformers in this lesson, we're going to go ahead and build out a person class. So we'll just open the new dialog and create a person class. This class will have a string for the first name and a string for the last name as fields. We can go ahead and right-click within our class and then navigate to Source and then Generate Getters and Setters, and then we simply select all of our fields and we can generate those get and set methods. The other thing we can do is we can go ahead and generate a constructor. So if you right-click in the class, once again, go to Source, and then you will see Generate Constructor Using Fields towards the bottom. Once you open the dialog, we'll create a constructor with both fields, which are already selected for us. Go ahead and hit OK. At this point, we have a person class. Now we're going to change our application to use this more advanced type. So we'll navigate to the Spring Integration Application class, and we're going to change our array from type string array to type person array. And then we're going to use our constructor for the person object and supply our two arguments in order to create an instance of a person. And we'll just create one more person within this array, and we will name the person John Doe once again. Now, when we run our application, instead of passing simple strings as the payload of our messages, we will be passing the person instances as the message payloads. So it's a little bit more of a complex type. When working with these types, we get some out-of-the-box transformers that we can use. So let's navigate to the integration context.xml file, and let's remove our current transformer and take a look at some of the other implementations made available to us. So if we take a look at the object2 tags, you'll see object to JSON transformer, object to map transformer, and object to string transformer. And these are all implementations of transformers provided to us by Spring Integration. For our first demonstration, we'll be using the object to string transformer. So we go ahead and add that element into our XML file, and then we specify our input channel, and we specify our output channel. And just like the last transformer, these are the channels that will deliver and then eventually receive our messages once they are transformed. So what the object to string transformer will do is it will invoke the toString method on an object, and the returned result from that method will become the payload of the message. So we need to implement a toString method on our person object. So instead of just accepting our default, we're going to go ahead and add that method in. And you can do that very quickly using Eclipse by right-clicking, going to Source, and then Generate toString. And we'll just create a toString method that supplies the value of both fields. So with that configuration in place, we can now go to our Spring Integration application and launch the application. And now if we inspect our console output, there we see that our object to string transformer was used to invoke the toString method on our person object, and that result was placed as the payload. Next, we're going to look at a more useful transformer that's provided to us, and that's actually the object to JSON transformer. So JSON is used very heavily, especially with web applications, to transport data back and forth between the client and the controller layer. So out of the box, we get this object to JSON transformer, and it's able to take an object and serialize it to JSON. In order to use the object to JSON transformer, we need to add a JSON parser into our application. So we're going to navigate to the pom.xml file, and we'll click on the Add button to add a dependency, and simply type Jackson. And then we are going to be using the com.fasterxml.jackson.core Jackson data bind library. So we see that dependency right there, and simply click OK to include the dependency within the POM file, and then we'll save that dependency. And now if we navigate to our application, we can run the demonstration, and you will see that our objects have been converted to JSON. And that was all thanks to an out-of-the-box transformer provided by Spring Integration. And let's just take another look at the namespace. We saw that we can convert an object to a string, and we can convert an object to JSON. There's also a transformer that will convert an object to a map. So that's our final transformer. We're not going to run a demonstration on that one, but what we will take a look at is there are transformers that perform these operations in reverse. So here's a JSON to object transformer, and that is going to deserialize JSON and build out an object. And there's also a map to object transformer that we can use. So those all may come in helpful as you work in Spring integration. Another way that we can modify a message within Spring integration is using the header filter. The header filter simply removes certain headers from a message. This can be useful if we need to prevent sending information, such as security information, downstream in the messaging system. If there is a header that should not be passed on in the chain, the header filter can be used to remove it. Let's take a look at an example. To work with the header filter, we'll need to add a header onto our message. So let's navigate within the Spring integration application, and we're going to set a header using the message builder, and we simply provide the name of the header, and let's call this private key. So this is some secure information that we do not want to pass on. And we have a very complex private key of 1, 2, 3, 4, 5. Now let's look at our print service, and we're going to modify this service to print out all of our headers. And this will be useful for seeing how the header filter works. So we can use the for each construct, and we're going to get an entry that has generic types of string and object, and we'll name that entry entry. And then we're going to take our message, get the headers, and then get the entry set, because underneath the hood, the headers in the message are really stored in a map. That's why we use the entry type, which is from map, and we're able to invoke the entry set method, which you would find on map. And then simply within the body of this loop, we're going to output the key. So we're going to get the key, and then we'll concatenate that with the value and separate them by a colon. And then so get value. All right, so with this in place, let's just go ahead and we can now run our application, and we'll see what happens. And looking at our console output, we see our message payload as well as all of the headers for the message. And in fact, we do see that our private key is being sent downstream within the messaging system, and we don't want that to occur. So the tool we can use is the header filter, and that's provided out of the box by Spring integration. So let's build the header filter into our application. To do that, we will use the integration namespace, and if we take a look on the namespace, we find the header filter. And the header filter is pretty simple. We need to provide an input channel, so this is the channel that's going to deliver the message to the header filter, and in our case it's the input channel. And then we need to provide an output channel, and this is the channel we're going to place the filtered message on. In our case, it's the output channel. Now, the next thing that we'll need to provide is the header names that we would like to remove. In our case, we want to remove the private key. If we had other headers that we would like to remove from our message, we simply specify the next header name after a comma. So you just comma delimit all your header names that you would like removed. So some other name, and we can remove that because we only want to remove the private key header. Okay, now with this in place, we're going to need to actually add another channel. So I'm going to add a filter channel, and we'll modify the output channel to be the filter channel. And then we'll set that as the input channel on our object to JSON transformer. And that way we'll get the message from the gateway, put the message on the input channel, it comes into our header filter, and we remove the header, and then we pass the message on to the object to JSON transformer. Eventually it reaches our output channel, which is connected to the service activator, which is going to print our message payload and our headers. So let's run through this demonstration, and this time we should no longer see our private key being filtered. And in fact, if we do take a look at our two messages, so here's one, and then here's the other, we no longer see our secure information being sent. And that's all thanks to putting in place a header filter, which is able to remove headers from a message. Spring integration provides the header enricher, which allows us to add static headers to a message. While we can add headers to a message by using a custom transformer, the header enricher is a much easier and more convenient approach. The header enricher adds a header and can be viewed as the counterpart to the header filter, which removes headers. To get started in our lesson, we're going to add the header enricher within our current message flow. To do that, we rely upon the integration namespace, and on it we will find the header enricher element. And if we take a look at that element, we see some of the normal attributes we work with: the input channel, which will deliver the messages, and we're just going to specify that as input channel. And then we need to specify an output channel. And this is the channel the header enricher will place the message on when it finishes its work. So we're just going to name our output channel Enricher channel, and we'll copy that name and we will build out that channel. So we'll create the new channel, give it an ID of Enricher channel, and then we're going to set the input channel for our header filter to the Enricher channel. Now, if we take a look at the sub-elements of the header enricher, you see that we get some options here that provide us with convenient methods to set common headers. So there's the correlation ID, there's an error channel, which we haven't discussed yet, but you'll also see a reply channel, another header we haven't discussed. We've talked about the priority, and there's a convenient method for setting our priority, but you'll also see then a generic header sub-element. And what this allows us to do is to specify the name of our header. Let's make up some header. We'll make a public key, and the public key will get a value, and that value we're just going to set as 54321. At this point, the header enricher is configured, and when we run our application, we'll send a message to the gateway, and the gateway will place the message on the input channel. The input channel will deliver the message to the header enricher. The header enricher will add a public key header to our message with a value of 54321. The message flow will then go to the header filter, which removes the private key header. Then we transform our object to JSON, send it to our print service, and our print service will use the print service bean to output our message. Now, when we output our message, we're going to see all the headers on that message. So now when we run our application, we should see that our headers have been added. So there we see our payload, and if we take a look at the headers, we do see that our public key header was added thanks to the header enricher. Now, one of the things that we can do when working with the header enricher is we can delegate the value off to a different bean within the Spring IOC container. So let's navigate to our package explorer, and within the com.o'reilly.integration package, we're going to create a new class, and we're going to name this class Custom Header Enricher, and then just go ahead and hit Finish. And then on this class, we're going to place a method that will return our header value. So I'm just going to return a string, and I'll name the method getHeaderValue. And we won't pass any arguments to this method. And then I'll simply return this is the header value. And now what we can do is we can make this custom header enricher type into a bean within our Spring IOC container. So we use the bean tag. We're going to call this our custom enricher. And then we set the type of our bean, and now it's part of the IOC container. And then we can go up and modify our header tag. And if we take a look on that header tag, we can refer to a bean, so the custom enricher, and then we point to a method on that class. In our case, it's going to be the getHeaderValue method. So what will happen is when the header enricher needs to add the public key header to our message, it's going to consult the custom enricher bean and invoke the getHeaderValue method. And what is returned from that method will wind up being the value for our header. So with that in place, let's navigate to our Spring integration application, and we'll launch it and take a look at the console output. And when we get our output, if we look at the headers on our message, we do indeed see that the public key header has been set to this is the header value. This was all made possible by the custom header enricher that we have created. And to build that bean into our messaging system, we used the header enricher tag, and we specified the method and the ref attributes accordingly. This lesson will teach us how to use Spring Integration's Payload Enricher. The Payload Enricher is used to append additional information to a message's payload. The Payload Enricher allows us to pass a message to a request channel, which returns a message that we can then use to append additional information to the payload of our current message. It sounds a little bit complex, but we'll simplify the use of the Payload Enricher using a simple example. To get started, let's navigate to our com.o'reilly.integration package, and we're going to open the person class. On the person class, we are going to add a new string, and we're going to name this string phone number, and then we can go ahead and add an accessor for the phone number. So just right click within the class file and go to source, and then generate getters and setters, click on the phone number, and then hit OK. And that will add get and set methods to our person. Now, what we're going to do is we're going to use our Payload Enricher to populate the phone number on the instance of person. So we can close our person class, and now we will begin to build out our Payload Enricher within our integration context.xml file. So the first thing I'll do is remove our header enricher, and then if we take a look at our friend, the integration namespace, we will see that there is the enricher element, and this element is used to add information to our payload. You'll see the familiar input channel, which we are going to specify as input channel. And we also will have an output channel where we will place the enriched message to continue downstream on our message flow. In this case, however, we're going to create a new channel for our output, and we're going to call that channel the enricher channel. So we can copy that string, and now we can build out a new enricher channel, and that will receive our enriched messages. The next thing we'll do is within the body of the enricher element, we're going to specify a property. And this is the property that we would like to set. So in our case, we would like to set the phone number on our person object, which is going to be contained in the payload of the message sent to the input channel. We'll go over that before we run our demonstration. The next thing we'll need to do is specify an expression. And what we're saying is that when we contact a request channel, so we haven't seen a request channel attribute, which we'll add, we would like the message sent back from our request channel to have an expression evaluated against it, which is going to be used to assign the phone number field on the payload of the message sent to the input channel. In our case, we're just going to assign the entire payload returned by the request channel to the phone number field on the person instance, which is the payload of the message sent to the input channel. It gets a little bit complex. Now, we haven't built our request channel yet, but we're just going to name that channel request channel. So we're adding a channel, and its ID is going to be request channel. Now, that request channel needs to send a message to an endpoint, and that endpoint needs to return us a message so that we can set the phone number field. And in order to have that endpoint, we need to build it out. So we're going to create a new class, and we're just going to name this class Custom Service, and we'll open that class up. And inside of that class, I'm going to create a method that returns a string, and we'll just name it getPhoneNumber, and it's going to receive an instance of person. And here we would do something like maybe contact a data store or a web service and then return some phone number. So let's go with 8675309. Okay, so this service will return a phone number. And in order to contact that service via a channel, we need to add it into our messaging system. So I'm going to first create a bean, and the class will be of type custom service, and the ID will be custom service. And then we can go ahead and close that bean tag, and then we're going to use the integration namespace, and we're going to create a service activator. And we can specify that it refers to our custom service bean, and it is going to receive messages from the request channel. The other thing we'll need to specify is the method that we would like to invoke on that bean, and in our case it's going to be getPhoneNumber. So let's talk a little bit more about what will happen in this flow. We are going to drop a message that contains a person payload onto the input channel. And that input channel is going to deliver that message to our enricher. The enricher is going to send that message to the request channel. The request channel is going to deliver that message to our service activator that is associated with the custom service bean. The payload will then be sent to our custom service, and we will get back a message containing this string as the payload. We've then instructed Spring Integration to take that payload and to assign it to the phone number field on the payload of that message dropped on the input channel, and that is of type person. If we got some sort of complex object back from our request channel, so let's say it's some custom object that has fields on it, we can reference those. You would just use dot notation and then specify the field name. In this case, we're just getting a string back, we're assigning it to the phone number, so that's going to enrich the payload of our message, and then we're going to put that message onto the output channel, and eventually it's going to reach our print service and be printed to the console. So let's go ahead and save the integration context.xml file, and now we're going to navigate to the Spring integration application, and we can launch our app. Let's take a look at our output. So here we see the JSON output printed for the first message, and if we look closely, we see that the phone number was added to our person payload for the message due to the Payload Enricher. And we also see that occurred for our second message. So in this lesson, we learned how to configure an enricher in order to add information from our payload that is returned by a request channel. This chapter focuses on Spring integration endpoints that connect the messaging system to application code, external systems, and services. This connectivity is achieved using endpoints such as the service activator, gateways, and channel adapters. Unlike other endpoints that perform routing, enriching, or filtering, these crucial endpoints do the heavy lifting of enabling integration between internal components and external systems. Let's talk about the contents of this chapter in more detail. The endpoints in this chapter represent an important subset of those provided by Spring integration. Without these endpoints, the framework would not be able to provide crucial integration support between systems. We'll begin by exploring a familiar endpoint, the Service Activator. The Service Activator allows us to connect our system's internal services to the messaging framework. We'll learn some advanced configurations of the endpoint that allow us to unlock its full set of capabilities. Next, we'll look at the gateway, which allows two-way communication, meaning that it can send and receive messages. In addition, the gateway is an excellent way to decouple our application from Spring integration. In a way, gateways are very similar to service activators, since they both allow two-way exchanges. However, the adapter is primarily for external integrations. This means that those integrations which take place with resources outside of our application should be handled using gateways. The Service Activator is more appropriate for connecting business-level services within the application to the messaging system. Finally, we'll dive into channel adapter endpoints. Channel adapters are frequently used to connect a message channel to some other external system via one-way communication. Most organizations contain a diverse portfolio of systems that rely upon different technologies and need to be integrated with our applications. These systems may be a source or destination of messages sent through Spring Integration's messaging infrastructure. Within Spring Integration, we'll find various out-of-the-box adapters that solve these integration challenges by allowing us to integrate with the file system, web services, SMTP mailboxes, and other resources. Each of these endpoints has subtle characteristics that distinguish them from the rest. Some send messages while others receive them. Some are capable of two-way communication, while others are simply one-way communication. This chapter will give you the background required to determine which of these endpoints is appropriate for a given application need. This lesson takes a closer look at the Service Activator endpoint. We have seen the Service Activator used in many of our examples up until this point. In our demonstrations, the Service Activator has been used to invoke a service method on a message handler bean. Some of these message handlers provided a return value, while others did not. Those returning a response either returned a message or an object that found its way as the payload of a message. Let's walk through a quick demonstration of a Service Activator and explore another approach to configuring how we handle return values from the message handler. If we inspect our application, you'll see that we have simplified our integration context.xml file to have a very simple message flow. We accept a message on the printer gateway and we send that message to an input channel. Now that input channel is not connected to anything at the moment, and then we have a Service Activator set up to accept messages from an output channel. So what we're going to do is we're going to add another Service Activator to our message flow. So we can go ahead and add a placeholder in for our new Service Activator, and we know that each Service Activator is associated with some sort of message handler bean. So we're just going to add an ID for a bean of uppercase service. And for right now, we won't specify the type, but we'll go ahead and create the type within our com.o'reilly.integration package. So just open the new dialog, create a new class, and we'll name that class uppercase service. And we'll just finish creating our class, and then we add a new method which returns a string. We're going to name this method execute, It's going to accept a person as an argument, and then what we'll do is we're going to get the person's first name, and then we'll concatenate that with a space, followed by concatenation with the person's last name, and then we're going to take this new string and we're going to uppercase it. So very simply, we're just uppercasing the person's first and last name. And then if we navigate back to our integration context.xml file, we can build out our bean, and this is very similar to what we've done in the past. And now we define the bean we'd like to refer to using the ref attribute, and we can use IntelliSense to get the uppercase service, and then we can specify the method. And in fact, we don't even need to specify that method if there's only one public method on our bean, but it is very good to specify that explicitly. So for the value of the method attribute, we're just going to specify execute because that's the method's name. And then we need to provide an input channel that will deliver messages to our service activator. And we're going to have the input channel deliver those messages from the gateway. Now, what you'll notice is that we have not configured the output channel. And in fact, we're going to use a little bit different of an approach. Since our uppercase service does return an object, this string is going to be created as the payload of our new message. And that's going to be returned from this message handler bean to the service activator. And the service activator needs to know where to send that new message. And ideally, we'd like to send it to our output channel and have that output channel deliver it to the print service, which will then print out the payload of our message along with some of the headers. So what we can do, besides specifying the output channel, is we can supply a header. And this header will direct the service activator where to send the response once it has provided a return value. So instead of specifying this private key header, we're going to change that header to reply channel, and then we can either provide the actual channel implementation. So we could auto wire our channel, and then we could reference that bean as the value of our header, or we can just specify the name of the channel, and then Spring Integration will look within the IOC container to find a channel with the same ID. So we're going to go ahead and specify the output channel, and this will cause our messages to be sent to the output channel. So once our new message handler processes the payload person, it's going to return that string. That becomes a message, and that message is sent to the service activator. The service activator inspects the reply channel header and sees that it should send the message to the output channel. And then Spring Integration looks inside the Spring IOC container, finds the output channel, drops the message onto it, and then the print service activator is connected to that output channel, and it's using it actually as its input channel, which delivers the message to our print service. And we can take a look at that quick, and we see we just print out our payload along with the different headers. And that's our message flow in this case. With all this in place, let's go ahead and run our demonstration. And once we run the demonstration, we do indeed see that we get our person's name in uppercase. So there we see my name in uppercase along with John Doe. And in fact, we also see our reply channel header. And this is an alternative way of telling an endpoint how to handle a return value from an endpoint. And that's by using the reply channel header. And you'll see this construct on several of the endpoints within Spring Integration, not just on the service activator. Gateways are used within Spring integration to hide the messaging system. By using a gateway, we can remove direct dependencies upon Spring integration components from our code. To do this, we use an interface, which prevents tight coupling between our application and the messaging system. By placing an interface between our application and the messaging system, we can hide the details of the messaging system. Let's run through a quick example to learn more about gateways. If we take a look at our integration context.xml file, we'll see that we already have a gateway set up. If we further inspect this gateway and take a look at the underlying interface supporting it, you'll notice that we are relying upon the message type from Spring integration. And this is coupling our code to the Spring integration framework. Ideally, we would like the gateway to blend more naturally with our application code and not have the tight coupling to the framework. What we'll do to remedy this is we're going to build a new interface. So we'll use the new dialog and we're going to create an enhanced printer gateway interface. And we'll go ahead and hit finish. And then we get our new interface, and we're going to add a public void method that is named print to this enhanced printer gateway interface, and it's going to accept an argument of type person. So here you see that instead of accepting a message, we're now accepting a POJO that we have defined. So this would allow us to conduct our application logic without ever really tying into Spring integration. Now, with that interface set up, we need to navigate to our integration context.xml file, and we're going to swap out our type. Now I'm going to specify the service interface attribute on our gateway tag to point to the enhanced printer gateway. You'll remember that the service interface attribute points to the interface that's going to define our gateway, and then we define this default request channel, which is the channel that we're going to place messages on that we receive from the gateway. So we will have the print method invoked, a person will be supplied, that person's going to become the payload of a new message, and then we're going to place that message on our input channel, which will then deliver the message. And let's actually send it to our print service here. So I'm going to make a new channel and I'm going to call it print channel, and we will deliver the message through the print channel to the print service. And then I'm just going to switch the uppercase service here for this service activator. I'm going to create a new channel, which we'll use later, that is named the uppercase channel. So we're going to drop a message on the gateway, it's going to go to the print channel, and that's going to be delivering the message to our service activator, which is then going to invoke our print service. And we're going to modify our print service to accept a message of any type so that it can handle the new person payload. And it's simply going to print out our payload, and then it's going to print out all the headers for our message. So let's save our integration context.xml file, and now we have a little bit of work to do within the Spring integration application class. We're no longer going to auto-wire the printer gateway type. Instead, we're going to use the enhanced gateway, and we'll see that that changes the type of arguments accepted by that gateway. We can no longer pass in a message. Instead, we need to pass in a person object. So I'm going to specify that we pass in one of the elements within our person array payloads. So now we're going to iterate through that array and pass the actual person object into our gateway. Now you see that we no longer rely upon Spring integration within our application code. it's transparent to us that we are using Spring integration when looking at this class. And that's really the main purpose of a gateway, is to take that messaging code out of your application code and tuck it behind this nice interface. And you may wonder, where is the implementation of this enhanced printer gateway coming from? Well, in the background, Spring integration actually builds a proxy, and that's what gets injected into our class when we auto-wire for the enhanced printer gateway type. So Spring integration builds that proxy, and then we invoke the methods on the interface, and the proxy receives them and ties that object into the messaging system. So with all this in place, let's go ahead and we can run our application, and we should see that we get our two messages. Their payloads get printed as well as their headers, and that's in fact what we do receive. So let's return to our editor, and now we're going to add another method to the enhanced printer gateway. So if we take a look at the integration context.xml file, you'll notice that we really didn't specify any method on our gateway, and that's because when there's only one method, Spring integration knows that is the method that is going to receive the object, and we actually invoke that, and it's able to tie that method to this default request channel. But what happens if we add another method to our interface? And it's perfectly legal, so we can add this uppercase method, and you'll notice that this method actually returns a string, where the other method returned void. Nothing was returned from it. So now we got something coming back. And what Spring integration will do by default, it's going to build anonymous and temporary reply channel, and that's going to return whatever message we get in response to invoking this uppercase method. And let's take a look at what that might be within the integration context.xml file. So we need to change some of the configuration of our gateway. So we're going to remove, in this case, our default request channel, and we'll define those mappings at a more granular level within the body of the gateway. So here we can specify a method, and for the method we're going to say print. So we're looking at the print method on the enhanced printer gateway, and then we can tie that to a request channel, and in this case it's going to be the print channel. And now we can do the same for our uppercase channel. So for the uppercase method, we're going to associate that with the uppercase channel. And what this will cause to happen is that when we invoke the print method, we send those messages to the print channel, which eventually go to our service activator working with the print service. And when we invoke the uppercase method, those messages will be sent to the uppercase channel, which then get delivered to our service activator tied to our uppercase service. And if we take a closer look at that service, we see that it does indeed return a string. So we're going to get a reply there. That reply will be sent back to our gateway via a channel that Spring integration automatically creates. So let's navigate to our Spring integration application class, and we're now going to invoke the uppercase method on the gateway, and we need to remember that this method will return a string from the messaging system. So we're going to call this our return message, and we'll assign that to a string, and then we can print out that return message to our console. So we're no longer going to get the headers being printed out as if we had invoked the print method. Instead, we're just going to get that message being returned from the gateway that is the name of the person in all caps. So let's go ahead and we can run this example and take a look at our output. And there we do indeed see that we invoked the uppercase service through our gateway by invoking the uppercase method. So we were able to define multiple methods on our gateway, and then we set up these mappings within the gateway tag, and that allowed us to direct the content of those messages, or the arguments sent to those messages, to the appropriate channel as the payload of a message. In this lesson, we learned how to use the gateway to abstract Spring integration out of our application code and to work strictly with POJOs in order to send messages to the messaging system. We also saw how to receive replies from the messaging system by using the automatically generated channels by Spring integration. One of the features provided by Spring integration for the gateway is the ability to set headers on the messages the gateway delivers to the messaging system. In this lesson, we'll see how to apply headers to a message using the gateway. So to get started, we're going to look at our integration context.xml file, and if we take a look at the integration namespace, we'll see the default header tag. And we're going to include that within the body of the gateway tag. And this is a way to add a header to every message that is delivered to the messaging system by our gateway. It doesn't matter which method we invoke, by specifying this default header, the header will be added to the message, and the message is going to be delivered to the respective channel for each of our methods. So we're going to go ahead and we'll name this header global header, and then we provide a value for the header. So we're just going to use a static string for our first example, and I'll just specify it as simple value. And now if we navigate to our Spring integration application, we're going to invoke our print method because that's the one that displays all of the headers. So we'll need to do a little bit of a change here. We'll just comment that out. Okay, so we're configured to invoke the print method, and that's going to display the headers, and we expect to see our new global header be added to our messages. And there we do see the global header added to our second message, and we see it added to our first message. So that header would be added to all of the messages for this gateway. If we wanted a more granular configuration, Spring integration allows us to define headers per method. So here within the body of the print method, we're able to further define another header. And this header would only be added to messages that were created by invoking the print method on our gateway. We would not add this header if we were to invoke the uppercase method on our gateway. So let's just call this new header the individual header, and we're going to actually specify an expression for the value of this header. So the expression attribute allows us to provide a spell expression which will be evaluated in order to determine the value of the header. And one of the arguments that is made available to us via spell is args, and this allows us to reference the arguments passed into our print method. So in our case, we're talking about the first argument, which is of type person. And we know that person has a first name field that we can reference using spell. So what we're doing here is for each method that is created by invoking print, we are adding a header named individual header, and the value of that header is going to be the first name of the person that was passed to the print method. And then that message will be passed to the print channel for further processing. And eventually we're going to wind up printing the payload and the headers for that message. So let's take a look at this in action. We'll go ahead, invoke the application, and now we see the individual header added, and there we see the value is Kevin for the first message, and for the second message the value is John. So we were able to use our configuration within the integration context.xml file for the gateway to add some headers onto the messages that this gateway is introducing to the messaging system. And this can be valuable if you need to include some sort of metadata about your message for further processing downstream in the messaging system. Gateways are capable of returning a reply message when we invoke a method. Reply messages can come from a variety of sources, some of which may require a bit of processing time. If we inspect the execution of a gateway method, we'll discover that the gateway will block execution while waiting for an expected reply message. This may not always be ideal, and sometimes we may desire our gateway to act in an asynchronous manner. Luckily, Spring integration makes it extremely simple to switch a gateway's behavior to an asynchronous mode, which we'll see how to do in this lesson. So as we said, by default, if we were to execute our application, you notice we're invoking the print method multiple times within this loop. We will see that the execution of this application will block on this print method. So we'll pass in the first person, and the print method will be invoked, and we'll block until we would get some sort of reply or acknowledgement that this message is finished. And this is especially true if we were to use the uppercase method on this gateway, because the uppercase method returns a string. So let's get our message and we'll print it out. And what we'll see when we execute this application is that it's always going to go in this order. First, it's going to be Kevin that prints and then John Doe. And that's because before we send the John Doe person to our uppercase method on the gateway, we will wait for the first person, Kevin Bowersocks, to finish processing. So when we run this application, what we see is the same sequence every time. So Kevin and then John. However, what we may want to occur is we want to fire the message off on the gateway, and then we want to continue on with our processing in an asynchronous manner. Well, there's some tools that Spring integration provides to us in order to make our gateways perform asynchronously. And in order to do that, we need to make some changes to the methods on our gateway. So we're just going to work with the uppercase method, and instead of returning a string, what we can do is we can say that we would like to return a future that has a generic type of string. And there you can see that a future comes from the concurrency tools within Java, and it's specifically within the java.util.concurrent package. Now, this will change how we then operate within our application because we now have to take the concurrency into consideration. But once Spring integration notices that this gateway method returns a future, it by default switches over into an asynchronous mode. We can use a future, but it's a little bit rough, and Spring actually provides a very nice feature called the listenable future, and this allows us to work with callback methods. And we don't need to do a lot of the processing that we would need to do when working with a future. So when working with a future, we would need an executor, and we would have to check to see if the future has returned, and eventually we would end up blocking. But the nice thing with the listenable future, as we'll see in a moment, is that we just need to provide a callback. So let's go ahead and change our Spring integration application to work with the listenable future. So we're going to change the type of the variable that is being assigned the result of invoking our uppercase method on the gateway, and we're going to change that type to a listenable future. Next, we'll change the name of this variable to future, and then if we take a look at the available methods on the listenable future type, you see that we get this add callback method. And we're going to go ahead and provide an implementation of a listenable future callback. And we need to generically type that to the type of the message payload we'll return. So if we import that type, you'll then see that we can implement the interface, and we just provide implementations of the different methods on the listenable future callback type. So what we'll do inside of these methods is provide some console output. So the first output is simply going to say we are invoking the success callback, and we're not going to provide any output for the on failure method. We're just going to assume everything's going to work, but you could include failure processing logic there. And then we'll also print out the result to the console. So there we have provided an implementation of a listenable future callback, and once our message is returned from invoking the uppercase method on the gateway, it's going to kick off this callback method and we will execute the on success logic. Let's also add some additional console outputs so we can get a better understanding of what is occurring within this application. So let's mark the point at which we are sending the payload or the person object to our uppercase method. So I'm just going to add some console output and just say invoking the gateway method. So we can see when we do indeed pass that person object to our gateway. And then just to better illustrate the asynchronous nature, we're going to add a random timeout into the execute method of the uppercase service. And this will allow us to see the responses come back in different sequences. So inside of this method, we're just going to use time unit dot seconds, and then we're going to say sleep, and then we're going to use a new random, and we'll import the random type, and then I can invoke the next int method, and I'll say for 10 seconds. And then we need to surround that with a try catch. So what will happen in this application is we're going to pass both of these person objects to our uppercase method on the gateway, and we're not going to wait for a response before sending each person object. We're just going to send the objects, and then we will have the uppercase method eventually pass its message over to the uppercase service, and we're going to invoke the execute method. And when we do that, we're going to sleep for random time, and then we eventually return the names uppercased, and then we head back. Once we return those strings, the listenable futures will have their callback methods invoked, and we'll have this console output from the on success message. So let's go ahead, now that we have everything in place, and we'll kick off this demonstration. And we'll see if our random timeouts there agree with us. So there we did, in this instance, get Kevin first, and then we got John. Let's see if we can get them to switch. So we'll invoke it again. Okay, and this time we saw that John was returned before Kevin. So we're getting various different sequences when we invoke, and that's because of the asynchronous nature of our application. And that's all thanks to Spring Integration's support for asynchronous gateways, which we can obtain by using a listenable future or a future type as the return type of a gateway method. The inbound adapter receives messages by polling an external system or being notified by that external system. Once the message is received, it is delivered to the messaging system to be sent downstream in the message flow. The inbound adapter helps our system integrate with those external systems that need to deliver messages to our application via the messaging system. The inbound channel adapter allows these external systems to implement a variety of technologies. And these external systems can still integrate with our application because Spring Integration performs the necessary translation of the external system's message to one suited for the messaging system. In this lesson, we'll learn how to build a simple inbound channel adapter that relies upon a mocked service that we'll create. This simple example will give us a better idea of the role played by the inbound channel adapter. So to get started, let's first create our mock service. To do that, I'm going to create a new class within the com.o'reilly.integration package, and I'm going to name this class the Person Directory Service. So we'll go ahead and build that class. And then inside the class, we're going to add a very simple method that returns a person, and we'll just call it find new people. So maybe this is some call we have to check like an ERP service to see if anybody new has joined the workforce. And we're simply going to mock out a person that will be joining the workforce, and she's going to be Jan Doe. And that's what we'll return from our newly created find new people method. And next, we'll navigate to the integration context, and we're going to make this new class into a bean. So I'll call this our person finder bean, and then we're going to specify its type as person directory service. Let's actually change that name to Person Directory Service. It's a little bit better. Okay, so at this point we have this new Person Directory Service, and think of this as some bean we have that reaches out to an external service like ERP and then pulls in some sort of information that we need to put into a message. We can now build out, using the integration namespace, an inbound channel adapter that is going to take this service and make it a part of the messaging system and the messaging flow that we're creating. So we have this bean that performs the integration with an external system. We hook it up with the channel adapter using the ref attribute, and we point to the person directory service bean, and then we specify the method on the bean that we'd like to invoke, and it's find new people. And then we have to specify a channel for this new message to be sent to. So we use this service to get information to build a new message, and then the channel adapter forms that message and then places it on a message channel. And we can specify that channel by using the channel attribute, and we're going to use the print channel. So what we'll see is that the new message will be sent to our print service, and our print service is going to print the payload as well as any headers. Now at this point, we're going to actually go ahead and remove our gateway because we're no longer going to be using that as an entry point into the messaging system. It's now going to be this inbound channel adapter. Inbound adapters have two modes of operation, so they can pull or they can be event driven. In our case, we're going to configure the channel adapter to actually be a puller. So we can specify a puller within the body of the inbound channel adapter tag, and then we specify a fixed rate. Let's say every 3 seconds, we want to invoke the find new people method on the person directory service. So basically every 3 seconds, the inbound channel adapter is checking whether a new person has appeared in some external system. So now that we have set up our inbound adapter, we can navigate to our Spring integration application, and we're going to remove a few things. First, we're going to remove our gateway because that bean is no longer available. And then we're actually going to remove the body of the run method here because we're no longer going to be performing any logic where we're sending these messages. Instead, we're going to be pulling that service, and when we find a new message, that's when the message goes onto the messaging system of Spring integration. So let's save our application, and then we can fire it off, and once the application is loaded, there you can see that every 3 seconds we are pulling because of how we have set up our channel adapter, and we're taking in these new messages and then putting them on the messaging system where they can be processed. And this is all thanks to the inbound channel adapter provided by Spring Integration. In this lesson, we're going to discuss the outbound channel adapter. And as you can imagine, the outbound channel adapter, it does pretty much the opposite of the inbound channel adapter. The inbound channel adapter brought messages onto our messaging system, and the outbound adapter sends messages out to external systems from the messaging service. In order to learn more about the outbound channel adapter, we're going to build one into our current message flow. In order to do that, we need to create another mock type of service. So we'll create a new class, and I'm going to name that class Person Registration Service. And let's imagine that this service is basically used to include a person in some other system where we are keeping track. Maybe this registers them for an email account. We send a notification over to some email system and say, hey, make an address for this person. We'd like to have those things automated. And this service supports that. So what we'll do is we'll create a public void method within this class, and we'll call it register email. And it's going to accept a type of person, and then we'll just do something very simple, and we'll just say email created for, and then we'll print out the person's name. So we have this mock service created. You can probably guess what happens next. It becomes a bean. So we're going to navigate over to our integration context. And at this point, we can delete almost everything within this file non-related to an adapter. So we'll just go ahead and remove everything except for our print channel, our person directory service, and then the inbound channel adapter. And then what we'll do is we'll create our new bean. We'll say person registration service, and then we'll specify the type of this bean as a person registration service. And there we go. We got our bean in the Spring IOC container, and now we can start to build the outbound channel adapter. It's configured very similar to the inbound channel adapter, where we specify a reference to a bean, and it will be our person registration service. And then we specify a method that we'd like to invoke, and we're going to use the register email method. And another thing I'm going to do here is I'm going to just rename our print channel. So let's call it the register channel, just so it is a little bit more intuitive. Okay, and then the final thing that we'll do is on the outbound channel adapter, we need to specify the channel that is going to deliver messages to the outbound channel adapter. And you can probably guess it's our register channel because it's the only channel right now. So let's talk through what happens here. We have our inbound channel adapter, and that is going to every 3 seconds pull the person directory service, and then it's going to take any information it receives from that pulling, build a message out of it, and put it onto the register channel. The register channel is going to deliver that message to our outbound channel adapter, which is tied into the person registration service. This person registration service has the knowledge of how to register a person with a specific email address, we're saying, and it will perform that communication with that external system. So really what we're doing is we're taking information from one external system, moving it through the messaging system within Spring Integration, and then finally sending a message via our outbound channel adapter to some other external system. And let's just go ahead and add some output to the person directory service just to help us understand this flow. So we'll just put some real simple console output and we'll say that the inbound adapter has pulled this service. And that way we can see and have a little bit more visibility into how this flow works. At this point, we have everything set up that we need. We have the outbound channel adapter that is going to send that message out to that external system. Now notice it's only one way. It doesn't expect anything coming back. That's an important point with the channel adapter. So let's kick it off and see this demonstration in place. So Spring boots launching our application. There we see the inbound channel adapter has pulled the service, and then we see that we created an email for Jan. And Jan is the only person. There's a lot of Jans in this organization. But we can see how that messaging flow is working via these two adapters set up and the purpose of the outbound channel adapter. This chapter will begin our exploration of external system integrations using Spring Integration. This means that our Spring Integration application will be communicating with systems outside of the application. So far, all of our work has focused on internal message exchanges using Spring Integration's messaging architecture. Now, we'll be using endpoints such as adapters and gateways to reach beyond the boundaries of our application. We can use Spring Integration to perform integrations with external systems such as relational databases, JMS, FTP servers, and many other types of systems. In this chapter, we'll be focusing specifically on basic integrations with the file system. Let's take a closer look at our chapter. We'll begin by working closely with Spring Integration's file namespace that provides various message endpoints for supporting the integration with the file system in a convenient manner. We'll first take a look at two adapters that allow us to read and to write files. These one-way components allow for quick configuration of file reading message source and file writing message handler beans that perform the work of reading and writing files. From there, we'll proceed to working with a transformer that transforms our message's payload from an underlying type of file to another type, in our case, a string. Finally, we'll work with a gateway inside of the Spring Integration file namespace. This message endpoint allows us to write files to the file system similar to the adapter. However, the gateway also provides the option to return a message. Its support for two-way communication may be necessary for particular types of message flows. This is an exciting chapter because we'll start moving beyond the messaging architecture to see the other major function of Spring Integration, and that's the external system integration that it performs. And we're going to start with one of the most basic integrations, the file system, so we can establish a very good foundation to move on to more complex integrations. In this lesson, we'll learn how to use Spring Integration to read a file off the underlying file system. Specifically, we're going to use an inbound channel adapter within the file namespace included within Spring Integration. The file namespace provides us with several tools for interacting with the underlying file system. After working through this lesson, you will see how convenient Spring Integration is for working with the file system. To get started, we need a file to read. So we're going to navigate to the Package Explorer and then head to the source test directory, and we'll open the new file wizard and create a generic file. I'm going to go ahead and name this file sample.txt and hit finish. Within this file, just add any text you would like. I'm going to say this is a sample file, and then I'll save the file and close it. Now we can navigate to the integration-context.xml file, and we'll add the file namespace. So click on the Namespaces tab at the bottom of your screen, and then click on the int-file namespace, and it will be added to your configuration file. With that namespace in place, we can then reference the namespace by typing int-file. You'll notice that the autocomplete gives us a number of selections. These each represent tools within the file namespace that we can use to work with the file system. In our case, we're going to select an inbound channel adapter. This adapter is capable of reading in a file off the file system and then placing that file onto a channel. Now, we need to provide some additional configuration for this adapter. The first piece of the configuration that we need to provide is the directory attribute. So we start out by specifying a file prefix and putting a colon, and then we can write the directory we would like to look in. In our case, we put our sample.txt file within the source/test directory. The way we have specified this value, it is configured to use a relative path. So this is going to be relative to our project. If we would like to use an absolute path to a directory on the file system, we would just go ahead and put a / at the beginning. In our case, we want to stick with this relative path. Now the next important attribute is the file name -pattern, and you also see the file name -regex. And these two attributes allow us to select the files we'd like to read in using the inbound channel adapter. Notice I said files, and that's because you can configure both of these attributes to read multiple files either by use of a regex or by the use of wildcarding. So we're going to use the file name -pattern attribute, and we're simply going to use the name of our file, sample.txt. Now we could do something like this in wildcard and pick up every file whose name starts with sample. In our case, we're just going to stick with the absolute name of our file. The next attribute that we need to specify is the name of the channel we would like to place the file on as a message. So the file will become the payload of a message, and then we'll drop it onto the specified channel. In our case, we're going to create a channel named inbound channel, and we'll just go ahead and below our inbound channel adapter, create a new channel with the name inbound channel. Okay, so we have the channel we would like to place our file on, which will be the payload of our message. And then finally, we need to add a polar within the body of the inbound channel adapter. And we can specify a fixed rate of, let's say, every 10 seconds, check this directory for the file. And the polar is just going to make sure that we continuously check that directory. And then we need to modify our channel tag to use an ID as opposed to a name. We have the basic setup. Now that we will be reading this file, we need a place to put it. So let's create a new class, and we're going to name this class our file printer class. And within this class, we're going to add a method print that returns void, and it's going to accept a file as an argument. And then we're going to create a buffered reader, and we'll name it reader, and we'll assign its value to null. And then what we can do is we can create a new buffered reader using the constructor, and then within that we're going to create a file reader, and then we pass in our file, and at this point we have our file set up with a buffered reader. We'll need to then surround everything with a try catch to catch any exceptions. I'm just going to make this very generic, because this isn't really the point of our demonstration. We're just trying to read our file and print it out. So when we read a file, we'll read it line by line. So I'll create a string to hold the line. And then I'm going to assign reader.readLine to our string line. I'll check that it's not null. and then I'm going to print out the line. And then within a finally block, we want to grab our reader and close the reader. And then we're going to surround this with a try-catch. So we get a lot of exception handling here. But basically, we create a file printer that will be delivered the file over the channel, and then it's going to print out the contents of that file. And anytime we have a class like this, we'd like to integrate into the messaging system. You know that we need to declare a bean. So let's call this the file printer. And then we're going to specify the class as our file printer class. And then we use the integration namespace to make a service activator. We refer to our file printer bean, and then we need to specify an input channel. And in our case, the input channel will be the inbound channel. So with our inbound channel adapter in place, as well as our channel and service activator, we're able to run this demonstration, and we can go ahead and kick off the application and then navigate to our console. And what we'll see is that we get the contents of the file written to our console. And that's all thanks to the inbound channel adapter, which was able to read that file off of the file system. In this lesson, we'll learn how to write files to the file system using Spring Integration's Outbound Channel Adapter. Within Spring Integration's file namespace, we'll find a convenient approach to using a file writing message handler to write files to the file system. The namespace will mask the configuration of the file writing message handler bean, and that bean will be used to perform the heavy lifting of writing a file. Let's take a look at this component in action. To get started, let's navigate to our Package Explorer, and within the source test directory, we're going to use the new dialog to create a new folder. So simply type folder into the wizard and then select the folder, and we're going to name the folder read. We'll then create another folder within that same directory, and this directory is going to be named write. Next, simply grab the sample.txt file and drag it to the read directory. And you'll see that that file is now located inside of our newly created directory. As you can imagine, we are going to read the sample.txt file from the read directory, and we'll use Spring Integration and the file namespace to write the file to our write directory. In order to do that, we need to configure some components inside of our integration context.xml file. To do that, I'm going to remove our service activator and its underlying bean. Now, within this file, we can begin to add our outbound channel adapter. So we once again use the file namespace, and we can see the outbound channel adapter available in the IntelliSense. And then we're going to begin to configure this adapter. So like the inbound adapter, we can specify a directory. And in our case, we're going to specify the source test write directory, and this is the directory where our file will be written. Now, while we're thinking about these directories, let's modify our inbound channel adapter to read the file from the read directory. The next thing that we'll do is we will specify the channel attributes value. And this is just the channel that is going to deliver the message containing the payload which has our file. And in our case, it's going to be the inbound channel. So the inbound channel adapter picks up the file, places it on the inbound channel, and the message is delivered to our outbound channel adapter. Now, when working with an outbound channel adapter, it accepts messages that have a payload of type file, string, byte array, and input stream. In our case, we're just going to work with the underlying file. Now you'll notice with these changes in place, we can navigate to our Spring Integration application class and launch our application. And then if we take a look after refreshing our Package Explorer, we have now wrote the file to the right directory. Returning to our integration context.xml file, let's take a look at some more advanced configurations. One of the things we can specify is that the outbound channel adapter should automatically create the directory. So for example, if we save our XML file and then we go ahead and delete the sample.txt file as well as the right directory, we can then go ahead, run our application, and then if we navigate to our Package Explorer, we can refresh the Package Explorer and you see that the right directory was created and then the sample.txt file was written within it. Now let's return back to our integration context.xml file and explore another feature of the outbound channel adapter. And this is the mode feature. And if you take a look at the mode feature, it allows us to define the behavior if a file already exists. So we can fail, we can append, we can ignore, we can replace. Let's go ahead and specify replace. And what we'll do is we'll open our sample.txt file and let's make sure this file is within the read directory, and we can see that by hovering over the tab, and it is indeed. So let's say this is a sample file that we have modified. And now I'll close that file, and when we run our application, you'll notice that the sample file that is written will overwrite the existing file. So here, if we refresh that file, we see now that we get this is a sample file that we have modified. And that's because we have specified the behavior of the outbound channel adapter. Let's take a look at one more attribute on the outbound channel adapter element, and that's the delete source files attribute. And we can go ahead and specify that we would like to set its value to true. This is a Boolean true or false. And what you'll see now is that if we are to execute our application and then we take a look within our Package Explorer, the file within the read directory, and let's make sure that kicked off. Okay, so we've kicked it off. And now when we take a look at the file within the read directory, we see it gets removed. Oftentimes when processing files in this manner, you'll want to delete the file if it has been successfully processed, and Spring Integration just provides a very convenient way to do that. And then another simple attribute we'll quickly take a look at is the file name generator. And this attribute allows you to specify some other name for the file, and there's different ways that can be completed. You can use a spell expression, and you can basically name the file whatever you would like using this file name generator attribute. So in this lesson, we learned how to use the outbound channel adapter within Spring Integration's file namespace to write files to the file system. And this is just one of the ways our Spring Integration applications can collaborate or integrate with external systems such as the file system. In this lesson, we'll learn how to add a transformer from the file namespace to our message flow. The transformer will allow us to convert the payload of our message from a file to a string. As we explore additional integration support within the course, we'll find these types of transformers throughout the Spring Integration framework. Our demonstration will give us hands-on experience using these types of components which are specific to a particular type of integration. To get started, we're going to add an additional method to our file printer class. So within the class, simply add a new method that returns void, and we'll name this method print and we'll have this method accept an argument of type string, and we'll just name that string file. The next thing we'll do is we'll print out some console output, and the output will simply specify that we are invoking the print method that uses string arguments. So we'll say invoking the print method with a string. And this is to distinguish it from its counterpart, which is invoked using a file. Next, we're going to simply print out the string to the console. And that is all we need to do within the file printer, but now we need to head back to the integration context.xml file, and we're going to put back in place a bean for this class. So file printer, and then we specify the file printer type. And then we're just going to add a service activator so we can invoke this newly created method. And we need to specify an input channel for our service activator. And in this case, we're going to define a new input channel named transform channel. So let's go ahead and create the transform channel. And at this point, we are ready to add our transformer into the message flow. So the inbound channel adapter is going to pick up the file and make it the payload of the message, and it's going to place that message on the inbound channel. And unfortunately, the message is not of the appropriate type because it's a file for our service activator to process with our newly created print method. So what we'll do is we'll create a new transformer using the file namespace, and here you see two available transformers. In our case, we want the file to string transformer, and then it's as simple as specifying an input channel, which in our case will be the inbound channel, and then we need to specify the output channel, and in our case that is the transform channel. And then we'll just comment out the outbound channel adapter for now. And for comments we need 2 dashes, and to end that we'll need 2 dashes. Okay, so here we have a flow in place that will pick up a file from the file system, send it to the inbound channel as the payload of a message. The inbound channel delivers it to our transformer. The transformer converts the file to a string and then places it on the transform channel, and the channel drops it off with our service activator that will send the message to the file printer where the contents of the file will be printed. So we can go ahead and launch the application, and then we're going to navigate to our console. And you'll notice that nothing is processed. And if we take a look at our package explorer, that's because we do not have a file within that read directory. So simply right click on the sample.txt file, and you can click on copy. And now watch what happens to our console as soon as we paste it within that directory. So we paste it, and now it got picked up. So if this were some process that were dropping the file there, it would pick it up with the polling. And we see that because our console immediately printed the output because the file was picked up and processed. So here we see that we invoked the print method with a string, and then we got the contents of that file. And this was all made possible by our transformer that we put in place in the message flow. And one additional thing I'd like to point out is that if we take a look at the file printer, it had two methods named print, and that's actually what we specified within the service activator. Spring integration was smart enough to check the payload type of the message and choose the appropriate print method based upon the message signature and its applicability to the payload type. So it's another way that Spring integration does a great job of supporting our message flows. Within Spring Integration's file namespace, we'll find the Outbound Gateway component. You'll remember that unlike adapters, which provide one-way communication, gateways allow for two-way communication. This means they are capable of receiving a message and sending a message in response. In this lesson, we'll take a look at the Outbound Gateway within the file namespace. This component is used to write a file based upon a received message and then to pass the message to another channel for continued processing. To get started, we'll work within the integration context.xml file, and we're going to be interjecting a gateway between our transformer and our service activator. So to do that, we use the integration file namespace, and if we take a look on that namespace, we will find the outbound gateway element. The outbound gateway element has a number of attributes that we can specify. The first is the request channel, and this is the channel that will deliver messages to the gateway. In our case, we're going to wire it to the transform channel so that it receives messages from the file to string transformer. Next, we're going to specify a reply channel. And this is a channel where messages will be placed after the gateway finishes its processing. For the value of this attribute, we're going to specify a new channel named outbound channel. We will need to go ahead and create this new channel within our integration context.xml file. So I'll just build a channel and have its ID as outbound channel. And then we are going to connect the service activator to this channel by specifying the outbound channel as the input channel for the service activator. As the two-way communication of the gateway is processed, the request channel will deliver the messages to the gateway, and the reply channel will deliver the responses to the service activator. Now next, we need to provide some additional configuration to our gateway. The gateway will write the file to the file system and then pass the message on for continued processing. We've supplied the configuration for how it will receive and send messages, but we also need to remember that it's writing messages to the file system, and we need to provide configuration that details how that needs to occur. So much of this configuration is duplicated from our outbound channel adapter. So for instance, there is a directory attribute, and we're just going to specify the same directory that we have for our adapter. We can also specify an auto create directory attribute and set that to true, and we'll make sure the mode is equal to replace. And at this point, we have established our message flow. So we're going to read the sample.txt file off the file system with the inbound channel adapter. We send that file as a message to the inbound channel, which delivers that message to the transformer that is capable of converting this message to a string. That string becomes the payload of a new message, which is placed on the transform channel that delivers the message to our outbound gateway. The outbound gateway is capable of taking that string payload and writing it as a file to the file system. In addition, it sends a message to the outbound channel, the original message it received, and that message then goes to our service activator for printing to our console. So to demonstrate this, the first thing I'm going to do is check to make sure we have a file to read, and I will also delete the file that is in the right directory. So just simply hit delete and then hit OK for the confirmation. And now when we run our application, we can kick it off and we'll watch our console. We'll see the console output, and there it is. This is the contents of sample.txt, which was written. And now we'll also see, if we refresh our directory structure in the Package Explorer, that the sample.txt file was written. And this was all made possible thanks to Spring Integration's Outbound Gateway. and it's capable of receiving messages as well as sending messages, and this contrasts with the adapters that are more for one-way communication. Spring Integration provides support for integrating with FTP servers. Most of you are probably familiar with FTP or File Transfer Protocol. FTP allows us to transfer files between a client and a server through an established connection. Often the FTP server acts as an intermediate drop point used to share files between two systems or organizations. This chapter will explain the details of performing FTP integrations using Spring Integration. Let's take a closer look at its contents. For the most part, we'll be using Spring Integration's FTP namespace to establish a set of endpoints that connect our messaging system and applications to FTP resources. To work with the namespace, we'll start out by installing the FileZilla FTP server and configuring an account to use for file sharing. From there, we'll proceed to build out a Spring integration application that connects to the server. Step 1 of this application is building a session factory that creates sessions with the FTP server for use by Spring Integration. We'll then inject the session factory into a number of components that perform the actual integration with the FTP resource. The first two components we'll explore are inbound and outbound adapters that allow us to read and write files to the FTP server. Finally, we'll conclude by looking at the outbound gateway on the FTP namespace. This component allows us to execute a variety of commands on the FTP server. At the conclusion of this chapter, you will have a good understanding of the tools provided to us by Spring Integration that help us integrate with FTP servers. In order to run our FTP integration demonstrations with Spring Integration, we'll need to download and install an FTP server. To do that, we're going to search for FileZilla from Google, and then we're going to go ahead and select the first result that we get from our search. So here we see the filezilla-project.org. We'll navigate to that site, and then we'll see the FileZilla server, and below that is a download link. Click on that download link, and then select the appropriate option for your operating system. I'm using Windows, so I can just go ahead and click on the green button here, and that will take us to a page where our download will begin shortly. I'm just going to click the direct link in order to kick it off a little faster, and eventually we will get a dialog asking us where to save our installer. And you'll notice that I have already downloaded the file and placed it on my desktop, so I'm not going to make you watch me download this file, but place it at a spot where you're familiar. So let's navigate over to my desktop, and now we can double-click on the FileZilla server and simply hit yes to allow this program to make changes to your computer, then accept the license. And then I normally don't like to install a desktop icon or a start menu shortcut. You can configure your installation however you'd like, but you do need to have the FileZilla server installed as well as the administration interface. Once you have this customized, hit next, and then you need to pick an installation directory. I'm going to install to a folder named Services on my desktop. So I'll select that file and then hit next. And then it's going to ask you how you would like to start the FTP server. By default, it will be installed as a service and started automatically. I normally like to start my services manually, so I'm not taking up a bunch of additional resources when I boot my machine. With my preference selected, I'll go ahead and hit next. And then from here, just go ahead and hit install, and you'll see the FTP server begin to install, and eventually it completes. And now we can go ahead and work with the FileZilla server. You'll notice that it automatically opens, and it asks us to provide credentials to access the admin interface. Well, by default, there are no credentials, so just hit connect and you will connect to the server. But then the first important thing to do is go in and go to your settings and then your admin interface settings, and let's apply a password. So I'm just going to use password for my password to the interface and just go ahead and hit OK. And you will see that you'll get some sort of notification, and let's disconnect and now reconnect to our server. I'm not going to supply a password, and you can see that now it's trying to reconnect because I didn't enter my password. Let's now try with our password, and this time we should see a successful authentication, and there indeed we do see we're logged on. Now we have the server installed, it is protected, and we can work with this server in order to run integrations with Spring Integration. Spring Integration can pull files off of this server. It can also write files to this server, and we'll take a look at some techniques we can use to accomplish those tasks. In order to integrate our Spring Integration application with our FTP server, we'll need to set up an account as well as some directories that we would like to access on that FTP server. We'll first work on the directories. So you'll remember that I had created a services directory on my desktop, and within that directory I installed FileZilla. So now we're just going to create a new folder within that directory, and I'm going to name it shared, and then inside of that directory I'm going to create another directory called files, and this is where we are going to exchange files with the FTP server. Now while we're working on this, I'm also just going to go ahead and create a new text file, and we'll use that text file as we work with the FTP server. So let's call this FTP-sample, and then inside of this file we can add some content. So you can type whatever you'd like in here. Let's just say hello world from Spring Integration FTP, and we'll go ahead and save that file, and now we have our example file set up. Now what we'll do is we'll navigate over to our FileZilla server, and we're going to perform some additional configuration. Click on Edit within the menu and then select the Users menu item. You'll notice that we can set up accounts on the server. So here is a Kevin account which I have created. We're going to go ahead and remove that account and add a different account. So I'm going to name this account KBauerSocks, and we'll hit OK. And then I can go ahead and click the password option, and I'm just going to specify a password of password. You can use whatever credentials you would like. Now if we navigate to our shared folders, what we can do is add a shared folder that is accessible for the KBauerSocks user. And you can probably guess we're going to look within that services directory, and we'll select the shared directory. And then I'm going to make this writable, deletable, and appendable. So we're going to give all these file permissions as well as directory permissions to the KBauerSocks user. And then we can just go ahead and hit OK. At this point, you can see that we are done sending our account settings, and we have set up our KBauerSocks account. We can now use this account when working with Spring Integration's FTP support. In this lesson, we'll set up our first integration with the FileZilla FTP server. We'll be using another namespace appropriately named the FTP namespace, which is provided by Spring Integration. This namespace will be used to establish an FTP inbound channel adapter. The FTP inbound channel adapter will read files off of the FTP server, then write them to a local directory, and finally deliver the files to the message system as the payload of a message. We'll configure this endpoint as part of our demonstration. To begin, we'll need to add a dependency to our pom.xml file. So from within the Package Explorer, open your pom.xml file, and then we're going to navigate to the Dependencies tab. From the Dependencies tab, we're going to click on the Add button, and then type org.springframework.integration. And you can just type a partial there. And this is going to give us all of the Spring integration dependencies. And here we see the Spring integration FTP artifact. We'll go ahead and select that artifact. And you'll notice that it says managed by it. And that's because Spring Boot is providing the appropriate version for our project. Go ahead and hit OK, and then hit Save, and then you can close your pom.xml file. Now, sometimes you need to close and open your integration-context.xml file in order to have that namespace picked up. Let's just go ahead and do that to be safe. So I've now closed and opened the file, and now we're going to add that namespace into our project. And there we see the int-ftp namespace, and we can go ahead and check and uncheck that just to make sure it goes in, and just hit Save to add that namespace. And now we're going to head over to the Source tab, and this is where we will configure our FTP Inbound Channel Adapter. Now you'll notice we already have a file inbound channel adapter set up. We're going to remove that component and we will replace it with our FTP inbound channel adapter. Before we do that though, we need to build out a bean. And this bean is a default FTP session factory. And basically this bean will create the sessions we'll use to connect to the FTP server. So let's give it a ID of FTP client factory, and then we need to specify this bean's type. And as we said, it's the default FTP session factory. And this is a great place to use the IntelliSense to pick the appropriate class. There we have established a bean with our default FTP session factory type, and now we need to provide some of the configuration details. The first is the host, and that's very simply our local host. Now for a production environment, you're going to have probably a server name there. And then we specify another property, which is the port. In our case, we are using port 21. And then we have two additional properties, the username, which was kbowersox. Remember that account we created. You may have a different username if you chose a different value for your credentials. And then a password. And in our case, we like to stick with the password of password here. Keeps it simple for our demonstrations. Now we are ready to begin the configuration of the FTP inbound channel adapter. So we're going to leverage the FTP namespace, and there we see the inbound channel adapter. And immediately it's going to ask us to specify a session factory as well as a local directory. So let's talk about these two attributes first. The session factory we've already established. We know it's the FTP client factory bean that we created. Now, the local directory, remember, this inbound channel adapter reads files off the FTP server, writes them to a local directory, and then sends them on their way on a channel on the message system. So we're just going to write to the source test write directory, and that should sound pretty familiar. And while we're doing this, let's go over and just clear out that directory as well as the read directory. So just select those files, hit delete on your keyboard, and then confirm. We'll navigate back to our integration context.xml file, and we'll continue our setup. Now there's also a remote directory attribute that we need to set up. Now you'll remember we created that directory on our FTP server and it was shared and then /files. And that's where we are going to be looking to pull in these files off the FTP server. I'm also going to specify that we delete the remote files once we've read them. So I'll just set that to true. Then to complete the configuration of our inbound channel adapter, we're going to go ahead and add a puller, and we specify the fixed rate attribute on the puller, and I'll say let's pull every 5 seconds. Now the next thing we're going to do is we're going to establish an FTP channel. The FTP channel is going to be the channel that we have our inbound channel adapter drop the messages on. So let's go ahead and specify that attribute. So there's the channel attribute, and we can say FTP channel. And then I'm actually going to go ahead and remove several of our other endpoints, everything except for our service activator. And we will then set the service activator up to listen on our new FTP channel. So the messages will get sent to our file printer and the contents will be printed out. So at this point, we're ready to run our demonstration. Let's do a quick walkthrough. We're going to read messages off of the FTP server, and we're going to take a look in that remote directory. And actually, this should just be files instead of the full directory, because we will initially start out in that shared directory when we connect to the FTP server. And we're going to read any files within that directory, and then the inbound channel adapter is going to write them to our local directory, and then it's going to send the file to the FTP channel as a message with the file as the payload. That's going to be delivered to our service activator, which will then print out the contents of the file. So let's save our small change and then navigate to the Spring integration application, and we'll launch the application, and we can see it kick off in the console window. Now I'm going to navigate to the file system where I will copy our FTP sample.txt file, and then I'm going to place it within the shared files directory, and we should see it get picked up by our inbound channel adapter. So we're doing that polling. There it got picked up and processed, and if we refresh the Package Explorer, we see the file was written to that local directory. So in this lesson, we learned how to configure an FTP inbound channel adapter. Spring Integration's FTP namespace also provides an outbound channel adapter, which connects the messaging system to an FTP server, allowing files to be written to the server. The endpoint accepts payloads of type java.io.file, byte array, or string, and it writes these files or these payloads to the FTP server. To get started using the outbound channel adapter, we're actually going to create a gateway in order to deliver a message that will be written to the FTP server as a file. So to do that, we're going to create a new interface within the com.o'reilly.integration package, and I'm going to name this interface the File Writer Gateway. So we'll go ahead, and within the File Writer Gateway interface, we're going to add a method that returns void, and we'll name the method write, and it's going to accept a file name as well as a message, and both are of type string. Now what we're going to do here is we're going to add an annotation to each of these parameters, specifying that they are to be a header or the payload of our message. So here I'm saying that the string message should be our payload, and that the string file name should be a header named file name that will be placed on our message. So we'll go ahead and import those types, and be sure to choose the messaging.handler.annotation package. Okay, so we have this File Writer Gateway, and now we just need to build that into our integration context.xml file. To do that, we can rely upon the integration namespace and use the gateway element. And on that element, we're going to find the service interface. And we can specify that the file writer gateway is indeed our service interface. The next thing we'll need to specify is a default request channel, and this is the channel that we are going to deliver the messages to. So in our case, it's going to be the FTP channel. And at this point, we have a gateway configured. Once the gateway receives a message, it's going to place it on our FTP channel, and then we're going to have it deliver the message to our outbound channel adapter. And that's located within the FTP namespace. There we see it, so we can select that. And at this point, we're no longer going to need our inbound channel adapter or a lot of the other components we've specified within our XML file. I am going to need the FTP channel, so I'm going to pull that up above the comment, and now we can begin to configure our flow. So we know there's a variety of attributes we'll need to specify on this outbound channel adapter. It too needs a handle to our session factory so that it can create connections with the FTP server. It needs to be listening on a channel, so we can specify it's going to receive its messages from the FTP channel. We also need to tell it where to write the files. And so we're going to initially connect to that shared directory, and then we're going to say write within the files directory. And then we also need to tell the outbound channel adapter how to name the files it receives. So we're going to work with a remote file name generator expression. And this is a spell expression that allows us to consult the headers on the message and use the header as the name of our file. So here you see that we consult the headers, and then we grab the header with the name of file name, and that becomes the name that we'll use when we write the file to the file system or the FTP server. I'm going to go ahead and save our configuration, and now let's navigate to the Spring integration application. And in this file, we need to auto-wire our new gateway. So I'm just going to establish a field of type file writer gateway, and I'll name that field gateway. And we can import the annotation and that type. And then it's as simple as using the gateway to invoke the write method. And let's say that our file name is going to be example.txt. And then our message is going to be, this is a test of the FTP outbound channel adapter. Okay, so now we have our application set up to use our gateway. It's going to deliver these two arguments to the interface we've established. Those are going to be used to form a message, with the first argument becoming the file name header and the second becoming the payload of our message. From there, once the message is formed, it's placed on the FTP channel and delivered to our outbound channel adapter, where the file is then written to our FTP server. So let's kick off our example, and there we see in our console that Spring Boot is launching the application, and now I'm going to navigate to the file system where our FTP server is configured, and you see that we have written the example.txt file to the FTP server. You can also use the management interface to see the files being written. So for example, here we see the file being written to the FTP server. So in this lesson, we learned how to use Spring Integration's outbound channel adapter to write files to an FTP server. In this lesson, we will be working with Spring Integration's FTP Outbound Gateway endpoint. This endpoint allows us to execute a set of commands against the FTP server. We'll take a look at one of the commands we can execute and demonstrate the use of the Outbound Gateway endpoint. To get started, we need to set up a bit of infrastructure in order to perform our demonstration. The first thing we're going to do is on our file writer gateway, we're going to add a new method, and we're going to name this method read. And we're just going to supply a string parameter that can be used to provide the file name of the file we would like to read off the FTP server. Next, we're going to create a new class, and I'm simply going to name this class MessagingPrinter, and we can go ahead and hit finish. And then on this class, we're going to make a very simple method that returns void, and it receives a message, and then it takes that message and prints it to our console. Okay, now we're going to navigate to the Spring integration application, and we're going to modify our application to use the newly created gateway method. So we're going to invoke the read method, and then we're going to look within the files directory, and we're going to read the example.txt file. So make sure that you have the files directory within the shared directory of your FTP server, and that files directory should contain a file named example.txt. Okay, now let's navigate to our integration context, and we're going to remove several of the components we have configured. So I'm going to remove the outbound channel adapter, and let's remove all of these commented out components. And then what we'll do is we can set up the bean that is going to correspond with our message printer, and I'll just call it MP, and then for the class it's going to be message printer. And there we have our bean, and then we're going to set up a service activator to use this new bean. And the method we're going to invoke is the print method. And now we have our message printer set up as well as our service activator. And now we're going to start tying everything together with our outbound gateway. So what's going to happen is we're going to receive a message from the gateway, and we're going to receive that string, which represents a file we'd like to read off of the FTP server. That is going to be passed to our FTP Outbound Gateway. And you'll see a number of attributes that we need to specify on this gateway. So we specify the FTP client factory, and that's how we're going to get a session to connect to the FTP server. And then the next attribute is the command, and this is very important. So here are all of the commands that you see we can execute using the outbound gateway. So these commands will be executed on the FTP server. And you can see that many of these commands correspond with command line commands that you would execute within Windows or a Unix operating system. In our case, we're going to invoke the get command, and then we need to specify what arguments we're going to supply to that get command as far as what is the file name that we would like. And we're just going to say use the payload of the message that we provide as the parameter for the get command. Next, we need to specify which channel is going to provide that message that contains the payload, which contains the file name. So in our case, we're going to deliver it via the FTP channel because that channel is connected to our gateway. Now, the other thing we need to specify is a local directory. When we get that file off the FTP server, we're going to write it to a local directory with the outbound gateway. And in our case, we're going to write to the source test write directory, that we created within our project. So if you take a look, there's source test write, and that's where our file will be written. Returning to our configuration file, we just have one more attribute to set up, and that is our reply channel. In this case, we're going to make a channel named Outbound Channel. And if we navigate to the bottom of our configuration file, we're going to go ahead and create the outbound channel. And then we're going to hook the outbound channel up to our service activator. So the file is going to get sent to the service activator, which will then print the file. And actually what we're going to do, because we haven't set the service activator up to read a file and to print it, we'll just use another one of the Spring integration components within the file namespace, and that's the file to string transformer, and that will make our work a little bit easier. So the file to string transformer is actually going to get the message from the outbound channel, and then it's going to deliver it to a channel we'll call the transform channel, and then we're going to actually connect the service activator to that transform channel, and we'll need to build that channel out. So basically, we supply a file name to the gateway, which we are doing in our Spring integration application class. That file name goes as the payload of a message to the outbound gateway, which invokes the get command on the FTP server, and there are a variety of commands that this outbound gateway can invoke. You'll have to take a look at the details of each particular command if you want to perform a different command. Now, the get command gets invoked using the payload of our message, which contains the file name, and then we get that file from the FTP server, we write it to the source test write directory, and then we put the file on the outbound channel. The outbound channel is connected to a file to string transformer, which turns our file into a string and passes it to the transform channel, and that transform channel provides it to the service activator, which prints out the contents of that string to our console. So let's run this application, and what we should see when we look at our console is that we will get the contents of that message sent to our console. So here we see the message being sent to the console, and then if we take a look at the source test write directory, you now see that that file is actually written to the directory we specified. So we just took a look at one example of using the FTP Outbound Gateway. As we mentioned, there's several commands on this gateway that you can explore, and they'll each have a bit different set of attributes you'll need to specify, but they're all pretty easy to follow along with. Spring integration also provides support for integrating with relational databases via JDBC. As a Java developer, you are most likely familiar with using JDBC to connect to a database and perform some sort of CRUD operation. JDBC connections allow us to store and read persistent information in databases for use by our applications. When integrating applications, it's not uncommon to make a JDBC connection from one application to another application's database using a direct JDBC connection. Spring integration allows us to abstract this communication using its JDBC integration support. Let's take a closer look at our chapter. The overarching goal of this chapter is to get you comfortable with using Spring integration to integrate with a relational database. We'll check out a variety of methods provided by Spring integration to establish those integration points. We'll first set up an H2 embedded database and establish a data source that forms the connection to the database. This will give us a data store to work with through our examples. From there, we'll proceed to building out a Spring integration application that integrates with our established database. Next, we'll inject the previously established data source into a number of components that connect our application to the database. The first two components that we will explore are the inbound and outbound channel adapters. These components allow us to read and write records to a relational database with JDBC. We'll see how the message system passes messages. However, the adapters are capable of converting these messages into database records or converting a database record into a message. And from there, we use our messaging system within Spring integration to pass around these messages. Finally, we'll conclude by looking at the outbound gateway. The outbound gateway is provided within the JDBC namespace. The component provides us with the capability to receive or send messages. At the conclusion of this chapter, you will have a good understanding of the tools provided to us by Spring integration. Using these tools, we will be able to integrate our Spring integration applications with relational databases. In this lesson, we'll configure our project to include an embedded database that we'll use to perform JDBC integrations with Spring integration. So to get started, we're going to be modifying our pom.xml file to include a number of libraries to support our JDBC integrations. So we'll open the pom.xml file, navigate to the Dependencies tab, and then within the Select Dependency dialog, we're going to first add our database, which is com.h2 database. That's the group ID, and the artifact ID will be h2. And this includes an embedded h2 database within our application. The next thing we'll do is we will use the org.springframework.boot namespace, and within that namespace we're going to find all of the different starters available to us within Spring Boot. We're going to be using the spring-boot-starter-JDBC dependency, and this artifact is going to provide us with a simple way to construct a data source or a connection to our H2 database. Finally, we need to include an org.springframework.integration artifact, and that is the JDBC artifact within the org.springframework.integration group ID. So there you see the spring-integration-JDBC artifact, and that's going to provide the int JDBC namespace. The spring-integration-JDBC artifact will provide us with the JDBC namespace within Spring integration, and that's going to provide those convenient tags within our integration context.xml file that allow us to easily work with the different JDBC components. Okay, so with those artifacts in place, let's save our POM file, and we can go ahead and close it. Now we're going to clean up our integration-context.xml file. We'll no longer need our gateway or any of the FTP specific components, so we can remove those. I'm going to also remove our file to string transformer, and then I'm going to remove all but one of our channels, and I'm actually going to change that channel name over to JDBC channel. Now let's add the appropriate namespaces. So click on the namespace tab. Well, they're not there. So we're running into that situation where you need to close and then open your integration context.xml file. And like magic, you see the namespaces appear. So keep that in mind. If you're ever missing a namespace, you know that you need to open and close that file. So there's the int-jdbc namespace, and we're also provided with the JDBC namespace. So let's go ahead, save our integration context.xml file, and now we can build out our data source. So if you look at the JDBC namespace, you'll find this embedded data source. And we can provide an ID, so let's say data source, and then we can also specify the type of our database. It's very important to specify this attribute and make sure we select H2. Now, inside of this embedded database tag, we can provide a script tag, and this script tag will be initialized when the database starts. So we just specify a location of a file that we would like to run. And these are almost always SQL files. So let's add that file, and then we'll save our configuration. Now let's build out the init.sql file. So we're going to place this file within the source main resources directory, and we just open the new dialog, and if you type SQL, you can select a SQL file. And we'll name the file init.sql, and then within the file we can specify our script that we would like to execute upon startup of the database. So we're going to build out a table, and we'll name this table person, and we're going to add some fields to the table. Let's add a person ID, and we can make it a primary key, and then we're going to add a first name field as well as a last name field, and we're making both of those varchars. Okay, and then we're just going to simply insert a record into our person table. So I'll just say person number 1 is Kevin Bowersocks. And there we have our init script. And now let's navigate to the Spring integration application, and we'll clean this up a little bit. Remove first the gateway, because we'll no longer be auto wiring in that gateway, and then we're going to remove the invocation of the read method on the gateway because it no longer exists. And once you have that in place, you can clean up your imports and save the Spring integration application. And at this point, we should have our project prepared to work with a JDBC integration. If we would like to validate our configuration, we can simply run our application and then check out our console output. And here we see that we didn't get any issues reported via the console. And if you actually take a look at some of the logging, there you'll see that we actually connected to the embedded data source, and then we shut down that data source. There we see our init.sql script being executed. We did not receive any errors, so we can be pretty confident that the configuration of our database was successful. Spring integration provides us with an inbound channel adapter for working with relational databases via JDBC. This adapter will execute a SQL query against our database and return a list that corresponds with the result set returned by the query. The list will contain a map that corresponds with each row returned in the set. Let's walk through a simple example to see the inbound channel adapter in action. To begin, let's maximize our integration context.xml file. And within this file, we are going to add our inbound channel adapter. And to do that, we are going to use the int JDBC namespace, and there you see the first option within the namespace is the inbound channel adapter. Let's select that tag, and now we are going to specify some attributes on our inbound channel adapter. The first attribute that we are going to specify is the channel attribute, and this is going to be the channel where we will deliver messages to. So the inbound channel adapter will execute our query against the database, and the result set becomes the payload of a message. And that message gets placed on the JDBC channel. Now let's go ahead while we're at it and connect our service activator to the JDBC channel. And our service activator is very simple. It's just going to invoke the toString method on our message so we can see the details of our message. The next attribute that we need to specify is the query. And this is the actual query that will get executed against our database. So we're going to simply select everything from the person table. And then finally, what we need to specify is the data source. So we need to know what database to connect to. And in order to get that information, we reference our data source bean, which defines all of the connection parameters to our underlying database. Finally, within the body of the inbound channel adapter, we will define a poller, because we will execute this query at an interval. So we're going to set our fixed rate attribute, and let's say execute it every 4 seconds. Okay, so we have configured our inbound channel adapter to query our database, and that returned result set gets added as the payload of our message, and then that message is delivered to our service activator, which prints out the message. Okay, so let's run this application and we can watch its execution via the console. So there we see Spring Boot launches the application, and there you can see that we pulled the record from the data store, and we are actually pulling that same record every 3 seconds. And you can see their different messages by the ID header there. But if you take a look at our payload, we see that it's representing a list which contains a map, and each key in the map, so we would have a person ID key and it would have a value of 1. We would have a first name key that would have a value of Kevin. And if we had multiple rows, and let's actually demonstrate that. So I'm going to stop our application, and now I'm going to open the init.sql file. And within that file, I'm just going to add another row. So let's specify this as John Doe. And now we have a huge database of 2 people. And we'll head back to the Spring integration application and run the application. And now we'll see that both of those records are pulled from the data store. And there you can see we now have 2 entries within that list. These would actually be 2 maps, one for Kevin Bowersox and one for John Doe. And there you can see the polling nature of having defined that poller within the body of our inbound channel adapter. So this concludes our lesson on working with a relational database using JDBC and Spring Integration's inbound channel adapter. In this lesson, we'll take a look at the outbound channel adapter, which is the counterpart to the inbound channel adapter. Instead of retrieving messages from the database, the outbound channel adapter inserts records into a relational database based upon a message that it receives. To get started with our demonstration, I'm going to build a few objects. And I'm going to walk through this rather quickly because we've done this type of work before. We're going to build a person class, and this person class is going to have an integer that will name ID, a first name field which will be a string, and a last name field which will be a string. We're going to go ahead and generate a constructor using the fields, and we're also going to generate getters and setters for that person object. We've seen this before. Now what we'll do is we'll create a new interface, and this interface is going to be the person gateway, and we're going to use this gateway to send messages to the message system. It's going to have a public method that returns void, and we're going to name the method save, and it's going to accept a person argument. So we'll go ahead, create our gateway, and now we are going to modify our Spring integration application to auto-wire this new gateway. So we're going to create a person gateway field and we'll name it gateway. And then what we'll do is we'll build a new person using the constructor. So I'm going to build a person with an ID of, let's say, 4, because we already have a few records in our database. And we'll name this person Jane Doe. And then we can use our gateway to invoke the save method and pass it the person. We will end up sending the person as the payload of a message to our message system. Now we need to switch over to our integration context.xml file, and we're going to remove the inbound channel adapter, and then we're going to also establish a gateway that corresponds with our newly constructed interface, the person gateway, so we can specify that type. And then we need to have this new gateway listen on a channel, and we specify that using the default request channel, and I'm going to name that the inbound channel. And then finally, we just need to create that new channel. So our new channel will be called the inbound channel. And we're going to pass those messages to the outbound gateway that we construct. So if we take a look at the JDBC namespace, we're going to find the outbound channel adapter element. And using this element, we can write a record to the database based upon the message that this outbound channel adapter receives. So let's take a look at some of the attributes on this outbound channel adapter. The first is a channel, and this is the channel that will deliver messages to our outbound channel adapter. Well, since we're invoking a gateway method that's going to create our message, and we're going to drop it on the inbound channel, we are going to subscribe to that inbound channel. And then we need to specify a data source so we know how to connect to our database. And we have defined our data source bean below. So we'll just reference that bean. And then here's kind of the tricky part. We need to provide a query to execute. So in our case, we're going to insert into the person table, and then we specify the values. And here we are going to use a bean property expression. So this is a little bit different than spell, but what we do is we start with a colon, and then we can reference our payload, and we can then access the fields on the payload using dot notation. So there I'm accessing the ID field on the person object. There I'm accessing the first name field. And then finally, you can probably guess we're going to access the last name field. And these will be passed as part of our SQL statement. So what we're actually doing is passing these values to be inserted into the person table into the appropriate columns. Now, in a production application, this is not the best way to do it. Always list out your columns. That way you don't have to worry about the order or if you have the right number of arguments being passed into your SQL statement. Okay, and to clean things up, I'm going to switch over to the self-closing tag, and we can remove the end tag for the outbound channel adapter. At this point, our flow is set up, and now what we're going to do is we're going to leverage Spring Boot to get a little bit more debugging output. So if we look within the source main resources directory, we have the application.properties file, and in here we can set our logging level, and we're going to switch it over to debug. For this demonstration, we might not want to keep it there. It's quite a bit of output. And then once we have that in place, we can execute our application. Okay, so now if we take a look at our output, and I think we may have actually executed twice there, but if we take a look at our output, we can see here we're doing some work with the JDBC template, and we can see that our inbound channel got a message, And there we can see that the payload is of type person. So we're seeing this message go through the message system, and there we're preparing our statement, and then we execute the prepared statement. And there you can see the actual call that's going to insert that record into the database, and we're using the driver there. And then eventually we shut things down and disconnect from our data source. So there we were able to use Spring Integration's JDBC Outbound Channel Adapter to write a message to our JDBC data store. The JDBC gateway can be used to perform both write and read operations against a JDBC data store. The component receives a message, which is then written to the database, much like the outbound channel adapter. However, in the case of the gateway, a message is then passed to a reply channel. Let's run through a demonstration to see this component in action. To get started, we will add the component to our integration context.xml file. So at the moment we have an outbound channel adapter established, and we're just going to go ahead, use the JDBC namespace, and then put the outbound gateway in place. Now, if we take a look at the outbound gateway, we're going to see some similar attributes that we would find within the outbound channel adapter. First, we're going to see that we need to specify a channel that will receive our message. And in our case, we're going to use the inbound channel just like we have on the outbound channel adapter. You're also going to find that there is a data source attribute. And once again, we're going to go ahead and use our configured data source. And then you will see that there is an update attribute. And in the update attribute, we specify the query that we would like to execute when we receive a message. So in this case, we're going to insert the person object, which will be within the payload of the message we receive, into our person table. Finally, we'll need to specify a reply channel. And the reply channel will receive the message that is provided by the outbound gateway. So once we perform that update, Spring Integration creates a message, and the payload of that message indicates how many records were updated. So we need to specify that reply channel, and we're going to use our JDBC channel, and that channel is connected to the service activator, which simply prints the message. So let's grab that channel, we'll go up and specify that it is indeed our reply channel, and then I'm going to remove the outbound channel adapter. We can then save our integration context.xml file, and let's navigate to the application.properties file and remove the debug setting. We'll no longer need that. And then we can go kick off our application, and we'll turn to our console to see the output. Okay, so here you can see we got a message that says that we have updated one record, and that was the record which corresponds to the message that we passed to our gateway, which eventually was delivered to our outbound gateway. So we pass that person object to the gateway, it puts it within the payload of a message, it gets sent to the outbound gateway inserts the person into our JDBC data store, and then it sends a message on the reply channel saying, hey, I've updated this many records, and that message gets dropped on the JDBC channel, which is connected to the service activator, and that is eventually delivered to the message printer where we get the details of the message. Now, one of the things we can do, we can change the message that gets sent out from the outbound gateway. And to do that, we need to provide a query. And this query gets executed after we perform the query specified in our update attribute. We then perform this query and it determines the payload of the message that we're going to place on the reply channel. So here we're just going to go ahead and select from the person table where our person ID is equal to the ID on our payload. So we're just going to select that record which we have inserted into the database and place that within a message that's dropped on the JDBC channel to be printed. So let's run this demonstration, and we'll turn once again to the console. And now we should see some output, and there we see our message being printed to the console, and we actually see the headers there along with the timestamp, and then we actually get to the payload, which is going to be this map that contains all of the fields within our person object. So in this lesson, we took a look at the JDBC Outbound Gateway and saw how it can both receive and send messages, and we took a look at how we can modify the messages that it places on that reply channel. In this chapter, we will explore how Spring integration applications integrate with the Java Message Service, or JMS. JMS is an API that dictates how applications communicate. The API defines a set of interfaces that Java applications can use to create, send, receive, or read messages. JMS promotes loose coupling between systems and creates a reliable transport between the nodes. Let's take a closer look at our chapter. Throughout the chapter, we will be looking at the necessary components to achieve different types of integrations with a JMS provider. To achieve this, we'll first need to install a JMS provider. In our case, we will be using ActiveMQ as the provider. Once we have the ActiveMQ server in place, we'll see how to establish a connection to the server from our Spring integration application. Using the connection we've established, we'll then write messages to and read messages from ActiveMQ. To do this, we initially use channel adapters which support one-way communication. We'll see different variations of these channel adapters and learn their behaviors. Finally, we'll work with two types of gateways, inbound gateways and outbound gateways. Remember that gateways are capable of two-way communication. This means that our inbound gateway will receive messages from the ActiveMQ server and then provide a reply to the server. In contrast, the outbound gateway will send messages to the JMS provider and then receive a reply after the JMS provider has a response. JMS is one of the most common integration types used with Spring integration applications, and in this chapter we will teach you the ins and outs of building this capability into your application. In this lesson, we'll set up and configure an ActiveMQ server. ActiveMQ is an open source messaging server provided by the folks at the Apache Software Foundation. ActiveMQ provides full support for the Java Message System, or JMS. We'll be using ActiveMQ to perform our demonstrations of Spring integration support for JMS. To get started, we'll need to download the ActiveMQ software and install it on our machines. So simply from Google, just type in ActiveMQ, and we will then select the activemq.apache.org link, and here is the home page for ActiveMQ. You'll notice the Download ActiveMQ Today link, and we'll click on that link, followed by the link for the latest stable release. Finally, we're taken to a screen where we can download the appropriate distribution type for our operating system. In my case, I have a Windows system, so I will download the first link, which provides me with a .zip file containing the installation. Now, I have already downloaded the file so that you don't have to wait for me to download it. So let's just hit cancel. You would proceed with the download. And then I'm going to navigate to my desktop And from my desktop, we see the zip distribution. Now, you'll remember that we had created the services directory on our desktop earlier, and this is a great place to put our new server. So I'm just going to drag the file into the services directory and then use my favorite extraction tool, 7-zip, to extract the server. Okay, and at that point I can take the zip file out so we do not get confused. And you're going to see the Apache-ActiveMQ followed by the version number directory, and then within that is another directory. And here's where we really get to the installation. Now, in order to kick off the server, we're going to open a command line, and you can see I'm sitting on my desktop, and I'll just from there navigate to the services directory, and then within the services directory, I will navigate to the Apache MQ directory, and we can take a look inside that directory, and you'll see we need to go another level deeper. And let's take a look inside that directory. And here's where we want to be. See that bin directory? That's going to contain the application. So I'm going to clear my screen. From here, I'll navigate to the bin directory, and then I'm going to issue the command ActiveMQ and then start. And this will start up our newly created server. Once the server has been started, we can then access the management console for the server via a web browser. So I'm just going to open a new tab, and I'll type http://127.0.0.1, and then we're going to use port 8161, and we can then navigate to the /admin directory, and that's going to get us to the management console for the ActiveMQ server. The username is admin, and the default password is admin, something you'd probably want to change in a production environment. But here we see the ActiveMQ server, and it allows us to look at the queues available on the server as well as the topics available. So let's go ahead and create a queue. So we're just going to name this queue sample.queue, and we'll go ahead and hit create. And then let's go over and create a topic, sample.topic. And there we've added a queue and a topic to our server that an application could integrate with. In later lessons, we'll learn how to integrate Spring integration with our ActiveMQ server using Spring Integration's JMS support. In this lesson, we'll set up and configure our Spring integration application to connect to the ActiveMQ server. By establishing this connection, we'll then be able to leverage Spring integration components that integrate our application with JMS. As we work through this example, we'll be leveraging other Spring Framework libraries that provide support for Spring integration's ability to connect to JMS. In order to add some of those libraries, we'll need to navigate to the Dependencies tab within our pom.xml file. And at this point, we're going to do a little bit of cleanup. We're going to remove our support for FTP, for H2, and for JDBC. With those artifacts removed, we'll then go ahead and look within the org.springframework.integration group ID to find the JMS artifact. So there's the Spring Integration JMS artifact, and we'll add that to our project. If we save our pom.xml file, we can then take a look at our dependency hierarchy, and we'll see that the Spring Integration JMS artifact pulls in some additional libraries such as Spring-JMS and Spring Core. So it's leveraging the whole Spring stack in order to build this support into Spring integration. In something like Spring-JMS, you're going to find a JMS template which is similar to like a JDBC template, but it will be used by Spring Integration's JMS support underneath the hood to make these transactions occur with our ActiveMQ server. So in addition to that artifact, we will need to add libraries from the org.apache.activemq group ID. And these are the libraries that are going to help us communicate with our ActiveMQ server. So things like establishing connections and queues. And I'm going to be a little bit lazy here and just add the ActiveMQ-all artifact. And that's going to include all of the dependencies that we will need to work with our ActiveMQ server. Next, we're going to head to the integration context.xml file. And the first thing we'll do is actually close and then open this file. And you'll remember that's because the namespaces don't always get picked up. So here you can see that now we have the int-jms namespace, and we'll go ahead and add that. And if we then take a look at our source, you're going to notice we have a few errors, and that's because we've removed all of our support for JDBC. And that's because we're not working with JDBC. So we're going to remove those components from the configuration file. And then we're also going to remove our JDBC channel and actually make it a JMS channel. And then we just change the input channel name on our service activator. So we're going to leave the gateway in place as well as our service activator so we don't have to re-establish those artifacts when we work through our demonstrations. But here's the point where we start to configure the beans specific to our ActiveMQ connection. And to do that, we use the bean tag, and then we're going to create a bean named connection factory. And you can start to see where we're heading here. Just like you need to have some component that knows how to establish a connection to a database, you need the same thing for an ActiveMQ server or any JMS server. And to help us, Spring has provided the caching connection factory bean. And this bean has a property that we must specify. So we're going to use the property tag, and then we're going to specify the target connection factory property. And actually, we're just going to embed our bean for this property to set its value within the body of that tag. So we're going to create another bean, and this bean will reference the ActiveMQ connection factory. And you see we can use IntelliSense to grab our appropriate type. And in our case, we just want the first option. And then what we need to do to configure that bean is actually provide another property. So we're getting some real nesting here within this configuration. And we need to actually specify the broker URL, and we provide a simple string value for this. And it's our protocol, so we're going to use TCP, and then we're going to be connecting to our local host where we've configured the ActiveMQ server. And then by default, that server is set to listen on port 61616. So we need to specify that's the port we'll be using. And at this point, we have configured a connection factory which can be used by Spring Integration to support the components it provides that provide us the efficiencies with JMS. So when we have some sort of adapter or some sort of gateway that connects us to a JMS resource, this is the underlying connection factory that Spring Integration is going to consult, because we need to provide those details about how to connect to that resource. Like other integration types, Spring Integration allows us to work with JMS channel adapters to communicate with our ActiveMQ server. In this lesson, we'll be using the JMS Outbound Channel adapter to send a message to our JMS server. To get started, we'll work within the integration context.xml file using the JMS namespace. So if we take a look, you'll see there is the option to select the outbound channel adapter within Spring Integration's Integration JMS namespace. So let's go ahead and add that element to our configuration file. And now we need to specify some of the attributes to finish the configuration. So the first thing that we'll do is we will specify the connection factory, and we can point to our connection factory bean that we have created. And then next we need to specify the channel that is going to deliver messages to our outbound channel adapter. And in this case, we're going to use the inbound channel. So messages will be sent from our person gateway to the outbound channel adapter, which will then write those messages to our JMS server. Now we need to tell our outbound channel adapter the destination of these messages. And in our case, we need to configure a queue. So we're going to create a new bean with an ID of queue. Then we need to specify the type of that bean, and it's going to be an ActiveMQ queue, and we need to also specify a constructor argument that provides the name of that queue. And in our case, the queue we set up was the sample queue. Now we can specify that we would like our outbound channel adapter to write to the sample queue, which is represented by our queue bean. So with that configuration in place, we can save our integration context.xml file, and we'll actually need to put one more component in place. So one of the problems we'll encounter is that ActiveMQ is not going to understand what our person object is that is being passed to our gateway and to the outbound channel adapter. So I'm just going to use Spring Integration to set up an object-to-string transformer between the two endpoints. So our input channel is going to be the inbound channel, and then we need to set up an output channel, which I'll just name outbound channel. And at that point, we have our transformer in place. We just need to now specify the outbound channel, and that will cause a string to be passed to the outbound channel adapter, which becomes the payload of the message sent to ActiveMQ. Now, one of the things we will do is add the toString method within our person class. That way we get a better representation of our object when we pass it to our server. So let's quickly walk through this. We are going to, within our Spring integration application, invoke the save method on the gateway, passing it in a person. Within the integration context.xml file, we have set up a gateway to receive that person object and make it the payload of a message which is sent to the inbound channel. The inbound channel is connected to an object-to-string transformer, which is going to invoke the toString method on the person object. It will then make the result of invoking the toString method the payload of a message that is placed on the outbound channel. That outbound channel is then connected to our outbound channel adapter. And it's good we took a look at that because we need to switch the channel that will be dropping messages to that endpoint. The outbound channel adapter will then send that message to our destination, and that is an ActiveMQ queue that we have established. It knows how to connect to that queue because we have configured a connection factory that provides the details for connecting to our server. Okay, so let's run this application and we'll monitor the console while it executes. Okay, so we see that the application is ran, and now if we navigate over to our administrative console with ActiveMQ, You can see that we have one pending message on our sample queue. And if we take a look at that message, we should be able to see the message details. And right there is the body of the message, and that was created by our application and passed to ActiveMQ through Spring Integration's JMS support. And that was provided via the outbound channel adapter. So in this lesson, we learned how to communicate with a JMS server by sending it a message using Spring Integration's JMS support. Spring Integration also provides support for the JMS Inbound Channel adapter. This adapter is used to retrieve messages from a JMS queue by polling the queue for any new messages. Any new messages found will then be sent to the messaging system for distribution. This is pretty simple. Let's walk through a quick demonstration. We'll get started by working within our integration context.xml file. Within this file, we already have established an outbound channel adapter that is capable of sending a message to the JMS queue. Now we will add a component that is capable of receiving that message off of the JMS queue and distributing it to our message system. And that component is the inbound channel adapter, which we can find within the JMS namespace. So right there we see the inbound channel adapter, and we can go ahead and add that element to our configuration file. Now, if we take a look at the attributes on the inbound channel adapter, some of them are going to look pretty familiar. First, you'll see the connection factory, and you can safely assume that we need to tell this component how to connect to our ActiveMQ installation, and the connection factory has those details. The next thing we need to specify is a destination. And this is the queue that we would like to read messages off of within our JMS server. Finally, we need to supply a channel. And the channel is the place that we will place any messages that we have read off of our destination. In our case, we are going to place our messages on the JMS channel. And you will see that that channel is connected to a service activator, which invokes the print method on the message printer bean. And that message printer bean simply prints out the contents of a message by invoking its toString method. Now, anytime we are receiving messages from a message source, such as our ActiveMQ installation or our JMS server, we need to be operating in one of two manners. Either that resource is going to push us the message, or we are going to reach out and poll that resource to see if any messages are available, and if so, bring them back. So the first thing we're going to look at is setting up a poller within our inbound channel adapter. We have seen these in the past, and you know that we can set the fixed rate attribute. And I'm going to set this for 7,000 milliseconds. We have now configured our application to poll our ActiveMQ server, and anytime a message is there, we're going to send it on the message system, eventually reaching our message printer, which is going to print out that message. Now, how are messages going to get on the queue? Well, we do have our application set up to fire a message to the ActiveMQ server, and then we're going to pick that message up with the inbound channel adapter. Now, to make this a little bit more transparent, we're going to add some debugging within our application. So we'll just print some information out to the console. Obviously, this isn't production quality debugging. It's simply for our examples here. But we're going to say that we are printing the message, and then we'll print the message after that. And then within our actual application, let's just put a little notice when we sent the message. So we'll just say the message has been sent to JMS, and we'll save that. And at this point, we are ready to run our application. So let's kick off the application and then navigate to our console to see it in action. Okay, so we see the message has been sent, and now roughly 7 seconds later, we should be reading that message off of our JMS queue. And there it is. And there we're printing out the message that we received from the queue. Now let's take a look at this message. The first thing you'll see is that the payload is actually a string. So that was what we had sent. We invoked the toString method on our person object when we sent the message, and we received that string message back, and that's because the message was actually sent to JMS as a text message. And any text message will be converted to a string type payload. But what you'll also see is a number of headers related to JMS that come back. So there we see a JMS message ID, and these are actually going to correspond with information that was generated on our JMS server when the message was received. So in this lesson, we learned how to set up a JMS inbound channel adapter, and this component is used to continually check in with a JMS server to see if any messages are available on a particular queue. If they are, we then place that message onto our message system and proceed with the logic of our application. In this lesson, we're going to take a look at another way that we can receive messages off of our JMS queue. So we saw that an inbound channel adapter can be used to retrieve messages off the queue by polling. So here we have our inbound channel adapter, and it's set up to check with our ActiveMQ installation every 7 seconds to see if there's a message. So this is our application initiating a check against the server to see if there's a message. Now, the opposite approach is for the server to notify us when a message becomes available. And that's exactly what we're going to take a look at. So if we inspect the JMS namespace, you'll see that there is a message-driven channel adapter. So I'm simply going to switch over to this new element, and this means that we're going to use a little bit different of an approach. We're going to receive a notification, and that's the message-driven part, when a message arrives on that JMS queue. So the attributes that we supply for this element are pretty much the same as those that we supply for the inbound channel adapter, except we are no longer polling, so we don't need to have that poller in place. And in fact, we don't have to put anything in the body of that tag, so we can use the self-closing form. Now, while we're running through this example, and this is really all we need to set up this new approach to receiving messages, let's take a look at the connection factory attribute. If you were to look at the documentation for Spring integration, a lot of the examples are going to exclude that connection factory. And it will work because by default, that attribute looks for a bean with the name connection factory as we have specified. So if you didn't want to include that attribute in every tag, you could take that approach. I really advocate for being verbose with your configuration and leaving that attribute in place. That way, any new developers or anybody entering your project gets to see the connection between that connection factory and the other JMS endpoints. Okay, so with our new message-driven channel adapter in place, let's go ahead and we'll save our integration context.xml file. We will open up our application and we can run it and then navigate to our console, and this time you will see immediately that we get the message returned. So there we see that the message gets sent, and then we actually print out the message. So it was actually very rapid how quickly we got the message back. In fact, we got the message back before we even print out that our message has been sent. So we got notified very quickly by our ActiveMQ server that, hey, I have this new JMS message, and I was told to provide it to your application via the establishment of our message-driven channel adapter. So it's a little bit different of an approach to receiving messages that we can use within our Spring integration applications. Within Spring Integration's JMS namespace, we'll also find some gateways available to us. In this lesson, we'll take a look at the Inbound Gateway. This component is used to receive messages from a JMS server and in turn provide a response to the received message. We'll talk through the details of this component with a simple example. We will be working in the integration context.xml file, and what I'm actually going to do is take two of the important components and pull them to the top of the file, just so we can isolate them a little bit. Okay, so we have our message-driven channel adapter, which we're actually going to turn into an inbound gateway. So I'll just go ahead and switch over to the inbound gateway, and you'll notice that the only attribute that sticks is the connection factory. We'll talk about some of the other attributes here in a minute. What we're going to do with this component is we're going to receive a message from the JMS server, or our ActiveMQ server. And this is just like the message-driven channel adapter. The message is going to be pushed to us, then we're going to receive that message via the push from the server using the inbound gateway, and the gateway is going to put that message onto a channel. So once that message is placed on a channel, it will be delivered to an endpoint where some processing can occur, and then a message can be sent back. The message that is then returned to our inbound gateway will be delivered back to the JMS server. So that means we have a couple of attributes that we need to define. The first is going to be our request destination. So this is the queue on the ActiveMQ server, or our JMS server, that is going to deliver requests to the inbound gateway server. And that's how this all gets kicked off. The message comes from the server to the inbound gateway, and it's going to be delivered via this queue that we've defined. The next thing that happens is we need to place that message onto a channel. And in this case, it's referred to as the request channel, and you can see that we have connected that channel to our service activator, which is connected to our message printer. Now the message printer needs to respond with a message, so we're going to change it from a type of void on its print method to a type of string, and then we're going to return just some content here. So we'll say one message worked, and this just indicates that the printer has worked on one of the messages, and this will go back as a message with a string payload of one message worked. So that comes back to the inbound gateway, and now what we need to do is we need to specify a default reply destination, and this is defined normally as an ActiveMQ queuebean. Just like we defined our sample.queue, we're now going to define another queue on the server. And I'm just going to make this queue's name reply queue. Well, it doesn't just work to define it within your configuration file. You actually need to have that queue available on the server. And we also need to have a distinct name for that bean that represents that queue. So let's first add the reply queue as our default reply destination. And that means we're going to send the message that comes back from our service activator, which is tied to our inbound gateway. We're going to take that message and send it back to the reply queue on the JMS server. Now, if we navigate to our ActiveMQ server, which is our JMS server, and we take a look at the queues, you see we do not have that reply queue defined. So we'll simply create it. Now that that queue has been created, we have a place to send our messages to. So I'm going to go ahead, save the integration context.xml file, and then we're going to walk through what is going to occur here. We have defined our connection factory that tells us how to connect to the ActiveMQ server. We have also defined the gateway, which can have its save method invoked and have a person argument passed to it. And we do that within our Spring integration application. Here we're passing a person to the gateway. And then if we take a look at the configuration of that gateway, it places that message on the inbound channel. The inbound channel then transforms the person object to a string and then fires the message off to the JMS server. And that's how we get a message out there. That message is going to then be delivered to our inbound gateway. The inbound gateway is going to receive the message from the queue out on the server, and it's going to have that message pushed to it, and then it's going to take the message and put it on the JMS channel, which is connected to the service activator that is going to drop the message to the message printer. The message printer is going to print out the message and then reply that it has worked the message. That becomes its own message with the payload of one message worked, and then that's passed back to the ActiveMQ server on the reply queue. So let's take a look at all this in action. I'm just going to kick off the application. We'll watch the console here. So we see the message get sent to the JMS server, and that's coming from our application. Then we received the message back via the inbound gateway, and we printed out the message. Now what should have happened is we should have had another message go back to the reply queue. So once I refresh the queues here, we then see that we now have one message, and if we inspect the queue, we can indeed see our message, and there is one message worked. So the inbound gateway provides us with a way to receive messages from a JMS server and then do some work and reply with another message that is transported back to the JMS server. The final component we will discuss within the JMS namespace is the outbound gateway. This component is used to send a message from the Spring integration application to a JMS queue. Once the message is placed upon the queue, another entity works the message and places a response on a reply queue from which the outbound gateway receives the message. Once the outbound gateway receives the message, it passes it on to Spring Integration's messaging system for further processing. It's a little complex, but we'll walk through it step by step, and by the end of this lesson, you'll have a good understanding of the JMS Outbound Gateway. We will start our work within the integration context.xml file. If you inspect this file, you'll notice that I have rearranged some of the components. So for example, I've moved all of our channels as well as all of our queues and our connection factory to the end of the file. We've seen a lot of these throughout the chapter. You'll also see that I moved our inbound gateway below our outbound channel adapter. And remember, the inbound gateway is going to monitor a queue, the request destination, and it will receive messages from the queue and process them and then return the processed message or the reply to the reply queue. So the whole time we run our demonstration, we're going to have the inbound gateway monitoring our queue for messages that it can work and provide a reply to. You'll also remember we have our gateway, which allows us to invoke a method that creates a message and passes it to a channel. And in our case, at the moment, it's going to the outbound channel adapter, and that's simply sending a message to our queue. So what we're going to do now is we're going to remove our outbound channel adapter and we're going to put in place the JMS Outbound Gateway. So there we see the Outbound Gateway element. And if we take a look on that element, we're going to find a number of attributes that we need to supply. The connection factory, as always. Then we're going to supply a request destination. So what happens is we're going to pass the outbound gateway a message and it's going to fire that message against a JMS queue. In our case, we just want it to be the queue that we've established, which I believe is sample.queue. That's where we'll send our messages on the ActiveMQ server. And then we need to specify the channel where we are going to listen for messages to arrive. So we're going to make the outbound gateway listen or be connected to the outbound channel. So whenever a message is placed on the outbound channel, it arrives at the outbound gateway and then that message is fired off to the ActiveMQ server. Now at the ActiveMQ server, what actually will happen, you'll notice we have our inbound gateway set up to monitor that queue for any messages that arrive. So once the outbound gateway sends the message to the ActiveMQ server on our sample queue, the inbound gateway is going to pick it up, send it to the JMS channel, which our service activator is connected to, and then it's going to invoke the print method on the message printer. And notice that the print method returns a message saying one message worked. And let's just modify this a little bit. Let's say from the inbound gateway, and we can save that. And now we're going to return to our integration context.xml file, and we'll continue the setup of the outbound gateway. So what we need to tell the outbound gateway is where to find that response. So it wouldn't need to exactly be an inbound gateway. Some other system could pick up that message on the ActiveMQ server, do the processing, and then place it upon a reply queue. And we've specified a reply queue within our configuration, and remember that queue is named reply.queue. And that happens to be the queue that our inbound gateway is placing its response to any messages from our sample.queue. And like I said, that could be any system providing that response, placing it on the reply queue. Now, once the outbound gateway gets a reply from the reply queue, it needs to pass that message on to a reply channel. So we're going to go ahead and connect our outbound gateway to the reply channel. And we have defined a reply channel in our configuration below. And now we can connect that reply channel to another service activator. So I'm simply going to copy our existing service activator, and I'm going to make a new method, print console, that will get invoked. And I'll need to put that on our message printer bean. So let's just make a new method, returns void. We'll name it print console. And then we'll accept a type of message. And then within the body of this method, we're just going to say that the message was passed. So let's say message was passed to print console from the outbound gateway, just so we can kind of see the flow of our messaging system here. And then what we'll do from here, we're going to print out the message. Okay, so with that in place, I'm going to return to the integration context.xml file, and we're just going to walk through this one more time. And actually, before we do that, make sure that we have connected our service activator to the reply channel. So we'll start from the beginning. We fire off a person object and use it to invoke the save method. So we pass the person object to the save method, and that is our gateway that we've specified within the integration context.xml file. So when that save method is invoked on this gateway, it is going to pass that person object as the payload of a message to an object-to-string transformer. This component will invoke the toString method on our person object and make that string payload the body of a message. From there, it's going to place that message on the outbound channel, which gets delivered to our outbound gateway. The outbound gateway component passes this message to the sample.queue queue on our ActiveMQ server. The ActiveMQ server receives the message, and upon receiving the message, it is going to notify the inbound gateway, which is going to receive the message and pass it to our JMS channel. The JMS channel is going to drop the message with the message printer bean because we have our service activator configured. It will then invoke the print method, which is going to return this new message that contains this string as the payload. That goes back to the reply queue, which is being monitored by the outbound gateway. So the reply queue delivers the message to the outbound gateway, which then delivers that message to the reply channel, which is connected to another service activator that is designed to invoke the print console method, which simply prints out some output to the console and then prints the message. And I'm actually going to remove this printing of our message within the print method so that we don't get confused. So let's go ahead and save the message printer, and we're now ready to run our application. So I'm just going to kick off the application, and then we'll take a look at our console and inspect the output. So here we see that we receive the message on our outbound gateway. So it fired off that message to ActiveMQ and it was processed there. And then this is the message being received on the outbound gateway that then gets passed to our message system. And there you can see the payload is that string that we created when working the ActiveMQ queue with our inbound gateway. So it's a little bit complex. Take a look at the integration context.xml file if you still have questions, and think about the previous lessons where we learned about the purpose of the inbound gateway and then the new content that we added with this lesson regarding the outbound gateway and its behavior. So we learned how to use an outbound gateway to send a message to an ActiveMQ or JMS server, and then how to get the response after that message is processed and placed upon a reply queue. In this chapter, we'll focus on Spring Integration's HTTP support. Within Spring Integration, HTTP support provides a number of adapters and gateways that allow our applications to integrate with resources such as REST APIs. A lot of REST APIs use HTTP as the underlying protocol, so this support comes in very handy. Let's take a closer look at our chapter. Within the chapter, we will explore the HTTP namespace, which is going to provide a number of components that allow us to achieve integration via HTTP. As with our other integrations, the components we're going to rely upon are going to be channel adapters and gateways. We'll take a look at two types of inbound components. We'll see an inbound channel adapter and an inbound gateway. And both of these components allow our applications to consume and process HTTP traffic or HTTP messages. We'll then see two other components, an HTTP outbound channel adapter as well as an HTTP gateway that allows us to send HTTP traffic from our application. And all of these components will integrate with Spring Integration's messaging system. By the time we are finished with this chapter, you will have an understanding of how to integrate your Spring integration applications with HTTP resources such as REST APIs. In this lesson, we'll cover Spring Integration's HTTP Inbound Channel Adapter. This component within Spring Integration's HTTP namespace provides one-way communication for inbound HTTP traffic. The HTTP Inbound Channel Adapter allows our Spring Integration applications to receive HTTP requests, which are then converted to messages that are passed downstream in the messaging system for further processing. Let's get started with a simple example. Within our pom.xml file, we'll need to add some dependencies to support our HTTP integration. To do this, we're going to click on Add, and then we're going to look within the org.springframework.integration group ID, and within this group ID, we're going to find the spring-integration-http dependency. So we can go ahead and add that dependency to our project, and then we also need to add a dependency from the org.springframework.boot group ID, and this dependency is going to be the web dependency. So we want to use the starter POM for all of Spring's web support. And if we save our pom.xml file, we can take a quick look at our dependency hierarchy. And one of the important things to notice is that we're going to get the embedded Tomcat server. And that's really how we're going to support a lot of these HTTP requests. Without some sort of embedded server to handle these requests, our functionality would not work. So with our pom.xml squared away, I will now open the integration context.xml file, and within this file we are going to provide the configuration for all of our different components within our messaging flow. But first we need to add in the namespaces to support the integration namespace as well as the HTTP namespace. So go ahead and make sure those options are selected. I'm going to actually remove the file namespace just to take away some clutter, make sure the HTTP namespace is in there, and then we can return back to our source for this configuration file. Now the first thing we'll put in place is the inbound channel adapter, and we see our HTTP namespace there. And there's several components we can select in order to perform different types of integrations with HTTP. In our case, we're simply going to have one-way inbound HTTP traffic. So we're going to use the inbound channel adapter. And within this adapter, there are several attributes that we need to specify. The first we need to specify is the path. So this is simply the URL that our inbound channel adapter is mapped to. So you're starting basically from the context root, and let's say we had something like files and then file X. You would map that URL to this inbound channel adapter. Just to keep things simple, I'm going to map to the root of our domain. Next, you can specify the methods that this adapter will support. In our case, I'm only going to support the GET method, so that's the type of HTTP request that we'll support with this adapter. And then finally, we need to specify a channel. So when our adapter receives HTTP traffic, it's going to create a message based upon that request, and it's going to place that message onto a channel. And in our case, we're just going to call it the HTTP channel. From there, the message will be delivered downstream, but we'll first need to put that channel in place. So there's the HTTP channel we just built, and now we need to send it somewhere. So if we take a look at our com.o'reilly.integration package, you'll see that we have the print console method within the message printer, and this simply prints out some output to the console and then prints the message out. And we'll be using this class defined as a bean, so we'll make it a bean, the message printer bean, and then we need to add an ID. I'll call it the printer, and we'll use that in collaboration with the service activator to print out the messages that we receive. So there's our printer bean that we want to refer to. We need to connect our service activator to the channel. So let's set the input channel, and that's the HTTP channel. And then we need to point to the method on that bean that we want to invoke, and that's the print console method. Okay, so we have everything set up here, and what's going to happen, we're going to receive HTTP traffic at our path, which is just the root of our domain. We're going to turn that traffic into a message, pass it to the channel. The channel is going to deliver it to the service activator where the message will be printed. So at this point, let's kick off our application, and we can watch it start up on the console. Okay, so we see that our application has now started. At this point, I'm going to navigate to a browser, and I'm just going to fire a request at localhost 8080, and let's add a parameter on there too. So let's say header1 is equal to value1, and now we send that request to the server. And if we take a look at our console output, you can see we did indeed receive that request. We turned it into this generic message. Take a look at the payload. The payload contains the parameters that were sent with that message, and then we also get several HTTP specific parameters. So there you see like the connection keep alive, the type of encoding that will be accepted. There's the browser that was used to create the request. So you see a lot of HTTP specific headers that are mapped to that message. So in this lesson, we learned how to use an HTTP inbound channel adapter to receive inbound HTTP requests and handle them using our Spring Integration application's messaging system. This lesson, we'll take a look at the HTTP Inbound Gateway. The HTTP Inbound Gateway is much like the HTTP Inbound Channel Adapter in the fact that it is going to take in HTTP requests and pass the request on as a message for processing within the Spring Integration message system. The difference is that the gateway allows for two-way communication. So now we're going to be able to send a response back to whatever system has sent us the HTTP request. So we'll start out by modifying our integration context.xml file. And to do that, we're going to look within the HTTP namespace and add the inbound gateway. And you'll see that we are asked to specify a request channel. In our case, we will use the HTTP channel. So this is the channel that will receive the messages that we create based upon those HTTP requests. Like the adapter, the gateway also has the supported methods attribute, and we're going to specify that as get once again. We'll also see that we need to provide a path on the inbound gateway. So we'll map to the same path as our channel adapter, and then at this point I'm going to remove our channel adapter since it's no longer needed. The gateway is established. Now there's a number of other attributes that we can specify. There's ways that you can dictate the reply channel. So once we pass this message off to the request channel, something is going to process it and then send back the reply message. and we can configure that reply channel explicitly, or an anonymous channel can be defined for us by Spring integration. So there's all sorts of different configuration changes we can put on the inbound gateway. We're going to keep it simple for our demonstration and basically just fire off our messages to the message printer. Now, one of the things we will do is switch the method that we are using on the message printer, because the print console method does not return any reply message. So if we take a look at the message printer object, here we see that we have the message printer and it is returning a string, and that's going to become the payload of the message that we return. So let's kick off our application, and if we take a look at the console, we see that it is now started up, and now we can go to our browser and let's once again fire off a message at localhost 8080, and there you can see that we got a message returned to the browser which corresponds with the text that we find within our message printer. So we know that our HTTP inbound gateway received the request, sent it off for processing, and then sent that reply message back to the browser. So we learned how to configure an inbound gateway to enable two-way HTTP communication. In this lesson, we will be working with Spring Integration's HTTP Outbound Channel Adapter. The Outbound Channel Adapter allows us to send HTTP requests from our Spring Integration application based upon messages received from the messaging system. The component provides one-way communication with HTTP, so we will only be sending out the HTTP requests from the HTTP Outbound Channel Adapter, and we won't be receiving any sort of reply other than something like a 200 message. So this is an outbound component, and in order to work with an outbound component, we need to be sending messages to it. So we're going to create a new gateway, and we'll name it Simple Gateway, and we'll place it within the com.o'reilly.integration package. This gateway is going to have a single method named execute, which returns a string and accepts a string as an argument. So we build this gateway, and now we can start to build the message flow that's going to deliver messages to our outbound channel adapter. So we use the integration namespace to create a new gateway, and the service interface that we specify for this gateway is our newly created Simple Gateway. And now we need to supply a default request channel. Make sure you pick the request channel and not the reply channel. That can often be a source of confusion. So the channel that's going to receive messages from the gateway is going to be the HTTP outbound channel. Now you'll notice that we do not have that channel quite yet, so let's go ahead and put it in place. We'll use the integration namespace to build out a new channel named HTTP Outbound. And now that that channel's in place, we can connect that channel to an outbound channel adapter. So we just put in place the message flow that's going to deliver messages to the outbound channel adapter. So the gateway is going to receive a message, it's going to place it on the HTTP outbound channel, and then we're going to have that channel deliver messages to the outbound channel adapter. And the channel argument is used to specify the channel that delivers those messages. The next thing that we configure on the outbound channel adapter is the method. So we're saying that when we send out the HTTP request, based upon the message we receive, we want that HTTP request to be of type GET. Next, we can specify the URL attribute, and this is where we will actually send our HTTP request. In our case, we're just going to fire it against our inbound gateway. So here you see I'm specifying localhost at port 8080, and if we take a look within our configuration file, we'll see that our inbound gateway is set up to service those requests going to our server that are at the context route. So the HTTP outbound channel adapter is going to fire off a request, which will then be processed by our inbound gateway. In order to get some visibility of this process, we're going to modify our message printer, just to add a little bit of debugging so we can see this process in action. So let's just print out to the console, and we'll say message printer is working the message. And at this point, now when the inbound gateway receives the message from the outbound channel adapter, it's going to start processing that HTTP request, and eventually it drops the message on the HTTP channel, and it gets processed by our printer bean. And that printer bean is of type message printer, and we just modified the print method, which will be invoked, to give us some console output so we have some visibility into this message flow. So with our messaging systems set up to pass messages to the outbound channel adapter, we'll next need to modify our Spring integration application. So the first thing that we'll do is we will implement the application runner interface. And this allows us to add a run method to our application which can perform some logic. Now within that run method, we're going to be working with our simple gateway. So I'm going to auto wire that gateway into our application. And then within the run method, we can use the gateway to invoke the execute method, and we can just say any old string gets passed here. One of the things within Spring integration, you can never send a message from a gateway without that gateway method having an argument or accepting an argument. So it's just something to keep in mind. Anytime you want to send a message from a gateway, you have to have an argument. In our case, the argument really doesn't mean anything. Okay, so with this configuration in place, let's go ahead and launch the application. And now we can see our console output. So there we see the server starting. And once our server gets started, we have the inbound gateway listening, and it receives the message, which is sent by our outbound channel adapter. And there we get the output that says the message printer is working the message. And that's an indicator that our outbound channel adapter fired off an HTTP request that was then received by our inbound gateway. And the focus of this lesson is using that outbound channel adapter to send a one-way HTTP request to some other external system. Now, in our case, we just leveraged some existing infrastructure to handle that request. Normally, this would be pointing to some external system. In this lesson, we'll cover Spring Integration's HTTP Outbound Gateway. This component allows us to send HTTP requests from our application similar to the HTTP outbound channel adapter. The big difference is that the gateway allows for two-way communication. So once we send out that request, we're now going to get a response. And the gateway is capable of passing that response on to our messaging system. In order to establish our new HTTP outbound gateway, we're going to be working within our integration context.xml file. We'll see that we already have an outbound channel adapter set up. Eventually, we're going to be removing that adapter. But first, we'll work within the HTTP namespace to add the outbound gateway. Now, if we take a look at the attributes on the outbound gateway, we're going to first find a request channel. And this is the channel that's going to deliver messages to the gateway for delivery to an external HTTP server. So we're going to be delivering those messages via the HTTP outbound channel. Next, we need to specify the URL that we would like to send these HTTP requests to. And in our case, we're once again going to be leveraging our inbound gateway, which we have configured below. Next, we need to take a look at the method that we would like to use in order to send our HTTP requests. We're going to be using the GET method. And then finally, we need to set up a reply channel. And the reply channel is where we will drop the response message. So the way the gateway works is we get a message in from the HTTP outbound channel, and then we send that message as an HTTP GET request to the local host on port 8080. It then returns a response. The response becomes a message in itself and is passed to a reply channel. So we're going to make a new channel, HTTP reply. And with this configuration in place, we can remove our outbound channel adapter. And now we need to set up the reply channel. So where the reply channel is going to deliver these messages as well as the reply channel itself. And a quick way we can do this, we're just going to duplicate these last three elements. So the channel, the message printer, and the service activator. So here I'm just going to make a channel, HTTP reply, and then I'm going to make a second printer bean. Then finally, we will set the service activator to look at our second printer bean, and we're going to have the service activator invoke the print console method. And if we take a look at the message printer, we see that the print console method is going to accept a message, write some output to the console, and then print the message. So let's go back to our integration context.xml file, and now there's one final change we need to make to our configuration. We need to switch our service activator to receive messages from the HTTP reply channel. At this point, we're ready to run our demonstration, so we'll navigate to the Spring integration application and launch the application, and then we can take a look at our console. You'll notice that the message was passed to our print console method, and you'll also see the output that we get from our inbound gateway processing the message. So we were able to send an HTTP request from our outbound gateway in response to receiving a message, and that HTTP request was processed by our inbound gateway, and then we received that response back and passed it to our reply channel for further processing. That reply message eventually reached our service activator and was printed to the console via the message printer. XML payloads are extremely common when integrating applications. So in this chapter, we are going to focus on some of the tools that Spring Integration provides for working with XML message payloads. Let's discuss some of the objectives for this chapter. To help us work with XML, Spring Integration provides a namespace. Throughout the chapter, we'll focus on a few components available within the namespace that can help us meet our application's needs. Many of the components within the namespace rely upon XPath. XPath is a simple syntax used to navigate XML. XPath allows us to specify expressions which reference particular sections of an XML document. We can also evaluate XML segments to derive a value. For example, I can count how many times a particular element is present within an XML snippet. As we learn how to use the XML support, we'll commonly be using XPath. One of the components that will use an XPath expression is our transformer. So we will see an XPath transformer that allows us to modify the payload of a message containing XML. We'll also take a look at how we can use XPath to derive a header value from a message. So we're able to provide some expression that is able to then be added to the header of the message that we are sending on the message system. So for example, maybe there is an important element that has a unique ID that is relevant to the data we're sending. And maybe we want that unique ID to be placed within the header. Well, we can use XPath to reference the element containing that ID, grab the value, and then place that within the headers for our message. We'll also see how to split our message payloads using XPath. So we can split an XML payload, and from that split, we're going to get multiple messages. And those now separated messages will then be sent further down the message flow. We'll also take a look at how we can filter our XML messages. So we can use XPath to evaluate a particular element value, and based upon the evaluation, we can determine whether or not to allow a message to continue to flow through the messaging system. Using the components within Spring Integration's XML namespace will allow you to take control of your applications that are using XML. We'll see a lot of great tools that are going to help you build out XML-based applications within this chapter. In this lesson, we will learn how to use Spring Integration's XML namespace to modify XML payloads of a message. Using the XPath transformer within the namespace, we will accept a message and then modify that message based upon some XPath expression. Once the message is modified, we will then place it on an outbound channel. Now, before we get started with our demonstration, I want to take a look at our project and some of the pieces that have been put in place in order to enable our work with XML. So looking within the Spring Integration application class, the first thing you'll notice is that we have added a field named XML, and it's of type string. And the value of this string is a small XML snippet. It contains a root tag of people, and within the people tag are person tags. And each person tag defines the first and last name of a person. Now looking closer within this class, you'll see that we pass our XML string, which is used for all of our demonstrations in this chapter, to our execute method on our gateway. And if we take a quick look at the integration context.xml file, you'll find a simple message flow established that has a gateway accepting a message, passing it to an XML channel, and then that XML channel delivering that message to a service activator that will cause the message to be printed to our console. Within this flow, we will interject our XPath transformer. If we take a close look at the integration context.xml file, you'll find that the namespace for XML has been enabled. So there within the namespaces, we see the int-xml namespace available. And that namespace will provide us access to all of the XML components within Spring Integration. Now, in order to get that namespace and those components, we need to have the spring-integration-xml dependency established within our pom.xml file. You will find this dependency within the org.springframework.integration group. So you can add this artifact much like we've added every other artifact within this course. Now, turning to our demonstration of the XPath transformer, we're going to navigate to the source tab of our integration context.xml file. And the first thing we're going to do is we're going to put two channels in place. So we're going to have an XML input channel as well as an XML output channel. I'm going to reconfigure our gateway to accept messages from the XML input channel, and I'm going to reconfigure our service activator to accept messages from the XML output channel. Now, with those channels in place, I can define the XML Xpath Transformer. So looking within the XML namespace, we see the Xpath Transformer. And if we take a close look at this element, we will see some pretty familiar attributes. The first is going to be an input channel, and you can probably guess that's going to be XML input, and then we need to define an output channel. And once again, you can probably guess that's going to be XML output. Now here's the important piece, and that is our XPath expression. So to define the XPath expression, we can use the XPath expression attribute. And here we just define some valid XPath expression. So in our case, we're going to start from the root. We're going to look in the people elements, and we're going to grab the first person, and we're going to return their first name. So let's save our integration context.xml file, and let's examine our XML to see if we can predict what the new payload of our message will be. So looking within our XML, we're first going to navigate to the people tag, then drop down into the first person tag, and then we're going to grab the value of the first name tag. So we should see Kevin returned to our console. So with all this configuration in place, let's go ahead, make sure everything is saved, and then we'll kick off our application. After I launch our application, I'm going to take a look at the console, and here we can see the output. And there we see that we sent a message to our service activator, and if we inspect the payload of that message, we see that it was Kevin. And that is definitely different than our initial XML payload. So we were able to transform our message, which contained an XML payload, using an XPath transformer. In this lesson, we'll take a look at Spring Integration's Xpath Header Enricher. This component within the Spring Integration namespace allows us to add headers to a message based upon an XPath expression. Let's run through a quick demonstration of this feature. So we'll be working within the integration context.xml file, and we're going to go ahead and remove our transformer. After removing the transformer, we'll take a look at the XML namespace, and within the namespace, we will find the header enricher. So we'll go ahead and place that element within our configuration file. Next, we'll need to specify some attributes on the XPath header. So we're going to go ahead and set the input channel, and we're going to set that input channel to XML input. So this is the channel that will deliver our messages. And then we're going to set an output channel, and we're going to set that to XML output. And that is the channel where we will place the enriched message. Now, it's a little bit different when working with the header enricher. Inside of the body of the tag, we're going to go ahead and add a header tag. And here we're going to specify the name of the header that we would like to add. So in our case, we're going to add a record count header. And then if we take a look at the available attributes, we will notice the XPath expression. And here we can specify an XPath expression that will set the value of the header. So in our case, we're going to invoke the count function, and we're going to tell XPath to count the number of person elements within our XML snippet. So I can now save this file. And what will happen is that our XML snippet within the Spring integration application will be passed to our gateway, which then is passed off to our header enricher. And on that message, we're going to add a record count header. and it's going to contain the value of our XPath expression. We then pass that message to our service activator and it gets printed to the console. So with that in place, we can fire off our application, and it looks like I accidentally put a C there. So we'll just go ahead, save, and then check out our console. And here we see our new message that has the new header added to it. So if we take a look, here we see the headers of the message, and we're starting to take a look at those headers, and eventually we will get to the record count, and there we see that it counted 2 person elements within the people tag. So our header enricher successfully added the header based upon what we configured within the header tag inside the XPath header enricher tag. So we took a look at Spring Integration's XPath header enricher and saw how we can use it to enrich our messages with new headers. In this lesson, we'll take a look at another component within the XML namespace, the XPath Splitter. Using the XPath Splitter, we can specify an XPath expression that will be used to split a single message into multiple messages. These multiple messages will then be sent downstream within our message flow. To get started with the splitter, we're going to be working within the integration context.xml file. And the first thing we'll do is remove the header enricher, and then we're going to use the XML namespace, and within that namespace we're going to find our XPath splitter. With that element in place, we need to specify some pretty familiar attributes by now. And the first is the input channel, and that's going to be XML input. The second is the output channel, and that's going to be XML output. Those are the only 2 attributes that we must specify for our example. Now within the body of the splitter, we're going to see that we can specify an XPath expression tag. And this is very similar to how we specified the expression for the header enricher, but we don't need to provide like a name attribute here. We just provide the expression that will be used to split our XML payload. So just for a refresher, if we take a look at that XML snippet, we see we have the people tag, and then within people we have person tags. And that's exactly what we're going to split on. So we just need to provide the appropriate XPath expression, and this one's pretty simple. We're going to start from the root, and then we're going to split at that person element. And we just go ahead and put that in place. And now what we should see is that when we invoke our method on the gateway and pass it our XML payload, that payload will be delivered to the splitter via a message on the XML input channel, and then our splitter will split the message, and we will have 2 messages at this point, and both will be sent to the output channel to be printed to our console by our service activator. So now we can navigate to the Spring Integration Application class, and we're going to kick off our application, and we'll take a look at our console to see our output. And as we expected, we now see 2 messages that were sent to the print console method. And if we take a look, we can see that the split did occur at that person tag, and we now have a message for each person element within our XML snippet. And this was all thanks to the XPath splitter and the expression that we provided to it. So this concludes our lesson on another component within the XML namespace, the XPath splitter. Spring Integration's XML namespace also provides us with an Xpath filter. In this lesson, we will use the filter to choose which messages should be allowed to proceed within our message flow. Let's get started with a simple demonstration. Within the integration context.xml file, we're going to add a new channel, and this channel is going to be named XML Filter. And then we are going to add the filter by using the XML namespace. So we see the Xpath Filter, and within this filter, we're going to connect it to the XML output channel. So we're going to receive the messages sent by our splitter, and we're going to apply our filter to those messages. Once we have filtered those messages, we will then pass the messages to the XML filter channel, and we will then configure our printer to receive the messages from our filter channel. Now, the only thing left that we have to specify for our filter is the XPath expression. So we can leverage our IntelliSense and add the XPath expression element, and then we simply need to provide an expression. In our case, we're going to take a look at the first name element within our XML, and we're going to check that the first name is equal to Kevin. And that is how we will determine whether or not a message is allowed to proceed to the output channel for further processing. So with this in place, we can navigate to the Spring integration application, and we can kick off our application, and we should only see one message now, and that message should correspond with the XML snippet that contains a person with the first name of Kevin. And if we take a look at our message, we see that the payload does indeed contain the expected XML snippet. So within this lesson, we were able to put in place an XPath filter, and that allowed us to inspect the XML payload of a message and make some determination using an XPath expression about whether or not this message should proceed further on in our message flow. Well, this is it, the final lesson. Congratulations for making it through our course. Let's take some time to recap what we learned and talk a little bit about what's ahead. Obviously, we covered a lot of technical material, but there should be some larger concepts about Spring integration that you take away from this course. We learned that Spring integration is an exciting and effective way to exchange data between systems. Using the framework, we can conform all of our application's external data exchanges to one flexible approach. Central to this approach is the messaging system. The messaging system provides us with an architecture that abstracts how data is sent between application components. The messaging system also connects endpoints that perform external communications to our underlying application. The framework provides support for multiple approaches of exchanging data between systems. We can leverage approaches such as file transfers, JDBC access, HTTP web services, and a variety of others. We did not cover every approach within the course because it wouldn't be a good use of your time. However, we did hit some of the most common approaches as discussed in the Integrations Patterns textbook. Spring integration was built upon many existing Spring projects. For example, when performing HTTP integrations, we were relying upon Spring's MVC support within the Spring core. Be mindful of this relationship between Spring integration and other Spring projects. Keeping these key concepts in mind will ensure your success with Spring integration. So with another tool in your toolbox, it's time to look ahead. Where do we go from here? If you have taken my past courses, you will know that I am a huge advocate for rolling up your sleeves and writing code. You don't need a reason to write code, just do it for the practice. So get out there and build something with Spring integration. Who knows what you might develop? At the same time, you need to keep putting tools in your belt. One of the best toolboxes available to a Java developer is the Spring ecosystem. There are some amazing projects out there right now within Spring's portfolio. Projects such as Spring AMQP, Spring Social, and the aspect-oriented programming support are great new areas to learn. When learning a new technology, nothing is more key to your success than your attitude and the resources you select to learn the material. In fact, even with the right attitude, it might be impossible to learn with the wrong resource. My previous courses have covered things like Spring Core, Spring Data, Spring Security, and Spring MVC. If you haven't taken them, this might be another great way to expand your knowledge within the Spring ecosystem. And finally, before we conclude the course, I want to take a moment and say thank you for watching and working through this course. It's folks like you that allow me to produce these courses, and I really take a lot away from it and hope that you have enjoyed learning about some of the things that I have learned through the years about Spring integration.